Good morning, ladies and gentlemen. Let me welcome you on our second day of the conference. Today our agenda is again pretty packed, so please let's start on time. All the coffee breaks and lunch will take place at the same location as yesterday. For today, I would like to especially remind you to fill in the evaluation forms. Please rate our speakers, the organization, and also suggestions for next year edition. You can suggest the location, topics, etc. Now, without further ado, again, I'm gonna give the floor to Jakub, our chairman. Thank you, and enjoy the second day of the conference.
Thank you. Good morning, everybody. I'm happy to see that we've been joined by a few more people today, and I'm particularly happy that some of those that were here yesterday came back. And then there is René van Kessel. You'll get that later today. Yeah. Good. So I don't want to delay. We'll get started because, like Teresa said, we have a packed agenda. So if you don't mind, we'll kick off a couple minutes early. Yeah? All good? Good. But then our first speaker will be Dr. Roland Damping Zheng, lead DC and offshore cables at TenneT.
It's my great pleasure today and give a short presentation and with the title, The Driving Energy Transition from the Perspective of an European TSO. Of course, safety first. I think we know where is our emergency exit and also assembling point. Yeah. There are following parts in my presentation. Firstly, yesterday my colleagues mentioned there is splitting between the German TenneT and the Dutch TenneT. I will give a short introduction of TenneT Germany, and then talk a little about North Sea, our green powerhouse, and then TenneT offshore project, and the 2 gigawatt, and also the interconnectors, and some words about technologies, and then our experience and challenges, and short discussion and conclusion. TenneT Germany is part of TenneT Holding, is to separate business unit in comparison with our Dutch TenneT. And we have more than 5,000 employees. I think now it's 6,000 something. And one figure is I'm very proud of. Last year, we have 100% our grid availability. There's no minutes unplanned outage of our grid. And we have totally 13 offshore grid connection system. And in the next page, we can see and our project. We have almost 20 years offshore grid connections, wind power connections experience. So a lot of things we can see, but due to the time, of course, it's shortened here. And also there is the first step, and we used AC connection, and then we go to the DC 150, and then go to the 250, 320, 525 kV. And also from the grid connections, capacity is from very small 60 megawatt and to 200 megawatt, 400 megawatt, 800 megawatt, 900 megawatt, and then go to the 2 gigawatt. It's step by step. And if we talk about interconnector, please don't forget it's only offshore interconnectors. We have also onshore interconnectors. And for example, our Z-Link, Z-Link, 525 kV, 2 gigawatt each. This is also interconnector between the two different TSOs in Germany. And we are one of the 4 Yeah, for TSOs, because yesterday some colleagues mentioned there is also interconnector and also TSO. I cannot see it's only 4 TSOs now, but it's traditionally it's TSO, so we have only 4 TSO in Germany. Our purpose, our promise, I think if you know TENNET, I don't want to go more. And as TSO, our main task, firstly, is the transmission of electricity. You know, now we are in the age of electricity. And if you look at our international energy agencies, and till the 2035, there is demand of electricity will increase 40% by 40%. So firstly, we need to have one robust and high voltage power grid with efficiency. Of course, system service, and we maintain the safety and also keep the balance of 50 Hertz. And due to our situation, our grid situation, we are in the middle of Europe. It is just cross-link the Nordic countries and South European countries, east and west part. Of course, we facilitate efficient and stable electricity market. Our offshore future, we need international energy work. And here, firstly, is innovation. It's most important. And I would like to emphasize here, flexible international offshore network. And of course, we have some principles. Firstly, networking. Secondly, standardization. System integration. System integration means not only electricity's network, electrical network, we have also the hydrogen's network and international cooperation. I think yesterday this picture has shown by some colleagues. Look at here, we have different European countries and cooperated together, collaboration altogether. Yeah, European must act now is efficiently expand our offshore wind park, and especially our North Sea and the green powerhouse. Firstly, we need a smart, utilized space utilization. Yeah. The goal must be energy output instead of the capacity, installations capacity. We talk a lot about wind park and so on. It's just talk about installations capacity. It's not true. Of course, we need maximum grid utilization. And we built a lot of 2 gigawatts. Now we talk about how could we use our power link, HVDC, and also cables. How could we utilize such capacity? We talk not only 2 gigawatts, we now talk about 2.2 gigawatts without change the design. Of course, it means there's billions saving for our grid operators, also wind power operators. And at the end, of course, for all us electricity consumers. And we need also smart networking our interconnectors. Yeah. And increase the wind power's output and also fair cost distribution. Yeah, it means totally in world more energy and a lower cost for everyone. If you talk about offshore, of course, we need to connect it also our Dutch colleagues because we are totally for offshore. We still have the so-called cooperation agreement, and especially for 2 gigawatts, and we have already transmission capacities 12.2 gigawatts. Interconnector here is offshore interconnectors, of course not included here is interconnectors onshore. Totally, we have cable system length 2.8 thousand kilometers. If we talk about cable length, we need to double. And each link 205 kilometers, something like that. And of course, we have some target. And for 2031, we have already 19 offshore wind connectors. And until 2031, we need 20 more new connections to get total together, Dutch and German part. Yeah, I think this is clear. Yesterday, my colleagues have already shown this great connection. And 525 key cable system, we will use one bundle together, and together with our metallurgy churn, and also telecommunications cable together. And we can transmit more, and because in the Dutch, we standardize 700 megawatt, and in the Germany, 900 megawatt, and now we go together to the 2 gigawatt, and we have the framework contract with some supplier. And of course, our platform is also ready for this together with our partners, and we developed such standardized platform and also ready for the future and the multi-vendor HVDC platforms. And also our multi-terminals readiness we have developed together. And this new platform are planned for the multi-terminals readiness already. And they can also directly connect with our wind farms. And yesterday, Lion-Link's project has already saw this possibility. For the future, yeah, we are planning the first offshore hubs in both in Netherlands and also in Germany, such offshore hubs. And of course, the wind boosters concept we need also present, and in the future to expand our expansion of our offshore wind and also with meshed DC grids. And we are developing the European's first multi-terminals hub, and together in the Header area in Germany, and together with our 50 Hertz, another German TSO. Yeah, since we have already 20 years experience, and would like to give some our experience and challenges we have to face, and regarding especially for the cable engineering. First, about planning and permits, and for this one is production capacities expansion. It need to be also planned long term, especially for our cable suppliers. Second is regarding interface management. Although in comparison with our Dutch colleagues, we have less interface, because we use EPC and 2 main EPCs contract for the HVDC platform 1, another cable. But we have also different components and different contractors we need to deal with. Next one, especially for the cable engineering, we need to understanding the range approval. And the things that we know, and every PQ test is more than 1 year, tap test 2-3 months. We need also planned already ahead of our project. And furthermore, is of course is a lot of new facilities, the production facilities, and now is introduced. We need also have clear picture, and also I have to face in the last 20 years a lot of design change during the project development. So, of course, it lead to some tap tests and PQ tests. And production verification, we talk about 525 kV extruded cable, but we need to be aware there's no inch such cable in operation. And for a TSO, it's most important if there is no operation experience, we need to also deal with such topics very carefully. And if we introduce some new insulation material, of course, we need some industrial testing. For example, we need to produce 10-kilometer cable to test if there is suitable for the production. And also, QA, QC is the most important topic. And in Internet, we introduce the rules before we starting the cable manufacturing. We need to do the FEMECA. And in order to de-risk, and especially technical risk, to minimize the technical risk. Of course, cable transport, prepare cable installation, and all the things, I think is a typo. Yeah, plow is not fluke. In German word, plow. HDD, protection duct, trial operation, and trial barrier. And because we have also a lot of the new installations tools, and need also do such verification. Yeah, fiber optic cable damage during this installation, we always face such cases. And of course, we introduce so-called OTTRs and TTR monitoring during the installation. And RPP, repair pending plan, and service life agreement for the cable operation and maintenance need to be introduced. Cable monitoring topic, DTS, RTTR, DRS, online cable fault location, such things we need also. And also we need to think about decommissioning and recycling already in the planning phase. Yeah, as traditional TSO. And of course, technical measures grade is also one important topic. And we need to introduce innovation and digitalization. On the other side, we need to keep stable technology for the next 40 years. Reliability, availability, maintainability of a cable system is always very important. The first question, if we plan some project, we need to think about it. And the benchmark, I think I would like to mention here. 1,000 kilometer cable, 1 failure per year. Repair duration, I think yesterday someone talked about 1 month. It's not reasonable. And I think average 2 months. I think yesterday also some colleagues have already mentioned this 2 months figure for the repair. And if we have 4,000 kilometer cables, it means 4 failure per year, 8 months after each. If our shareholder or stakeholder can accept this availability, of course, it's possible. 1 year, 8 months after each. And furthermore, of course, our documentation is built, document system engineering BIM, trust control, keeps the balance, and we introduce production supervision, system availability and testing cables of fault. Not too much, not too less. Yeah. Also balance reliability, sustainability, affordability. I think the SF6 freeze solution, lead freeze solution, recycling of material, and so on, such topics need to be also think about. Some conclusion and discussion. Yesterday's interconnection or talk about, or here I would like to talk submarine cables plays an essential roles of energy transition, and also in the future energy suppliers system. And we need cooperation with all the stakeholders, transparent communication and early information to the users, and also our electricity consumers. Furthermore, its legal political framework is not only limited in one legislative period, long term. And of course, we need to drive our energy transition together, also for our next generation. Yeah, Thank you very much. This is my presentation.
Thank you. So, do we have questions from the audience? Do I need to do it again? Ah, again, it worked.
Thank you very much. Right, very interesting. Alex Newman from the Offshore Renewable Energy Catapult. Just a question about the voltage levels in the future and the capacities. You're at 2 gigawatts, you mentioned 2.2 gigawatts without changing design. Do you foresee much increase in that in the future, or do you think the 2 gigawatt connection is the maximum that is system comfortable?
Yes, if you talk about regarding this connection capacity and so on, we need to think about the stability of our European grid. And our limitation of our in-East grid is 3 gigawatt. And of course, we can go further, but I have to point out, it's not everywhere in the European grid we have 3 gigawatt. It's stability limit. Yeah, for example, we know the Spain will have the blackout there because there is not 3 gigawatt connection. Yeah, so. But I think the first step as TSO, I would like to keep our conservative little and to have gather some operations experience. Then we talk about go to the next step. Yeah. Thank you.
Do we have any more questions? We have one here. Could we get the microphone?
Good morning, Roland. Thank you for the presentation. And can you elaborate a little bit more about when you mentioned one failure per year for every 100-kilometer cable? Because as a cable manufacturer, of course, we're so focused on to the reliability of the system. From my point of view, I just try to understand a bit more about the cause, the root cause, what's the potential solutions. That's question number one. The question number two is, where do you see this, the area that can be improved the most, at least from maybe cable manufacturer point of view or cable installation point of view, where we should tackle the problem first?
I think regarding this benchmark, is 1,000 kilometer, one failure per year. This is from some leading cable manufacturers has published this figure.
Okay.
And this is only from the operation. And we know there's failure during the manufacturing, during the installation, during the trial operation. It's not in this figure. It's just operation figure. Regarding this, what could we do more better is from the manufacturers, I think, is open communication is most important. And if you have some failures, please communication with your end user, transparent, and we try to find the solution. Don't try to hide the failure, because anyway, we will realize such things. And of course, QA, QC, this is most important, and also attitude is most important. Yeah.
Thank you.
Thank you very much. Yeah, thank you.
More questions? Do we have any other questions? Oh, right next.
Yeah, hi. It's Keith Netting from Becker. Do you see any space at all for alternative submarine cable technologies, like the sort of so-called superconducting cables?
I don't 100% understand your question. Alternative technology of the submarine cable, what it means? You mean the dry, semi-dry, wide, or what is exactly this? Yeah.
Yeah. No, sorry. I was meaning the superconducting type technology. Superconducting technology.
Superconducting technology. Okay. Yeah. As a TSO, so I have to see the operations cost is too much in comparison with our traditional extruded MI cables and in comparison with superconductive cables. And of course, if the price and operation price, I mean the TOTEX, in the future could be reduced dramatically, of course, as TSO, we would like to go there. Yeah. Yeah.
Perfect. Then, thank you very much for your presentation.
Yeah.
and we will move on. We have a slight change in the agenda. Claire, who was supposed to be presenting, will be replaced by John Rotsley, Executive Director at European Subsea Cable Association. John.
Okay. Thank you, and thank you for having me this morning. And I'm standing in, like you said, for Claire. So I'm going to talk about improving coordination and offshore liaison and how we can all work together. My name's John Rottersley, and I'm the Executive Director for the European Subsea Cables Association. So just as a bit of an introduction to ESCA, we were established in 1999 as the UK CPC. And in 2016 became ESCA to reflect the fact that many of our cables connected different locations across Europe. We had a lot of European members and interests across boundaries and maritime boundaries to represent as well. So we are made up of cable owners, companies who own, operate or service subsea cables in European geographic waters. So we have vessel operators, cable owners, supply chain consultants, and government members as well. So the principal aims of ESCA are looking after physical protection, so resilience and security, and maritime safety as well. So we operate the Kiss Orca project, which lets other sea users know where submarine cables are. So to begin with, I think it's safe to say that the sea and the seabed are getting busier. We're seeing all sorts of increased uses, new cables, offshore wind, carbon capture and storage, new marine aggregate extraction sites. And this is all in the context of increased environmental protections, new marine protected areas, and a desire for improved marine spatial planning all across Europe. We, of course, have fishing activity and our colleagues in the fishing industry to liaise with as well. And then the concerns around security, which I know has been covered quite a lot in the session yesterday and later today. So I won't talk about that in too much detail, but is obviously a pressing issue for the organisation. So the implications for cables are, of course, posing routing challenges, and also some of the considerations for assessment for projects. So on a project basis, this can make it much more complicated for assessing new routes and also working together with other sea users. And I thought our colleague's presentation just previously talked about the importance of communication between all sectors and across different sectors, as well as within the sectors that we operate within, which I think is a really key point that we're picking up here. Of course, one of the key challenges, there's continued barriers to access for repair activities. And one thing that we have seen is that even though the response times are improving for cable repair, actually some of the challenges and barriers to repair are increasing. And this can be for a range of regulatory factors. It can be requirements looking at cable protection measures, and looking at these is a key priority for the organisation. And then, of course, I will talk a little bit later in the presentation about the requirements for evidence and how we can improve and streamline consenting by improving the evidence base there. So government provides direction and regulation, and of course industry must help to shape those solutions. And what I mean by this is, even though government policy is looking at seabed management, marine spatial planning, it's vital to have the technical expertise from industry to help shape that policy and make sure that it's meaningful and workable in the long term. So we've got various policy initiatives. There's marine spatial plans across the EU, and also the marine delivery route map from the Crown Estate in the UK, which is looking at how different activities can work together. And some of these look at prioritisation of different activities, and that's maybe something that's going to come in the future when there is less and less space. Of course, there's the European Commission's Cable Security Action Plan, which is focused on telecommunications cables, but we'll see initiatives on power cables as well, moving forward into the future on this as well. Then there's licensing reform efforts, there's improving consenting and removing barriers for consenting, which are being worked on by UK government, and there's initiatives across Europe and different legislative policies which are looking at prioritising and developing the seabed for offshore wind. But this, of course, creates challenges for other types of cables, interconnectors, power cables, telecoms cables, and all of the other marine industries who are interacting in the same marine space. And again, this is all in the context of strengthened environmental requirements. So without technical input, policymakers will struggle to make rules and regulations which actually work and promote and allow new investment and new cable routes to be installed. And industry groups can support these collective efforts, and I'll talk about a few of these in a little bit. So some good examples of cross-industry collaboration. In the UK, there's the Seabed User Developer Group, and this brings together all of the major marine industries with the exception of fishing, aquaculture and shipping, because they're regulated slightly differently. But all of the major industries which are regulated in the same way come together and is a coalition of major marine sectors. So it's an association of associations. There's 10 members of the organisation, but when it speaks with consensus. So of course the messages which can be shared with policymakers and governments are then quite powerful. The focus really is on sustainable development, marine planning, streamlining consenting, and some of the things which can be improved there. But it brings together all of the different sectors with a common voice, and is a really good example of collaboration. And we might see some more initiatives like this emerging over the next few years. Fishing and offshore liaison with the fishing sector has always been a big consideration for the cable industry, and that's partly because of maritime safety, so ensuring that other sea users can operate safely around marine infrastructure, but also protecting subsea cables from damage from fishing activities. So we have the Kiss Orca project, which I've talked about already, and that has some emergency procedures in case vessels become snagged on a subsea cable. But it's important to make sure that information is shared so that vessel operators know what to do in these situations if they're in danger. There's also some good examples of fishing liaison practices which are being shared at the moment. So there's a guideline which is due for publication by ESCA talking about good fishing liaison for linear power and telecoms cables. And then the flow guidance is a fishing liaison offshore wind and wet renewables guidance, which is due for launch on Thursday next week, in fact. And there's proven success there in reducing conflict, improving safety, and lowering the risk of fault from other activities. And the same is to say for other sectors. If we're talking about anchor risk, then there's things which we can engage with the International Maritime Organization, engage with the shipping industry and others to reduce the risk of dragged anchors. So some examples of guidance and good practice. So ESCA publishes guidelines on various technical working practices. So we have guideline 6 on coexistence between offshore wind and submarine cables. Then we have guidance on crossings, RPL, minimum requirements, all sorts of other technical things which can help to shape industry practice. Then globally, there's the International Cable Protection Committee, which publishes recommendations. And this also provides good recommendations towards good practice around the world. It's important to note that they're not standards, they are recommendations, and this is to allow some flexibility for the global context. Other organisations also share technical guidance and experience, and then for policymakers in particular, to improve that technical understanding, we run subsea cable awareness workshops. And we've rolled these out across Ireland, in the UK and in Europe as well, to share information with those who are making the rules, to help them make better informed decisions when they're making decisions about cable routing, cable installation and assessment. So of course the benefits of this are we give some good certainty for planners and regulators. And also those technical constraints are built into the policy from the outset, so that you don't see policies which actually jeopardise or threaten resilience, and it's actually improving resilience and in turn cable security as well. And of course, hopefully, better informed decision making leads to streamlined consenting, improved response times, and fewer conflicts for installation and repair. So ESCA has some messages on policy, which we've been sharing recently with the European Commission, with the UK government and the Irish government as well. So we're looking at trying to promote focused and coherent subsea cable policy at a national, regional and international level. This is to harmonise, streamline and make sure that the understanding of industry is built into these policy initiatives which are happening all around the world. So in order to do that, one of the things that we see is conflict between policy. So you could have environmental policy which actually impacts cable routing in an inappropriate way. But if there's champions within government for subsea cable policy specifically, they can then help to make sure that policy is developed in a coherent way, that they work together. So if you want to repair a cable, your vessel won't be delayed by a cabotage regime or a customs regime or something, because it will be built into the subsea cable policy itself. And then, of course, in terms of international law principles, promoting UNCLOS and avoiding jurisdictional overreach as well. So then we also recommend strengthening intergovernmental coordination. So, of course, projects cross boundaries. It's important that if there's a marine spatial plan in one jurisdiction, that it works together with the marine spatial plan in another jurisdiction. And this is particularly important for interconnectors and cables which cross international boundaries. And there needs to be that coordination at an intergovernmental level to make sure that works together. Developing strategies for managing competition at sea, so where there are different competing uses for a particular area of seabed, that it's understood how coexistence can take place. And this can also apply for marine protected areas, environmental designations, and understanding where there's compatibility between different designations and uses of the sea as well. So what we'd like to see is governments developing proportionate and predictable legislation or regulation which supports streamlined consenting and reduces that consenting risk as well. And then, of course, over the summer, ESCA and IMCA, the International Marine Contractors Association, published a joint statement about cable repair and deployment. And this talked about facilitating exemptions and policy for rapid repair response. So, of course, we know about the challenges of cable repair activities, but it's important that if there is the ability to respond quickly to a cable repair, then that is baked into the policy from the outset. Some of the other security measures, which I'm sure will be talked about later today, are looking at stress testing, emergency planning, and understanding what happens when there might be an emergency disruptive event that requires coordination between government and industry, and how that takes place. And then there's a lot of talk in the European Commission about funding, and looking at funding and investments. Where are those resources best focused? There was talk in the cable security action plan and the recommendation 779 about a fleet of cable ships in the EU. But actually, is that the best response? Are there other investment areas that could better serve resilience of the subsea cable ecosystem? And that's something that we engage with as well. So in terms of evidence and joint research, better evidence for things like environmental impacts leads to better, more proportionate policy. So, of course, if there's a lack of evidence, then regulators will take a precautionary approach. They'll assume that they need to have excessive assessments, that there need to be more measures in place. But actually, if we can show what the impacts are, then these can be dealt with in a more proportionate and more streamlined way. So some of the areas of research which are ongoing, which ESCA has been supporting, are on fibre sensing, rock placement, seabed stability, marine biodiversity, and then on EMF, we're about to publish a technical statement as well, which talks about some of the considerations on EMF to try to settle the conversation, which can be quite significant at times. So, of course, in terms of ESCA's role in that, we can support academic institutions and research partners, and that can lead to bigger investment funding amounts for research. But we also have observer status in OSPAR, which is the Oslo-Paris Convention looking at protection of the marine environment in northeast Europe. And so this is a key measure to look at environmental protections and marine biodiversity. And it brings together all of the contracting parties from OSPAR, which is most of the European member states, plus Norway, Iceland, the UK, a few others. So it's a very good way to collectively look at assessment of the marine environment and protection of the marine environment. So we really support that because it then filters down into domestic legislation and helps with that harmonisation piece I was talking about. So I think the message there is that a strong evidence base reduces unnecessary precaution and can support a more streamlined and better regulatory outcomes. And then, of course, one of our priorities is looking at the next generation of people needed for subsea cables and the subsea cable industry. There's many, or there are younger people who are less willing to work offshore. There's skills gaps across engineering, survey, permitting, and all of the resources that we need for the increase in investment in subsea cables. And of course, there's a competing demand for resources and offshore personnel from across different sectors, whether that be oil and gas, power cables, marine aggregates, and others. And we see that there is an ageing workforce and a limited pipeline of new entrants as well. So in response to this, ESCA has established the Next Generation Working Group. We've got 80 members within that working group from across all of the sectors that we represent: telecommunications, power, and offshore renewables. So the category for them to participate is to be under 30 or within their first 3 years within the sector. And that's to recognise that people reskill, might move between different careers, and so to give the opportunity for new entrants to gain some experience. It provides opportunity for networking, training. We run some technical workshops, some university outreach, and also provide opportunities for direct engagement with regulators. So it's looking at a good understanding of multi-coordination between sectors from early in their careers, so that they have a flavour of different areas and don't operate in silos. So why this joint action matters? Well, the skills challenge affects everybody, and it's a thing which is common across all marine sectors. It's recognised even in shipping that there's fewer people willing to work offshore. So making sure that we have those skilled personnel is absolutely vital. And that collective and training raises capability for everyone to make sure that there's a multi-skills which can be used. And I think that, yes, this just finally sums up in terms of collaboration and cooperation. This is one of the areas where industry really can work well together to build the next generation of people. So to summarise, of course, the seabed is becoming increasingly busy. Government action is growing, and a lot of that's in response to security concerns. But we try to reiterate that there's a lot of things in addition to security that governments need to take seriously that can also impact resilience, which then has a knock-on effect in security as well. So collaboration can reduce conflict and improve coexistence, and improved policy and regulation can help to support that, and that's something that we work on all the time. Some of the long-standing challenges remain. They can be about cable repair, about different policies which can affect cable deployment and other activities as well. And that's something which governments can really play catch-up. They've come to the attention has been raised on the topic of subsea cables from the security perspective, but there's more that they can now do to improve things which have been problems in the past as well. Evidence underpins proportionate regulation. I think that goes without saying. The more research and evidence that we can have, makes decision makers better informed to make decisions on regulation. And then people are key to future coordination. So that bringing in the next generation of skilled people is also vital for a thriving marine industries in the future. And I think that brings me to time. Thank you very much for listening.
Thank you very much. So, do we have questions for John? To warm up a little bit. Ah, there is one. Yeah.
Yes, good morning. Patrick André from ASN. Talking about the marine, sharing the marine space, you don't mention much about the oil and gas industry, which already has a pretty decent footprint in subsea. So how's working, coordinating security, managing the space with the oil and gas?
Yes, well, I think as part of the forums which we operate within, so the Seabed User Developer Group includes oil and gas industry and Offshore Energies UK. We work with the Energio Alliance and others to make sure that there's some coordination there between sectors. And that's providing links and opportunities for that cross-pollination. But I think one of the things we see in the conflicts between policy, which I was talking about, that oil and gas is regulated very differently to power cables, which are regulated differently to telecoms cables. And some of the departments responsible might be the same department, but might not have joined up messaging even within them. So there's a piece of work there to make sure that there's good cross-understanding. I mean, if we look at the UK or the North Sea context, it's the Department of Energy Security and Net Zero. But it's such a big department that you can have one part working in conflict to another part. And I think part of our responsibility as industry is to help to coordinate and improve that. So those policy champions I talked about within governments, or those single points of contact, can really help to improve that coordination piece there.
Perfect. Do we have more questions? We have one there.
Hi there. Thanks very much for the presentation. David Barber from Gridlink. I've got a question about out of service and historic cables. Obviously, there's a lot, particularly telecoms cables now as well, which need to be crossed and essentially need to be cut by new projects. One question, are you doing any work in that field about facilitating to make that process easier? And the second link question is for new projects. We probably all have an obligation to remove the cable at the end of its operational life, usually to make a financial commitment now during development or during construction operations for that. And are you doing any work in that field as well?
Yes to both. So I think on the first topic of out-of-service telecoms cables or legacy cables, of course the first telecoms cables were installed in the 1850s, so there's a lot of legacy telegraph, coaxial, fibre optic cable on the seabed. So through the International Cable Protection Committee, they publish a recommendation on how to manage those out-of-service interactions, but recognising that it's a cross-sectoral challenge, particularly with new uses of the seabed. They'll also send out notifications from other sectors to try to engage with the cable owners who might have responsibility for those cables over the longer term. So it means that you can, if you're planning to develop a wind farm, you can reach out to the industry forums who can then disseminate that message, because actually finding the responsible owner can be quite challenging at times. And on the second question on decommissioning, we're part of the decommissioning ICG in OSPAR, which is looking at updating the technical background documents from OSPAR on decommissioning and what their recommendations to their contracting parties or domestic governments are. And we see that as a really good vehicle to get a more harmonised approach to decommissioning across Europe, because there's different considerations on expectation for full removal, or whether there's a case-by-case consideration for partial removal, or infrastructure which is left behind. I think that's an ongoing discussion. I don't think there's any firm conclusions there as to how that would be managed. But within ESCA, again, in response to the hot topic, we have a decommissioning working group, which is working on that topic as well. Hopefully answers the question. Thanks.
Perfect. Thank you. We have another question there.
Hi, Narciso Lacerda from Subsea 7. You mentioned about workforce, how to bring the next generation in. That's a good topic. Appreciate it for bringing it. It has been not only for cables, but for all offshore industry has been a challenge. A lot has been talked as well about skills that can be transferred horizontally. You mentioned about the competition between oil and gas and cables, but also there is this other side about complementary skills and transferable skills. Is that anything that you guys have been looking how to promote so these people that is already in the market would be interested to migrate?
Yes, and there's challenges, of course, because, of course, if you train the next workforce or if companies train individuals, they don't necessarily want them to be poached by a different sector or taken away. But actually we see that by upskilling larger numbers of people, then that cross-pollination happens naturally, and that's a real positive. Because, of course, those skills from oil and gas might apply to offshore wind, might apply to telecoms, might apply to different offshore sectors as well. So I think generally we see a positive in increasing the skills across the board.
Thank you. Yeah.
Okay, then I will ask one more question from my side. So you mentioned we need governments also to adapt their policy and look at the research that is being done and listen to the technical advice. Do you believe that the governments we're working with now have the technical expertise and actually listen to that advice? One concern that I see is, you mentioned we should have, or the idea of having a fleet of repair vessels came up. Of course, it came up after something happened. And that's a pipeline burst or 3 telecom cables broke for some reason. And then suddenly we are reacting. Do we have the competence in governments to deal with this?
That's a very good question. So I would say the answer is partially. So I would say that the competence and the skills levels within governments, and particularly within the European Union and European Commission, is increasing, but certainly isn't there yet. As I was talking about some of the large government entities or regulatory entities, of course you might upskill and have skills within one part of that system, but then not within another, so they don't necessarily work together. And then, of course, we've seen in the Irish context the challenge of having an independent regulator, which is at arm's length from government. And I think as industry, we have a unique opportunity to be able to share messages across these government departments, regulators, and make sure that we try and upskill different areas. So we can identify the regulatory challenges and policy areas which cause difficulties for the industry, and then try and upskill those. So as I said, we run cable awareness workshops. We try to give some technical competence. We invite government members to the organisation as well. And I think it's that long-term, softer collaboration rather than the direct action, which is going to have the most meaningful improvements. Because like you say, you can see absurd consequences otherwise in a very reactionary way.
Exactly. And then we speak to people that don't necessarily understand the difference between a pipeline and a telecom cable and a power cable. So the more we can explain up front, the easier it will be. Perfect.
Of course.
But then, thank you very much for your presentation.
Thank you.
And please have a seat and we'll move on. So our next presenter will be a virtual one. I hope he is online. Yes? So the next presenter will be Daniele Caruso. He is an independent consultant. Daniele, we can see you. Can you see and hear us?
Yes, I can. I hope you can hear me.
Yes, perfect. But then the floor is yours.
Thanks a lot. Good morning, everyone, and welcome. My name is Daniele Caruso, and I'm the Italy Portfolio Director for Nodara in Italy for the Italian projects. And my presentation focuses a little bit on an emerging market, which is Italy, and how cables are playing and will be playing the role of being a backbone as well in this emerging geography, which has a lot to offer in terms of ambition. Who we are, Nodara is a developer working, having projects as well in both the UK, north of Scotland as part of Scotland, and in Italy, and is basically the result of the evolution of quite old-rooted company in Italy called Falk Renewables, or a century of industrial history in the Italian region, first starting with the steel industry and then renewables. And one of the main, it started as a family business, and it grew through the last century throughout the Industrial Revolution, post-war in Italy. Then, of course, Nodara is the result of the evolution of this, this heritage, and today is operating in renewables worldwide in general, like PV, onshore wind, predominantly in many countries in the world. But as of a matter of floating wind, is operating in mainly two countries, the UK as part of the ScotWind lease round, and in Italy, with two main front runners projects at the moment running through the consenting stage, Odra and Caelia. Quite large projects, approximately 1 gig and 1.1 gig. And they are active in designing, constructing, and managing this project as well. So, focus of my presentation today is how subsea cable will be playing key roles in Italy ambitions of growth, specifically within the floating market, but also what challenge this new geography faces to reach these targets. We will range from the ambition themselves, the solution for the seabed. I'll give you a glimpse of how the seabed looks like in Italy and nearby coastline, especially in the Med, if you will. Policy momentum to close out with some key risk and mitigation and forward outlook. Let's begin with floating wind ambitions in Italy. So as an emerging market, they have set approximately 10 gigawatt of installed offshore wind capacity to be achieved between 2030 and 2025. So as you can imagine, this is a very ambitious for an emerging country with a quite convoluted regulatory framework, and of course, a very, an absence of experience in floating wind installation and commissioning, as you would imagine, but also with only one nearshore bottom fixed project installed nearby Taranto, the so-called Beleolico. Therefore, it's great to see the ramp up of this scenario in an emerging country in the Med, especially across the Italian market, because it creates opportunities and potential.
Daniele, can
Yes?
I interrupt you for a second?
Of course.
Could you put your slides in presentation mode, please? Because we see the front page. Yeah.
Can you see my slide now?
Oh, we can see, now we can see the presenter view.
Okay.
So if you could switch in display settings, I believe you can switch screens.
Okay. Transition, display settings.
No. When you're presenting, if you go to presentation mode.
Okay. Yes. I am in presentation mode. Can you see it now?
We can still see the front slide. We see the PowerPoint window, not the presentation screen.
Okay. So perhaps, can you see me now moving the PowerPoint?
Yes, but on the small screen. So if you go to presentation now.
Okay, I'll just, which one is the presentation?
Or press F5 or.
F5, yes. I pressed F5, but nothing works. Apologies for this little hiccup. Okay, control presentation, sorry, here.
So we can see the agenda slide now, but not full screen, just
okay. So apologies for that. I'm trying to solve it, but when I'm going now in presentation mode, I don't know if can you see it now?
No. Maybe if you could share the other screen where the slides are showing, because we are seeing PowerPoint, the editing view.
So apologies for that. I will be trying to go with these. Sorry about that. Not sure why is it happening. I'm gonna try to. Okay, hopefully, I hope you can see it now. Can you see my slides?
No, it's still in the small view.
I am trying to share it like this. Can you see it now? Apologies.
Nothing is changing.
I don't know. I'm doing a few things. I'm trying to.
Okay, we see no movement. Are we showing the right thing? Yes.
It's strange because I am doing.
Now we are on the seabed complexity slide.
Oh, fantastic! So fantastic. So you can see.
Could you then at least hide the top ribbon so we can get it a little bit bigger?
Can you see it now? A little bit better?
No.
Wait a second. Sorry. Apologies. Now, can you see it?
A little bit better. Yes. Is that okay
Apologies
for everybody? Yes. We'll work with this. Yes.
Apologies, everyone. Apologies for this little hiccup.
And if you cannot see, then there is some space in the front. You can join me. Yeah.
I can run his presentation.
Okay, but now it's good enough, I think.
Okay, fantastic. So, apologies, everyone. I'll be back very quickly. So, basically, just to wrap up, the cable routing and installation strategy must account for this heterogeneous and geohazard sensitive seabed in Italy, which is one of the key elements to take into account. Together with of course, a national policy and ambition aligned with this 10 gigawatts, so with the intention to reach this this point. So this capacity ambition, while it accelerates, will still hinge on a reliable and technical robust subsea transmission system, as well as inter-array cable floating wind, navigating these challenging seabed conditions. Why this is unique? Because especially in Italy, in the coastline, we do have quite deep areas in terms of water depth, which of course attracts a lot of investment and potential for floating projects. Nevertheless, hard volcanic carbonates and very seismic areas pose a huge threat to these developments and for cables, of course. Dense presence of cultural heritage, mobile sediments, as well as the presence of very highly sensible area, which we'll cover in a minute, creates sort of a perfect storm for not only cable routing, but cable protection, and to ensure that there is a certain extent of degree of safety and assurance for stability of this cable against anthropic and natural threats. Potential solution, of course, by the book, starting with the early geophysical and geotechnical deep investigation, CPT and vibrocores, and well, this means a deep knowledge of the seabed. It's becoming not only a standard practice to be adopted, but is becoming rather a crucial element to enable asset deployment. Together with this, there are few other things that will enhance the knowledge of the seabed, which normally is something that is done slightly later on the stage, such as soil liquefaction assessment, the seismic comprehension of the area, which becomes now a must at very early stage in order to understand the geological scenario behind a certain portion of seabed. Route engineering strategy will have to be enhanced. So not only the micro routing and the avoidance of canyons and slope, which is obviously, as very eloquently my colleagues have presented in the seabed risk and hazard threat assessment yesterday, is becoming basically more than a must, of something that cannot be avoided. But while the seabed becomes busy and busier, we do also have another constraint of which areas can become viable or threat assessed, risk assessed for cables. And this might not become the only issues. They might not be fully sufficient to assure asset integrity. So external mechanical protection, cable armoring optimization, design mitigation will have to play a role, inevitably, especially in the MED, especially in these areas. Then we move to installation. So how do we protect the asset? Now, of course, the industry is very well prepared to adopt and deploy specific solution for hard seabed. Nevertheless, when the hard seabed becomes also sensitive in terms of environment, and we'll see in a minute, this poses an additional threat. So the potential for cutting, retrenching, and protecting cables and various assets in areas highly dense with fishing, but also involving the presence of EU-regulated biodiversities and receptors, it becomes a way trickier issue to solve. So what are these elements that we shall consider other than the seabed complexity in terms of degree of cohesion, the rocky seabed? And mobility as well, as we said, and seismicity and liquefaction. Well, just to mention one, which is one of the most renowned species present in Italy, is so-called Posidonia oceanica, which is a slow-growing seagrass, endemic seagrass, it's very important, which basically grows everywhere in the Italian coastline. And it becomes an issue because I've been planning cable route in Italy for quite a few years, and it's the complexity of the nature of the position of this seagrass and the areas where the variety of species of the same seagrass and the evolution of the patchworks that it creates makes it very complex for cable routing. Of course, we have a new habitat directive as a priority species, so it's a strict protection as well as under the Italian law. There is a lot of attention from the government to protect and safeguard this type of species because it's critical for carbon emission. It's an ecosystem nursery. It stabilizes the seabed in a way, and it grows massively with particular, let's say, extent nearby the coastline. So when we talk about cable landing, near-shore area, it becomes an issue mixed as well with a small extent, a small thickness of sandy seabed on top of bedrock, shallow bedrock. So the key words from every regulator, every local authority is to minimize, if not avoid at all cost interaction, right? But from a technical standpoint, how do we do it? So there are some let's say, mitigation that we can consider and we can explore, such as non-intrusive Brazilian seagrass, a surface slate, plus the protection shells, typical, it's been done in the past, it's been done forever. Nevertheless, has to be risk assessed. I'd like to remind you all that the Ene-Malta, Sicily-Malta interconnector has been laid on top of Posidonia approaching the Malta landfall, and due to the proximity of an anchorage area, the cable, despite being protected with cast iron shells, it was surface laid and it caught an anchor, but I think it was 4 years after the installation. So this is the typical example of how do we risk assess this. Then low impact vessel operation, okay, no anchoring, no drags, fair enough. However, how do we do this in very shallow areas where DP cannot operate. Sediment dispersion, another key element to consider, because the biomass period has a peak, has a truss. Can we apply soft clay techniques? Yes, depends where. As you can see, this is becoming a massive point of attention, which not only affects the, let's say, EIA consenting stage, but it also affects the whole planning up to installation, commissioning, operation, and maintenance. Again, I give you some food of thoughts about regrowth. Yes, it can be replanted. Yes, nevertheless, it remains a very sensible topic. What's the policy momentum beyond this? We have, of course, a lot of policy regulated aligned consultation, acceleration of permitting, let's say a reduction of Bianca-aligned consultation towards the late stage route conflicts for subsea cable. Probably one of the most important things is the compatibility check, which is becoming a growing matter of attention towards the respect of navigation and, of course, traffic separation zone and sensitive habitat, as we said. The regulation authority for network and environment, ARERA, it's facilitating offshore grid investment by de-risking large transmission upgrades, including Ternas, which is our TSOs, which basically represent the backbone of the energy transition. But also, there are discussions towards an integrated national and regional planning strategy framework aiming to streamline the zoning for offshore wind, which we don't have at the moment in Italy. So not only we have a critical seabed scenario, but also there is no actual zoning provided by the government across the Tyrrhenian, Ionian, and Sicily Channel, which complicates the whole scenario. This last point is quite important because basically not only complicates the whole process, but it creates a very lengthy and highly bureaucracy-driven process, especially when dealing with sensitive EU-regulated habitat. The marine spatial planning evolution, therefore, has to move from the current landscape where you have the highly bureaucracy-driven, fragmented, national and regional opinion-driven authorities, which basically dictate the whole convolution of the process and, of course, creates delays and inconsistencies, towards a more unified offshore energy zonation with not only predefined corridor, but predefined and risk-assessed corridor. There are discussions about the joint baseline to avoid the duplication of studies, so to enhance a common and joint shared knowledge of the seabed, which would eventually evolve towards that sort of a risk-assessed planning ahead towards shared corridor, which will be the ideal solution to minimize the impact on the receptor, but as well facilitating investment towards a more risk-assessed schedule and controlled environment within the development of cable routing and associated risk mitigation. How do we reach this? Of course, there has to be an element of collaboration. The UK, of course, has this approach being one of the leaders in not only bottom fixed, but also floating wind amongst the country who led the development. Italy is trying to learn, it's growing, it's trying to look beyond the discrete installation, looking towards about what are the implications and how we can solve the marine spatial planning, try to create a framework for developer and of course for the whole supply chain to safely install cable. Integrating an early stage planning with the TSOs, it's one of the most important things, as well as surveys, port authorities, and environmental agency. That will be the core. So dialogue and collaborative delivery model. Are we there yet? Not quite, but that will be the path forward as every emerging countries. One of the key elements is data. There is no project without cable project, as we all know, as industry experts and leaders, without deep and profound knowledge of the seabed areas. How do we achieve this? Sharing geophysical and environment data platform. It will be complicated because, of course, there is a competition, there is a proprietary ownership. Nevertheless, the government can facilitate this with a centralized database, as is done in other countries, except, for example, the UK. The cross-sector synergies with the telecom and power cable, including as well the interconnector, will be definitely a massive leap towards a more integrated knowledge of the seabed and shared corridor approach. Some discussion in the UK have been already done in the past few years about this. To make a comparison, for example, so from where Italy can learn, expansion of local manufacturing, then coordination with cable operators, O&M contractors, EPC contractors, etc., as well as probably as a next step, a joint risk register towards the understanding, in a perfect world, what lays beneath the surface. To conclude with this overview about how Italy could grow towards a more integrated planning model, overcoming obstacles at seabed, not only from a regulatory and biodiversity element, but also from a cable protection, which merely says it all, from a cable protection and asset integrity standpoint. First of all, we know that there is no floating wind without cables. There is no bottom fixed wind without cables. Cables are the backbone of any energy generation offshore. The issue in Italy is that we have a very complex seabed, extremely harsh, with a geomorphology dictated by a vast list of risk. From a cable perspective, in certain areas, I would like to call it the perfect storm. Canyons, seabed mobilities, liquefaction, seismicity, receptors. How do we achieve a risk-assessed approach? Well, dialogue with bodies, regulatory governmental agencies is key. Understanding how these can fit into something greater is the challenge. Supply chain, designers, developers, EPCs are all playing a role in this, but they need to be supported by a correct policy momentum and traction to enhance collaboration, attract investment, and de-risk timelines and de-risk assets. And I will breach a little bit towards insurance as well, and I'm sure the audience is full of insurance representatives, where clearly, if you mix the let's say seabed bottom hardship and risk with the elements of risk connected to the floating approach, there has to be an element of early planning to the risk, something that will come afterwards. Closing statement for me, from my experience of planning cable route and managing the regulatory aspect in Italy, I'm one of the few lucky ones who started a little earlier. We know the backbone of Italy and every other floating offshore and bottom fixed energy lays in the generation, but in our case, does not only float. In this case, in Italy, has to start from the seabed. Thanks everyone for your attention and for joining my little hiccup presentation. Apologies for that. And I'll be welcoming any Q&A.
Yeah, thank you, Daniele.
And again, accept my apologies for the little hiccup on the presentation.
It ended up working very well. So let's take some questions. Do we have any questions in the audience? Not yet. Then I will start. It's very interesting to see the challenges that you're facing in the Mediterranean, and there is a couple operational cables at the large depths despite the challenging conditions. What I'm wondering is we already started a discussion about the environmental impact, also on the Neptune grass in the Mediterranean, and I was wondering if it's really a big topic, because I looked it up in parallel, and I found out that this grass covers 38,000 square kilometers in the Mediterranean. So if we dig a trench over 1,000 kilometers, 10 meters wide, we will take 10 square kilometers away from that 38,000. Is it really something we should be that worried about?
It's a very good question, because it's all about the magnitude, isn't it, at the end? But for us, expert, technical, industry leaders, it might lay only in the number, but what I've learned that regulators, especially at national and above national, like EU level, they see it slightly different in a way that whenever there is an element of interaction, it's not only about the numbers, but it's also about the impact on the wider biodiversity that is getting affected. And whilst the magnitude is as a percentage, it makes absolute sense. I found myself in a situation where my interlocutors was like pressing on another front. Yes, but you're still doing it. What are you going to do about it? So we ended up studying the mitigation of replanting, so repositioning it. And even then, there are issues, where you are repositioning, because you are modifying the natural environment of a certain biodiversity corner of a species, moving it elsewhere. So there is a growing attention, but especially when you consider, if you consider the isolated cable, or let's say an interconnector, the interconnector, for example. He went through the Posidonia oceanica, and then they've been able to apply fantastic, amazing mitigations on that by replanting, by using eco-friendly type of concrete blocks, etc. However, you will always face the challenge of how you are modifying that slice of seabed. And when it comes to Italy, it's not a patchwork. The density and the extent is massive, especially near shore coastal area. I haven't seen so far a slice of landfall near shore region not impacted by this type of endemic species. There are different typologies of, let's say, diverse type of Posidonia, and they grow within different areas, they extend in different patterns. From a biological interaction and biodiversity interaction is quite, is becoming really important, and EU protects this as a carbon capturing element. So inevitably, from cable's perspective, I see this coming as being as critical as, for us, technical people, seismic. So to be treated as at the very same risk, not only from a regulatory standpoint, but also from environmental compatibility, which, especially in emerging countries with this level of ambition, as you can imagine, it becomes a massive thing.
Yes, yeah, and absolutely. I think we need to fulfill environmental concerns or think about the environment, but we also need to be a little bit pragmatic. Because you also the way you described the grass, it's a slow-growing plant. I think the slow-growing element makes me worried about its carbon capture capabilities as well. Yeah,
yeah. As you know, it's us as a technical people. We are very pragmatic, but then we need to be able to convince people above.
Yes. It's a balance. It's a balance. Absolutely. Yes. Do we have? We have one more question in the room. Let's take that.
Hi, Henrik. And surprisingly, I'm not going to talk about the alternative in the stabilization in the grass, but you were talking about the graphic thing, and in Taiwan we spent a lot of time on the liquidation of the seabed for the cables, and that delayed some of the projects there. I think the conclusion were that it was not going to impact the cables very much, the liquidation, and at least nothing was really made to it in the end. Is that any different in Italy with the? Have you made any based on what has been learned so forth in Taiwan? Have you made any different consideration?
But thank you very much for the question. It's an excellent question. It's an excellent topic. I've been working on soil liquefaction studies in Taiwan for quite a few years before moving back to the Italian region. I will say what I will highlight about Italy is that what in my experience makes it slightly different than Taiwan. The morphology of the seabed in Italy, other than being extremely deep, is very much interconnected with volcanic active cores. Not to mention, I'm from Catania, Sicily, where I'm actually living approximately 10 kilometers from the largest active volcano in Europe, which is Etna, and is very much interconnected with a variety of very much deramated faults in the Ionian and the lower Tyrrhenian Sea. North of Sicily, we have a constellation of volcanic islands, which are active beneath the surface. One of them is Vulcano, where basically it's a big volcano's island, and it's still active. The issue is exactly this, that we do not only have a very active volcanic system across the region, but also those channels and faults are moving. So very highly tectonic driven. And yes, seismic wave propagation, it is an issue in Taiwan as well. The difference, not going into the seismic elements and the PSH distribution and differences between the two regions, is that in Italy is currently evolving. So the degree of predictability of the seismic wave propagation and the fault evolutions in these highly volcano-driven active areas, it's complex. That's the difference. I fully agree with you. And I remember a few years ago, I've been integrating a seismic assessment and soil liquefaction assessment into the CBRAs. Was one of my projects for one of my solution for a couple of projects in Taiwan while I was back in cable risk design and burial design, and it worked really well, very, very well. We had a very much risk assessed conjunction between the burial and the liquefaction and so forth. I see it more complex in Italy due to the constant evolution of the fault and the activities that we have undersea. Last week, just a few days ago, I know it sounds scary, but we had here the typical bi-weekly earthquake in my area, and that, funny enough, was not coming straight from the Etna. It's coming offshore. So approximately 25 nautical miles from the Catania's coast. That's the main issues, in my opinion. It's very complex. I hope I answered your question without going away too much from the court.
I think you'll have to join us physically next time so you can discuss it with Henrik.
It will be my pleasure.
He needs to discuss some more. Perfect. But thank you very much, Danilo, for joining us and for your presentation. And we'll go to the next presenter. Yep. Thank you.
Thank you very much.
Okay, so our next presenter is Andrew Norris, Director, Energy Transition at Cedric Global Specialty Energy.
make this thing go back.
There's a small button at the bottom.
The full button. Yeah, good. Right. Hello, everybody. Andrew Norris from Cedric. A little bit about my background. I've been in natural resources and power generation for most of my working life, and I'm a chartered engineer on the engineering side and then chartered insurance practitioner on the other side. So I've got a foot in both camps, and I think I'm a bit of a generalist, so specialise in some things more than others. Do you want me to use this, yeah? I would if it worked. Try again. That's a bit better. So yeah, okay. I mean, it's a tough act to follow, Dan, isn't it? He's so enthusiastic and animated, and I can't talk about any volcanoes today, unfortunately. So here we are. We're going to talk about insurance, and today submarine power cable insurance, and I'm going to focus on weather and. There's going to be a number of different things, but really what I'm going to do is just going to walk you through an insurance policy with a view to things that are in the insurance policy that have something to do with weather. It's a big subject, so there won't be enough time to go through it all, but hopefully I'll just whet your appetite. I first sort of got into the insurance of things like cables and such like, probably around about 2010, 2011. It was at the early stage of the offshore wind industry, and for the next 9 or 10 years was working with the insurance of offshore wind farms and submarine power cables, and with the company I was with, eventually headed up the centre of competence. So I got to see all of our operations right across the board, and were involved as a key insurer of things like North Sea Link, Nemo, IFA2, the Viking Link, and a whole bunch of others, and also quite a lot of really big wind farms. So I've seen it from the insurance underwriting side. In 2020, moved across into loss adjusting, and loss adjusting is all about sorting out the mess the underwriters have made. So when you're underwriting something, you try to cover all the possibilities, but inevitably there's complications. And a loss adjuster is going to try and navigate their way through that to bring the two potentially warring factions, the insured and the insurer, to some sort of resolution. So submarine power cables are incredibly risky, and of course with risk, nobody really likes risk. So the first thing is to try to avoid it. But if you can't avoid it, then maybe mitigate it. And if you can't entirely mitigate it, then perhaps you can transfer it to somebody else. And that somebody else usually ends up with the insurer. And insurers don't really like risk, and so quite often what they do is they divide it up, carve it up, and throw it to the rest of the insurers by way of reinsurance. So insurers see many, many cable claims, and in the process, they will send on a good portion of those claims to loss adjusters. And so by proxy, the loss adjuster gets to see a lot of claims. And the way I was trying to think of this is, if you had a project delivery team, and they're there sort of working on something for, say, 3 to 4 years, and they deliver the project, hopefully it ran clean, there were no problems, and then they'll move on to the next cable project, and maybe the same thing there, and maybe the next one. So over a decade, you could say they've maybe seen 1 or 2 claims, but insurers in any one period of time of, say, 10 years, see multiple claims right across the whole industry globally. And so they get a slightly richer sample of data. But even still, it's a relatively small, statistically insignificant sample of data. So, what we see quite often gives us an idea of trends. And I was thinking about, what are the trends that we're seeing at the moment? And then it suddenly dawned on me that I've been working on a number of claims recently, and not so recently, where weather has been a really important part. And not necessarily the causation part, but just a part of what's going on. So let's have a look at that. So when you talk about weather, you might think, well, okay, the weather caused the event. But sometimes it's not so much that it caused the event, it just made the event's recovery so much longer. And typical considerations are the prolongation of the repair period, and that repair period is quite often driven by things like wave height, wind direction considerations, the vessel selection, and so on. But there can be unexpected complications as well. So this drives up the cost, and for those of you that were here yesterday and listened to Michael Brooks, you might recall he was talking about two different types of coverage that you have in insurance. So you have the physical damage type coverage, so the thing's physically damaged, it needs to be repaired, there's a claim as a result of that. But there's another type of coverage, which is the loss of revenue. Now, the loss of revenue is something that is more towards the owner, developer, and behind them the financiers, and they want to protect their future loss of revenue in the event of an insurance claim. And those two aspects are not necessarily aligned, and especially when you start looking at weather. So, for example, you might be able to get a repair vessel for, say, 150,000 euros a day next year, but there's a more expensive one available right now. And let's say that's 200,000. So you're going to save 50,000 euros a day by deferring it to next year, or you take the hit now. Why would you take the hit now? Well, because maybe if there's going to be late delivery of the project, the delay in startup of that project could cost you much, much more than just $50,000 or euros or whatever per day. So in a way, there's not always an alignment of interests, and that goes not only within the contracting parties on the project, but also between the insurers and the insured. And so the question then becomes, where is the alignment of interests, and how can you resolve that as a loss adjuster? And the other thing about weather is it's a somewhat subjective thing. I chose a couple of photographs there, these sort of things you get with Microsoft, but it sort of came to me that, I used to do a lot of surfing when I was a bit younger, and I spent hours and hours looking at the surf and wondering, is that a decent wave or not? And that just goes to the point of weather being a very subjective thing. Okay, so how do insurers look at weather when it comes to insurance claims? Well, to understand that, you need to understand the policy, and there's a lot of people in this room who are experts in insurance. I know that there's some colleagues here from insurers and brokers, and they'll know this only too well. So bear with me for those people who are already there, but there'll be a lot of people who are probably, insurance is just some vague thing they do once a year with their insurance in their house. And so what I want to do is to try to sort of have a look at the architecture of an insurance policy and just walk you through a few of the key things. And the typical project insurance policy is called an all risks policy, but that all risks cover, the basic cover, is then extended for a number of additional things. I'm going to walk you through how they relate or could potentially relate to weather, and then I'm going to talk about how the coverage is then reined in again through restrictions and exclusions. So, policy, big thick document, principal insured, typically the owner, the developer, other insureds, contractors, subcontractors, and suppliers, and all the different tiers below that. There'll be a period of insurance, sums insurance, and then a whole bunch of other little bits and pieces. It'll probably say new for old, and in the section where it talks about new for old, it'll talk about use of pre-hired vessels or whatever to give clarification there. And then it gets to one of the key things which relates to weather, which is in the definitions section. Now, it's quite a lot to read if you look at the full-blown paragraph. So what I've tried to do is to bring out a few key words. So, I'll beg one. I think that is jumping forward one. Sorry, there we go. So, the definition of an occurrence, and it's a rather curious clause, so I'll read it out very quickly. An accident including continuous repeated exposure to conditions which results in property damage neither expected nor intended from the standpoint of the insured. It's one loss, accident, disaster or casualty, or series of losses, accidents, disasters or casualties arising out of one event. As respects windstorms, all tornadoes, cyclones, hurricanes, similar storms and systems of winds of a violent and destructive nature arising out of the same atmospheric condition within a period of 72 consecutive hours, highlighted for a reason, commencing during the period of this insurance, shall be considered as one event. So we're talking about weather, and the key things here are that we've tried to describe an occurrence. But when you think about weather, it's a continuum, isn't it? Yes, okay, it's snowing, it was snowing a minute ago at least today, and then it stopped snowing. Is that an event? Well, actually, it's all just part of the weather, and it's now sleet, and then it's rain, and then it dries up, and then there's some more. So actually, weather is just a continuous thing that happens, but insurers are trying to create a way of capturing that and calling it an occurrence. And so one of the ways they do that is they say, well, all of that happens within a 72-hour period is going to be construed as one occurrence. And then they say that occurrence is essentially an event. It's something that arises out of an event. And if you think about it, what they've done is they've taken the word occurrence, replaced it with event, but haven't actually described what an event is. So it's very, very problematic. It's also problematic because all the sublimits and deductibles are contingent on any one occurrence. Okay, moving swiftly on. The policy provides for all risks, but is extended by various mechanisms. And one of those mechanisms is removal of wreck or debris. And this is in addition to the sum insured, but can be sublimited. The thing says, following an occurrence, which we have already poorly defined previously, insurers shall indemnify all costs of the actual or attempted raising, removal or destruction of the wreckage and or debris of the insured property. So let's say that a cable is in a carousel, it's on a dumb barge, I don't know, maybe the towing bridle or something gets broken and it moves onto an area of shallow ground. They can't recover it straight away and it's now on the sandbank. The tide's going out and you now need to remove the wreck, you could say. So there has to be some sort of understanding of where the interests are, because the interests are in the cable and not the vessel. And I'll come back to that a bit later. Then you have another way of extending policy coverage, which is called the sue and labour clause. And this is quite an interesting one. I've seen this in some pretty horrific claims outside of the world of cables. But it basically says that in any imminent physical loss or physical damage to property insured, which is the direct result of a peril insured against, the insureds may sue, labour and travel for, in and about the defence, safeguard and recovery of the subject matters insured and may incur reasonable expenses in efforts to minimise the loss. The costs incurred borne by the insureds and the insurers proportionately for their respective interests. So the first thing is it has to be imminent. It has to be in the grip of a peril when it happens, and the insured property has to be in danger of loss. So if you've got a vessel that is about to go onto the sandbank and you're sue labouring and travelling to recover the vessel, which isn't actually covered by the insurance, the question is, to what benefit is it to the insurers who have insured the carousel? So you just have to start thinking about what endeavours you can do. But also it has to be imminent, not the next day or a week later. It has to be imminent for these costs to be triggered. Then there's the extension of policy coverage through a thing called the maintenance period. And the maintenance period is this period after handover when, if there's something that happens due to causation from the construction period, there's still cover as if it was part of the construction policy. But it happens in the operational phase. So if you've got some incident and you need to do the repair in the maintenance period, that's going to trigger a loss of revenue because it's operational now. But the operational coverage may be in place for business interruption. But the question will then be, okay, there's a vessel available right now and it's really expensive, 250,000 euros a day, or there's one available next year for $100,000 a day. The business interruption insurer is going to say, get that job done right now. the construction insurers would probably say, well, hang on, we can save $150,000 next year. So for every day. And if there's a prolongation due to weather, then that can be a considerable amount of money. So there's ample scope there for conflicts in the way people see that. Now, the all risks policy will have a number of clauses within it, and one of them is the additional work clause. And this is one which says the cost of additional work is that required for repositioning, and I'm going to cut through to the chase, stabilizing the property. Okay? Now, how often have we seen cables that need stabilization? So the question then is, to what extent can you trigger the additional work clause just for stabilizing a cable that has been washed out a little bit by a windstorm the night before? Then you get to the cable cutting clause, and this basically says that if the cable must be cut by reason of imminent threat to safety of persons or the cable as determined by the master of the vessel. And then it's the cost to put it back to where it would have been before you cut the cable. And it provides that the master shall take account of weather and sea conditions in the forecast at least 7 days prior. Well, how many people would take a gamble on what the weather's like in a week's time? And that's actually quite a subjective assessment, as I said earlier. And obtain regular forecasts. It doesn't say where from. It could be just, BBC News, or it could be something altogether more sophisticated. And take such precautions as may be necessary. What is necessary? What is reasonable? And how would you actually consider that in the event of a loss? And where does the marine warranty surveyor sit in all of that? Because we're talking about the master of the vessel. Then you have standby charges, and this talks about vessels which are actively engaged in repair activities following an occurrence where bad weather of any nature, okay, any kind of nature. So that is pretty broad. We're not just talking about a named windstorm. It could be all sorts of different things, tornadoes, waterspouts, snowflakes, who knows. And then you have this question about, is it cheaper to off-hire vessels or to incur the standby charges? Now, all of this opens up more cover for the person who bought the insurance. But from the insurer's point of view, they want to kind of restrict it a little bit. And one thing which is really key to cables is the all risks cover is for physical damage. Okay? It is not for defects. And insurance, and people have heard me speak before, defects and damage are quite different things. And then there'll be a whole bunch of other exclusions. There'll be all the usual things you see, like, for ionization, nuclear war, and all those sorts of things. But then more specific exclusions where vessels are quite clearly not covered. Okay, so again, this is where the conflict comes in because of the weather and the way vessels operate in certain weather. I'm going to move on quickly now because I just want to get to a couple of claim-related issues. So I said, I think earlier, that some of the biggest claims, the most problematic claims I've seen just recently in recent years have been either to do with weather, where weather wasn't the driving issue in causing the claim, but is a driving issue in prolonging and therefore making the claim bigger. But it's also where there's been uncertainty exactly what the weather has done to the cable. If the cable is free spanning, is that the tide that's caused that, or is that wave action? And as wave action, is that any weather, going back to those earlier clauses? So I'm getting very close to the end now, and I think that might be my penultimate slide. So just one other quick word then, seasonality. I talked earlier about if you've got a vessel that's cheaper next year, well, why is it next year? Because you don't work during the winter, or do you? Now, some people will say, well, hang on, if it's a good day in the winter, why can't you work? But then you'll be talking about the weather window, and again, there's this subjectivity of what is a decent weather window? What is the perfect wave? So in insurance, we sometimes have these arguments where people are saying, well, you can repair it now if you really get on with it. And others are saying, yeah, but if you take that risk and you can't get on and do the repair, and you've got all these vessels sitting around doing nothing, waiting on weather, who's going to pick up that cost? So just a few concluding remarks, just as we close in the last minute. So we've got an all risks cover. It's pretty broad, gives you lots of good things, but there's actually quite a few challenges in some of those clauses that appear to give you something extra, and they quite often lead to sort of insurance discussions about what is reasonable. And, as a loss adjuster, we get into the thick of that. Ultimately, the decision is for the insurers, and we will report the circumstances to the insurers, and we'll ask them what their opinion is in terms of coverage. And then if that differs from the opinion of the insured and maybe the insured's broker, then you quite often have some pretty steamy arguments about things. But usually there's some sort of way of resolving that. You just have to find it. So thank you very much for listening. And Jakob, I now hand the mic back to you for your duties.
Thank you, Andy. So, do we have questions from the audience? Oh, there is one in the back. Could we get a microphone?
Hi, Stephen O'Connor. I'm with Lockton. Just a quick question. It's not necessarily weather related for construction or for the owners or operators of power cables. It's more for the owners of vessels that might be operating in the area. You've got a vessel coming into port, and maybe a cable, not necessarily a power cable, maybe a fibre optic or something. The vessel has a main engine failure, has to drop its anchor. The anchor drags over the top of a cable or a pipeline or something like that. Create some damage, create some outage. Where does the owner, the TSO operator, come to claim back the cost? And is that is there a sense of they could sue the vessel operator who could then claim under sue and labour? How does that work?
Okay, a couple of things to pick up on there. So the liability for damage caused by vessels is limited by international agreement, and quite often there's not actually a lot of money to come back. So, for example, if it was a fishing vessel, it's based on the gross registered tonnage, and that wouldn't be very much. So you might be sort of going through a lot of heartache and bother to get not very much back. If the vessel is a sizable beast, and you can definitely prove that it was them, then the TSO would probably turn around and say, well, you've caused us some damage. I think probably it would edge into the world of, it would be an insurance, but I think it would be something that a maritime lawyer would probably better be giving an opinion on than myself. But I know the sorts of things that we've seen before. With interconnectors, I've seen ones where the two grid operators haven't bought the same insurance. So one side has bought business interruption insurance and the other side hasn't. So if the cable is then damaged, you also end up with a sort of slight misalignment of interests. But if I was a loss adjuster working on a claim where a third-party vessel had caused damage to the cable for my principals insured, I would probably advise them to instruct a lawyer to see if you can get some money back from the P&I insurers of the vessel. And maybe that might be a route towards some sort of resolution. It's not a world I get particularly involved in, but thank you for your question. I hope that's helped.
I believe we had a presentation a couple conferences back about cases like this. It's not simpler than what Andy described. I think that there was a case where they were considering in which jurisdiction to even sue the vessel. In the port it was coming from, in the port it was going to, in the country where it's flagged, and all of that would have an impact on what they can recover. So it was a legal question.
Absolutely, yeah. Yes, indeed.
Good. Okay, but then, Andy, thank you very much for your presentation.
Thank you. Thanks very much.
And we will move on to Richard Booth, partner at HFW.
I need to use this microphone, is that correct? I'll use this one because it's closer to me. Thank you very much for the presentation, Andrew. Always, obviously, music to a lawyer's ears when you hear somebody on the preceding presentation say, you need to ask a lawyer the question. At a subsea cable conference, why have you got a lawyer here? I tend to come along because we do a lot of work in offshore construction, a lot of work in offshore wind and subsea cabling and interconnector cable projects. And I tried to think of something a little bit different to talk to you about each year. This year, I thought I'd talk about force majeure clauses. I'm going to sort of rattle through it. There are quite a few slides, but I think the slides will be circulated later on, so you can look at those in more detail a bit later. But just coming back to our Italian friend online earlier, I really think I agree that we need to be a bit pragmatic about the Italian seagrass and assume that it will just cover the trench a few years later and not worry too much about that. But he talked about earthquakes and the frequency of earthquakes in the Italian region. And obviously, you know, that arguably covers the sort of force majeure topic, which is sort of acts of God. And whether that's foreseeable or not may be an issue. I wanted to talk about force majeure today because I think if you watch the news at night, 10 o'clock news, there's quite a lot going on in the world at the moment. And quite a lot of what's going on in the world at the moment could have an influence on how we deliver subsea cable projects going forward. I'm not saying it's going to. I think there's a lot of saber rattling from different jurisdictions and individuals. But of course, that saber rattling could progress and it could have an impact on the global supply chain. And that's really what I want to talk about today, particularly in the context of just wanting to put a thought in your minds about, do you need to really look at the force majeure clause a bit more closely when you're looking at your contracts for projects or cable supply? Because it's one of those clauses that typically comes towards the end of the contract. I don't know about you, probably it affects you as much as it does me. When someone sends me a contract, and unfortunately they're really long these days, I never quite understand why they're the length they are, particularly when they're being backed down to the supply chain. But the force majeure clause is always towards the end, and that's when I've had 3 coffees already and I'm beginning to lose the will to live. So sometimes I skip slightly over the force majeure clause. I'm going to encourage you not to do that today for the reasons that may become clear, but also actually not to forget that your counterpart who sent you the contract or who you're sending the contract to may also skip over the clause, so you might be able to slip something into the drafting for your benefit that they might not pick up on. So just have a think about that. And really what I want to focus on is the relief that you might get for force majeure. Now, what is force majeure? Well, force majeure really is an act of God, as I've said before. And really the reason we're concerned about it is because a cornerstone principle of all contracts is you have to comply with your contract. You have to comply with your obligations. So you've signed a contract, you need to perform your obligations. Obviously, if you can't perform your contract for various reasons, then you will potentially be in breach, and therefore you may be liable for damages to your counterparty. The question is, what caused that liability? Well, it could be your own failure to perform, in which case, good luck. It could be the failure of your counterparty to perform, in which case you may have a claim against them under the contract. Or it could be just a superior force or force majeure. Now, that's really a concept that's been developed in order to give relief to you if you can't perform because of a superior force. So if something happens which is not your fault, it's not your counterparty's fault, it's not a third party's fault, it's just something that's happened, then force majeure may give you a relief and give you a defence to the breach. In civil law jurisdictions, and there will probably be a lot of people in the room who are more familiar with civil law jurisdictions and civil law codes, force majeure is typically codified in civil codes, so it's set out in the law. In England, because we like to be a bit different, there's no such concept of force majeure in law. It's a creature of contract. So if you have a contract that's subject to English law or Scottish law, for example, then you need to make sure that you've got force majeure written into your contract. Otherwise, you will have no force majeure relief mechanism. What is force majeure? Well, it's really an event or a circumstance that's beyond the reasonable control of a party. So you could have man-made type disasters, so wars, revolution, nuclear explosions, etc., things like that. Or it could be a natural disaster, so it could be an earthquake or a typhoon. Those are the sort of typical events. Why is it relevant to subsea cable projects? So I put some photos up on the screen. Who can remember the volcanic eruption in Iceland back in 2017, something like that, maybe earlier, I can't remember now. It's 2010, okay, it was a long time ago. But I remember that because you don't really think a volcanic explosion or eruption is going to impact the delivery of a subsea cable project or an offshore wind project. But of course, we need to fly personnel or engineers, often by helicopter or plane from one part of the world to the other or to a ship. And that shut down the airspace in a large part of Europe for quite a number of days. So it could have an impact on how you perform your contract. COVID. We all remember COVID. We've slightly forgotten about it now. We were talking to friends the other day about how we had to queue up outside Sainsbury's at 2-metre gaps to be allowed in to look to see if there were any toilet rolls in there, even though we already had 6,000 toilet rolls at home. So COVID impacted us. The Ever Given got stuck in the Suez Canal, and that meant everyone had to sail round Africa to get to Europe from Asia. Pirates of Caribbean, they are still around, particularly off the coast of East Africa and the Middle East. Obviously, we've got the minor military operation in Ukraine, or the war or invasion, as I like to refer to it, but I'm not allowed to put in writing. And then, of course, we've got Iran, who are still sort of saber-rattling, occasionally threatened to shut the Straits of Hormuz. And then, of course, we've got the issues with China and Taiwan, and that could obviously impact some of the cable projects we have over there. So I think there are a lot of things going on in the world that could have potential to impact on subsea cable projects. And there's one in the middle, actually, which is more recent, and that's the sort of GPS jamming that we've seen in the Baltic and how that can affect vessels over there. So, why is it of concern? Well, any of those events or any other event that's outside your control or the party's control could have an impact on your ability to perform. And what you're concerned about as a subcontractor, supplier or a contractor, or even an employer, in fact, is being able to get relief under the contract if that type of event happens. And what is meant by relief? Well, relief is really probably an extension of time to relieve you of liability for liquidated damages, or it may be entitlement to cost. Subsea cable contracts, the bigger contracts that we see are typically based on FIDIC. FIDIC has written into it a force majeure clause in clause 19. And in FIDIC, that does excuse you from performance, and it may ultimately give you a right to terminate the contract if the event continues for a certain period of time. But there are a number of hurdles to overcome to successfully claim force majeure under FIDIC. And really where I want to get to with the talk is the concept of whether the relief that we typically see in an offshore wind contract is appropriate in the current geopolitical environment. Hurdle 1, there must be a force majeure event. And this is the clause from, this is the wording from clause 19.1 of the FIDIC Yellow Book, typically unamended in the FIDIC contracts that I see for subsea cable projects or interconnector cable projects. The key elements are the event has to be exceptional, and it has to be beyond the parties' control. There's often a bit of a debate when something happens as to whether that event was beyond a party's control or whether they could not have reasonably have provided for it or against it before entering into the contract. So what does that mean? So taking COVID as an example, if you signed a contract in January 2020, COVID as a pandemic probably would have been still a force majeure event at that point in time because we would not have understood the impact of COVID. If you signed a contract in early May 2020, COVID would no longer be a force majeure event because it was foreseeable at that point in time. It had happened, we'd had a lockdown, so therefore I think if you were trying to complain that you couldn't perform because of COVID, you would not have had any success arguing that as force majeure. And it's interesting, I was involved in a number of contracts around that time where our clients were being told by an employer or a developer, don't worry, you've got the force majeure clause. And I was like, well, it doesn't work because it's here, let's watch the news. COVID is very much here, I can't go anywhere. But what happens if you signed your contract, let's say in August 2020, when perhaps there had been the lockdowns had been released. We were all out, encouraged by Rishak Suni, I think at the time, to go and have meals out and see our friends. There was no lockdown anymore, everything was happening. You sign your contract at that point in time, but actually, arguably it would be foreseeable that there could be another wave of COVID at that point in time. So again, if that future wave impacted, which was linked to the COVID at that time, probably also not force majeure. So you've got to have those 4 limbs on the previous slide, but what FIDIC does is then give a list of non-exhaustive examples of what could amount to force majeure. That's the clause from 19.1 of the FIDIC contract. I'm not going to read it out, but what I wanted to focus on really is what we often see with this clause. And what we often see is developers and employers have an inherent interest in limiting the scope of the force majeure clause. What they want to do is restrict it to specified events. So rather than having a non-exhaustive list, which could be anything and everything, provided you hit the 4 limbs on the previous slide, employers want to say it's limited to only the events that are listed. And if you ignore the type in red on Roman numeral 1, they sort of try and really reduce it down, and then you have a problem, because if something unexpected happens which is no longer listed in your clause, you don't have a force majeure mechanism that bites. But I look back at some of my cable contracts from the last few years, and it's interesting how this clause can change. So there's always an argument about whether it should be a non-exhaustive list, better for everyone, or whether it should be an exhaustive list, not so good. But what I noticed is that there are some events which can pop up and be included in the drafting that are useful to have. And those are the ones that are in red on that first Roman numeral 1. So piracy listed as a force majeure event. I thought that was interesting if you could slot that into your contract, because if you're sailing your barge or your cable lay vessel around somewhere that's susceptible to piracy, then you could get force majeure. Sabotage, blockades, useful. And then the one I thought was quite interesting, which I think probably has its origin in logic contracts, was maritime or aviation disasters. And we all know there have been a number of vessel incidents recently, either new build vessels that have suffered some kind of failure during load testing, or other vessels that maybe have suffered issues during class certification testing, thinking of the Saipem vessel with that one. That's a maritime disaster, and that would be a force majeure event which would give relief from performance, would be quite useful to have in there. And then the last clause at the bottom, or the last limb, natural catastrophes, which is really, cataclysmic weather events. Why does no one ever list tsunami? I don't really know why tsunami is never listed, but obviously if you have an earthquake, you have the potential for a tsunami, and a tsunami is essentially a big wave. You may see Andrew surfing out on that wave if he thinks it's the perfect wave. But really, I think these are just things that you need to think about as to what you list in the clause. The other thing just to keep an eye on is, I've seen some contracts where the parties they think they've been quite clever. So they've said, okay, on the one hand, we'll agree with you, employer or developer, will have an exhaustive list of events, but we'll very carefully specify what those events are. And what they did with this contract is they linked the force majeure events to different fabrication yards or cable yards, and there was a list of about 10 of these exceptional events in this particular contract, listing every fabrication yard or supply yard that was thought of at that time would be involved in the project. Very good, you might think. I've covered every possible yard that I'm using. But in my experience, what can often happen with these contracts is one yard may be swapped out for a different yard, or one supplier may go bust and a new one has to be brought in, or there's a delay, so you have to try and accelerate by thickening the yards or introducing other yards. In those scenarios, the clause in this contract, which the parties I think thought they had been quite clever about, would no longer work because it didn't list the new fabrication yard or supplier. It also didn't capture the transport routes. So you could have a fabrication yard in China or the UAE, which is supplying something in Europe for a European project. So yes, the yard itself was caught, but the transport route all the way to Europe was not caught in the force majeure mechanism. Again, would it be a bit of a nasty surprise and present a risk? If an event happens, it has to prevent you from performance. So just because it's going to cost you a bit more money is not sufficient. It actually has to physically, legally prevent you from performing. That's quite a high hurdle. It also must be the sole cause of the failure to perform. So you can't have concurrent causes, one of which is force majeure and one of which is something of your own fault. You have a duty to mitigate if a force majeure event arises. Procedural rules, you have to give a notice. Just be careful about the notice mechanisms. Some of the more recent contracts I've seen have been very prescriptive as to the notice for force majeure. There's no need for that. It should be just notifying the event and why it's stopping you from performing. You shouldn't be needing to give programs and plans for how you're going to resolve that issue. The more prescriptive the notice mechanism, the more likely you will not comply with it, and therefore the bigger the risk of an argument as to whether or not you have complied with your contractual obligations to unlock force majeure. You must also show that you've incurred a delay as a consequence of the event and incurred cost. Cost. Under FIDIC, you get costs. Typically, however, in offshore wind or cable contracts, the cost entitlement is deleted. I don't think that's very fair. And the reason I don't think it's very fair, I'm going to talk you through now. So if you have a force majeure event in the majority of these contracts, you will get an extension of time provided you've been prevented from completing your works or performing your works. Yes, that relieves you of your liability for liquidated damages, but you're still bearing all of your own costs. Andrew, I think, mentioned earlier the cost of some of the day rates of vessels. I mean, they're over £100,000 for a cable lay vessel, £150,000, however much we have. If the force majeure event arises, you're still contractually required to perform your works, but the force majeure mechanism may relieve you of that obligation for the currency of that event. But as soon as that event is lifted, you have to continue performing your contract obligations. So if the event continues for 30 days, what do you do with your vessel? What do you do with a supplier who's saying, well, the cable's ready to be loaded out onto the vessel, I'm going to charge you storage costs? These are all costs that are not covered by the mechanism. It's the employer, the developer, or the contractor's project. They're asking you to perform wherever you're performing. So if they're asking you to deliver a cable project in Taiwan and there's a risk that something might happen there, it's only because the employer's asked you to deliver the project there that you're in that jurisdiction and you're putting yourself at the risk of a potential force majeure event in that region. I think you should be having an honest conversation with your counterpart at contract tender stage and saying, you want me to go over there, that's absolutely fine. But if something happens which means I can't perform and it's outside both of our controls, we need to have a serious discussion about who bears the cost liability for that, because it's not reasonable for me to bear that liability, particularly when I've got follow-on contractual obligations for different projects, which will mean that I will need to take my vessel somewhere else. So I have got a couple of contracts on my desk where the parties have had those honest conversations and they've included some kind of risk-sharing, cost-sharing mechanism in the contract for force majeure. These are the minority of the contracts that I've got. The majority of the contracts I have for cable projects have no cost entitlement. Under the cost mechanism, and this is one example, the parties have agreed that for the initial 4 days of the force majeure event, the contractor would just bear the costs. So if the vessel's on standby, the contractor would just swallow those costs. If the event continues beyond 4 days for the next 26 days, the employer under this contract, or the contractor, accepted that they would pay the standby vessel costs, the standby rate for the vessel. And the contractor agreed, if I'm being paid the standby rate for the vessel, then I will remain on standby at the site on the assumption or presumption that when that event is lifted, I will just continue to perform. If no further instruction was given by the employer under that contract, then the contractor was contractually entitled to demobilise the vessel from the site, from the project, and take that vessel to future contractual obligations. Also, with a contractual right to be paid the demob and any remob costs. That's unusual, but I think that's a fairer mechanism in the contract. There's only the vessel rates. I think there are other things you could think about in terms of storage costs or yard costs. Why is it important? The reason it's important is because although force majeure events will give you a right ultimately to terminate if the force majeure event continues for a period of time, the parties typically negotiate the period of time that that event must continue for. Often it's one of those 3 examples at the bottom are time periods that I've taken out of some contracts I've got. So the first one, 90 to 70, if the force majeure event continued for a continuous period of 90 days, then only after that continuous period of 90 days, so 3 months, the contractor would have the right to terminate. If it was multiple different periods, then it's 270 days, so quite long. But I think what's more representative of what we see are the last 2, which is a continuous period of either 140 or 180 days. 180 days, that's half a year, 6 months, that I'm still contractually obliged to perform. And what am I supposed to do with the cable that's sitting somewhere in a yard, storage costs, or my vessel, which I've got standby rates for? Also bear in mind not only the risk of whether you recover your own costs, but the force majeure mechanisms are reciprocal. So it's not only the contractor that can operate it, but the employer can operate it. Or if you're a supplier, the main contractor can operate that mechanism. Now, a clever, informed employer or main contractor may use that mechanism to avoid liability for costs. So if something happens that's outside the employer's control, or the employer tries to argue it's outside their control, they could give a notice of force majeure downstream to their contractor or their supplier, and that will relieve the employer from their obligation to perform and probably entitle the supplier to an extension of time, but again, no costs. So again, the costs risk sits with the supply chain. There are alternative mechanisms to think about in these types of events. So adverse climatic conditions or unforeseeable shortages due to pandemic or epidemic are also covered in the standard FIDIC clause. If you can use that clause, it's better, it's less onerous than the force majeure mechanism. Change of law clauses may be relevant. They were looked at very closely with COVID, for example. Insurance, possibly there might be a business interruption claim if the project is handed over in phases, for example. So just think about different approaches. Tips and tricks. 2 slides, last 2 slides before coffee. I do think force majeure mechanisms should be more sophisticated now, particularly in relation to the cost liability and cost sharing. Your list of events should be non-exhaustive. You don't have a crystal ball to look 4 or 5 years in advance as to what may happen in the future. So when you are sent a contract that has an exhaustive list of events, I think you should go back to your counterparty and say, no, I'm not accepting that. I should be entitled to have any event that falls within the criteria of force majeure as being my force majeure entitlement. We talked about prevention. It's a very high hurdle. So if the force majeure event arises, you have to be prevented from performing. Some people try to amend that prevention to change the terminology to hindering or delaying, which is a lower hurdle. That's an example of something you might want to try and slip into the drafting when you're reviewing the contract to see if your counterparty doesn't notice it, because it's a lower threshold and therefore easier to achieve. Check the geographical reach of your mechanism, not just the country that the site is based in, and that's often what happens. We have a global supply chain. That global supply chain has transport routes. Make sure that your mechanism bites on that. Cost recovery, important. Notice provisions for force majeure, make sure they're reasonable. It should be a very simple notice, nothing more than that. If the event arises, you could think about having a mechanism in the contract that says you have to actually talk to each other and sit down and discuss things, a bit like some of the mechanisms we see in latest vessel availability dates or early warning clauses. Seems obvious, doesn't it? But make sure your force majeure clause is back-to-back upstream and downstream. And don't forget about direct agreements that the project finance lawyers like us all to enter into that completely overwrites the termination and suspension clauses in our contracts. So just have a think about how that works. Jacob.
Perfect. Thank you. All right. Let's see if there is one pressing question maybe. Andy, perfect. A question for the lawyer. and then we'll take a break.
I hope it's about waves.
No, sadly not. It was just that last one, actually, direct agreements. Could you just quickly explore on that? I sense perhaps you're running out of time there and like to have talked about it, so maybe just take a question on that.
Yeah, so most of the projects, or not most, but a lot of the projects have project finance, obviously, sitting behind them, particularly the offshore wind interconnector cable projects. The project financiers don't like the contractor or the supply chain being able to terminate contracts or suspend performance under contracts. So there's this separate direct agreement that sits between the subcontractor, key subcontractor or contractor, around the employer upstream to the banks. And basically under the direct agreement, the contractor agrees to give notice to the banks before they suspend or terminate. And it often has the effect of extending or lengthening the suspension or notice periods under the contract. So under the main EPC contract or cable supply contract, it might look like you can suspend if you've not been paid within 7 days or terminate if something happens. But really, the direct agreement is quite important to understand as well, because that can often extend those periods of time before you can actually enforce your suspension or termination rights. And that's sort of relevant to force majeure, because obviously in prolonged force majeure events, then you could have the right to terminate.
Thank you. Very interesting.
Right. Thank you. But then,
Thanks very much.
Thank you very much. Okay, so Richard already hinted at it. It's time for a coffee break. So let's meet again 1:15. And yeah, enjoy. Take our seats, if we could. Okay. Can we take, Hendrik, give everybody a minute. No. Okay. Can we settle down slowly and then we can continue? Sorry? No one is listening, I heard. Hello? Woo. It's okay. It's okay. We're getting there. Good. But then let's move on with the next point on the agenda. Our next presenter will be Henrik Bang Andreasen, founder at Partner Solutions.
One here pushing on which one?
Yes, that's for your slides.
Slide.
Big
Just
one is forward.
big one is forward. Thank you. I'm going to use this one. Thank you. Hello. So I'm going to talk about securing the future. So more future and less cable risk. So I have to do like this. Sorry, it's too far away. So simple. So I'm going to. Oh, here it is. Fine. Thank you. So simple offshore logistics. Getting the rock placement out of the critical path. Rock installation. I'm learning, but slowly. And stabilization at touchdown, preventing the cable fatigue. And cable repair without interfering with the scour protection. So I have a background in this industry from soon to be not quite 20 years, but getting there slowly. And I had a company before called Seaproof Solutions before I started this entity with Partner Solutions, and that does about cable stabilization. But before we get there, back to Michael Brooks started yesterday about the number of cable failures. And they talked about that we're going to have some 6,000 cable failures between export cables, inter-array cables, and interconnectors in the next 15 years. That was the figures that they released in July this year. They may have adjusted this a little bit, but whatever. So quite a few failures. And the thing that we started to do in 2020, 2021, we started to stabilize the cables under rock berms. And as you see, quite a peculiar picture there from wind park in the US, the South Fork, on the right-hand corner there. That's actually, you can hardly see the cable system, the CPS coming out of the rock berm and into the monopile. And then, of course, one of the ambassadors of rock installation, his comment from the LinkedIn, he's laughing now, so that was good. I was wondering whether we were going to start a fight over this, but yes, there's quite a few vessels that are being ordered to install rocks, and you can see that they say they do this to protect the cables. We're going to talk a little bit about that, because can rock berm prevent cable fatigue failures? And what I learned when I speak to the cable installers, they say totally depends on the design of the cable protection and the rock berms. And I think this is very correct. And in theory, it should prevent the cable failures, absolutely. And in the analysis, with assumptions that the CPS is not sedimented, so that the cable actually works, so that it's a tube-in-tube system, it's allowed to move inside the CPS.
it should work and it could work. And when the CPS is basically being based into something where the granular size of whatever you put the cable protection system into actually forms something that is relatively elastic on the outside, basically forming a soil spring on the outside. That works fine, and it worked fine when we put it into sandy sandy seabed, for example. And this is defined in, for example, the best practice that came out from the Carbon Trust exactly a year ago. They launched this CPS best practice. So why are we having these cable issues? And we basically have these cable issues because of this elephant in the room. And the elephant room is not a new digital animal or something. It's actually these non-disclosure agreements that we have, that the information I have myself, the information that most of the people in this room have, they are not allowed to tell other people. So unlike what Michael Brook told from his experience and some of my experience from the oil and gas days with pipelines and so, where we were basically, we had to share the information with other companies. We are not sharing with other companies. Even the companies don't share it with the colleagues in the same companies. So lessons learned within one company is not even told to the colleagues in the company. So a company that basically should tell, well, here's really something that could be a lesson learned that we could basically build on and make sure that we learn something from, is instead treated as a tragedy. So it's a bit like when we sunk in Norway. We built a massive structure in oil and gas, and for some reason we sunk it in a fjord. And then we had a good friend here just before. I think he was a lawyer, and he said lawyers are good. So they called the lawyers of this company and said, what are we going to do? And the lawyers said, well, call all the carpenters and we were going to build a big wall around this area where this structure sunk into the fjord so nobody could see that it had basically disappeared. The problem was, of course, this structure was so big that they could actually see the seismic activity in the next city where I live, in Bergen. So in Bergen, we could actually see that there was seismic activity in Stavanger, where this structure had hit the bottom of the fjord. So it's not always smart to try and hide your things. But what I'm getting back to here is that the reality that we do in offshore wind here is that the analysis with the right assumptions, with the right models, predicted the wanted results. And what was then the wanted results? The wanted result was that people wanted the analysis to give you a result that predicted the cables would work fine for 35 or 40 years. And that's what you got. So that's what the suppliers gave you. That's what the developer accepted, and that's what the third party happily accepted. So why did the cable fail? Reality is that stabilized with rock berms, cable system has failed. And there's a number of reasons why it has failed, because there's sedimented from the CBS systems are sedimented from start of life, because the impact forces exceed what the local analyses that are being made of for the cable systems, because the rock berms actually provides local point of contact, pinpoint of contact, not a nice fine granular sand size on the outside of the CPS systems, and the rock berms does not provide this CPS elastic support that we are talking about. So, in reality, there's a lot more to it than we basically predicted. So this 60 to 300 kilo grading that you saw the picture of before, that's here again, And I have, for the comfort of you here, I've removed my face from the lower picture here, so you can see the 60 to 300 grading close up, what the size of the rocks. I often spoke to the analysts in the project I worked with and asked them, do you know what a armor grading is? Do you know what 60-300 grading is? Do you know what a 90-250 grading is? And the people that works with rock, they know what it is, but the people that do the analysis, that sit in front of the computers, they have no idea what this is. They think this is tennis ball size. Some of them think this is the millimeters of the rocks that we use. And I tell them, well, a tennis ball size rock doesn't weigh 90 or 250 or 300 kilos. You know, they don't relate to this. They don't understand this because they don't relate to it. They can control the computer program. They can manipulate the computer program. Unfortunately, their powers only reach to their computer program, their analysis. They do not have power over the nature. So when they produce the program that predicts that your cable system will actually work for 35 or 40 years without problems with the FLS, that doesn't happen in reality. And that's a big issue we have. So the lessons learned that we had, for example, in Hornsea 1, where we took out 27 cables because there was a small hiccup in finding out where the inline splices were. So we pulled out 27 cables within 3 weeks after we installed them, not because it was fun, but because there was a small argument between the developer and the cable supplier. So we basically pulled out and we found out all these cable protection systems, they were filled up with sediment within 3 weeks. We didn't have any big storms, any even small storms in that period of time. Some of the cable systems have only been installed for less than a week after they were being pulled out, but they were all completely filled up with sediments. From this incident, we knew we had a lesson learned. Cable systems are sedimented from start of life. And to my history, this happened 3 or 4 years before this best practice from Carbon Trust came out and said, well, this is a tube-and-tube system. The cable is free to move within the CBS system. That's a lesson learned, just gone under the carpet. We don't learn from our experiences. Rock berm, if you try to move a cable inside the rock berm of this 60 to 300 grading that you see here from the quarried rock, it's not going to move. I tried to pull over a 30-ton excavator with this in the testings I've done with this. It's not going to move. None of the rocks are moving. It basically interlocks nicely into a matrix. So all the things that we in the analysis say, the system will do, our rock berms will actually help the CPS doing this and this to accommodate the bending radius of the cable so that the cable will actually reach this fatigue limit state is something that works fine in the computer, in the software, in the Orcaflex, but not in the water. Last thing, why is a cable flexible? Cable is flexible because the components can slip and stick inside the cable. So if you basically put a certain amount of pressure on top of the cable, you basically stop the cable from being flexible. So the reason why the early cables without any stabilization worked was because there was no load on top of the cable. So when we start basically pinning down cables with ballast, we basically prevent the cable from being flexible. And this is a problem when we then, at the touchdown point, pin down the cable with ballast weight. The root causes, I'm just going to show this because even if we did fill up the cables on the outside with ballast all the way up to the apertures of the monopiles, we would still have movements of the cable systems because through the replenishment holes of the monopiles, we will still have jettings. So on the one-year return storms in German Bight, they measure 10 meter per second water jettings that actually moves the cable about inside the monopile, inside the free-hanging cables. So even if we try to stabilize the cables on the outside of the foundations, we still get movements of the thing. So basically trying to stop the cable from moving on the outside is not fixing the issue, because it's not stopping the root cause. So this is trying to mitigate a problem by not really attacking the root cause. Third thing, why do I talk about simple logistics, is really if you want to stabilize cables with the scar protection, you cannot really place the scar protection as effectively as these nice rock dumping vessels. Excuse me for the dumping vessel again, but I'm going to use that word for the rest of the presentation. They can place the vessel, they can place these scar protection very efficiently, but they cannot do that very efficiently with the size of armor on top of the cable systems. That would simply damage the cable on the impact. So if they could install the armor layer with the same efficiency as the filter layer, they could install this. They can install the scar protection with more than 50% higher efficiency. That would lead to that you could reduce the cost and the CO2 emission of the scar campaign by quite a lot, more than 50%. And you could, of course, reduce the cable repair operations when you have to repair the cable, because you didn't have to remove the scar protection on top of the cable. That basically led to, is there an alternative solution to this? And this is basically, there is an alternative solution. You can stabilize a cable on top of the scar protection. You can put a construction on top of the scar protection and actually stabilize on top of the scar protection. It's possible, and that's what we basically done with a system that's called the Portner stabilization system, where we anchor the stabilization system through the scar protection into the seabed with screw piles. We do that with an ROV. We can do that with a tracked ROV, or we can do that with a work-class ROV with a variable buoyancy system. The idea is that we can stabilize at the pull-in, and the big issue that we get here is that we can stabilize after the scar protection is in place, and we basically can stabilize right after the cable is pulled in. So we don't have any risk period. No, there's not a non-stabilized period, which is a big issue for especially HVDC cables, but I would say for most cables, if not all cables. And we basically get it stabilized at the touchdown point, because we position this over the touchdown point, so we don't have any references to the foundation. We actually have the reference to the touchdown point of the cable system. So we remove some of the accuracy tolerance issues that typically are around the offshore installation, where getting something in position with plus minus a reference of 1.5 meter probably is the best you can hope for. So if you compare it to a rock berm with a PSS, we solve the root cause, we prevent the cable fatigue, we are out of the critical path. With the rock installation, we can basically achieve a more simple logistic, and we can get the instant stabilization after the cable is being pulled in. So we basically don't have this high risk period after the cable is pulled in. That's the big pros of this system. So, questions?
Thank you.
Henrik, I don't have to introduce myself. You know who I am. René Verkessel, ex-Van Noord, now Capability. I've been doing a lot of presentations on rock installation, as you well know. And I happen to disagree with you. And first of all, because One of the things I would like to remark is that 60 to 300 kilos of armor rock is not what is commonly used for post-installation or post-protection of cables. So there are a lot of points which I could discuss, which I'm not going to do, but the only thing is I'm now at a turning point. Either I give a presentation today on the installation vessels, or I take out an old presentation on rock installation. It's for the audience to decide. We can do both.
Well, we can agree on that we disagree, but I don't think that's going to help anybody.
Okay. But maybe you two can fight it out then during lunch break.
It's 10 years already.
Yeah, okay. Good. But do we have a question then to Henrik? Then I'll ask one. You showed examples that we knew as an industry about an issue, and then despite knowing it, it didn't seem to reach the decision makers on future projects. Why do you think that is? Is that we forgot to tell them, someone was trying to hide it, or it was easier to assume that the problem isn't there, so it isn't there?
No, the issue came quite clearly with the when we had the abrasion on the cable, when the cables were inside the when we had the hypermobility of the bend restrictor-based cable protections CPS systems, where they actually rolled over when we started to extend the scour protection, then as the CPS systems got longer, so before they were the burial points, so the distance between the foundation and the burial point became longer. The distance that the CPS covered on the scour protection got longer, and this was a mobile area, and where the bend restrictors became rolling systems, and with the internal sedimentation that I discussed, this got deburring machines that basically, when they rolled over this, they abraded the cables very fast. So here we had the example where first it was pulled out on Race Bank, where the cable was destroyed after 2 years and 4 months in operation, where the similar in the Taiwan Strait on Yunlin, the very same looked exactly the same. The cable looks like a rag doll. After a little more than 10 months, I think 10 months and 13 days or something, the cable failed after operation. So this initiated the stabilization process. Now people are saying we don't have cable fatigue because it takes longer for the cable to fatigue than it takes for the abrasion. One must remember that the cables that we put in now, people say, well, the cables get older and older. This is correct, but if you look at the accumulated life, what is the age of the cable that actually is out there? With all the new cables that we throw in, the average life of the cables is actually getting younger and younger because we throw so many cables in. And we only have stabilized the cables this way. We started doing this Ørsted started doing this with 350 cables in 2020. In 2021, they did another 450 cables. So they had 900 cables stabilized in 2021. Then other companies followed suit after 2022, or in 2022. We now have 3 years where this have happened. Ørsted now have to fill those where they're using dynamic rock berms, where they're using, and the grading they use is 95 to 50. So the sizes they are using to stabilize those rocks, the cables with, are between 95 kilos and 250 kilos that they use to stabilize the cable. It's only been out for 3 years, and now they have to refill those. So the fatigue on the cables is going to happen, and it's just like doing a crash test, and you stop the crash test just before the car hits the wall and say, it looks fine, nothing is happening.
Thank you. Good. But then, do we have any more questions? Yeah, we have one question here.
name is Roland Zhang. I'm from Tenet Asset Management. I think this is a very good point. But my question is, could we do some experimental testing and standard testing to simulate it such worst case onshore, and then we introduce some the test method, and then we can see simulated worst case, and then we can see, because we always ask such combination CPS, cable, and together, and can survive for the whole service life.
Yes.
Yeah.
Yes, the problem, first of all, yes, we can. The issue is that when we do, even though that we think we do 3D testing, you know that we only do 2D testing when we do multi-point testing. So we are looking at, in the Flowwick in Aberdeen at OIE, we are thinking about setting up, and I'm discussing this also this afternoon with OIE, to set up in a point-to-point where we have one cable that is locked, like it's pinned down by weight, and one that's pinned down by the PSS. So we actually do that in try to do that in 1.6 million cycles, and then see what is the fatigue in those two conditions, to basically be able to tell cable owners what are the fatigue, and then can give some kind of predictive information to people, what are the fatigue going to be, and hopefully give to cable owners an indication what is the fatigue on your cable systems likely to be, and do you want to sit and wait till the cable failed, or could you actually can you actually initiate some kind of mitigation where you could plan for do something before the cable fails, and actually do something about it before the cable fails, or whether you will accept okay, the cable may fail after 10 or 11 years, and then you will have to exchange the cables. Yes?
And to elaborate on that one, there is another study ongoing in Holland at the moment, and you're part of that one as well, as far as I know.
Yes, but that's heavily loaded under the, Stone Age approach, where it mostly will be just rocks.
I think that all the other contendants there will not be rocks only.
Okay. Good.
Yes, there was another question over here.
If we could, for the sake of time. Yep. So thank you very much, Hendrik, and you can discuss them later. Okay. But then let's move on to the next presenter, and that's Chas Bradbury, Director of Operations at Paratus International.
Can I use this one? Is there any chance I can use this mic? Is that okay? Because the chances of me standing still are, minimal, I would say. So, brilliant introduction from Henrik into cable protection systems, and maybe why the current state of the art isn't all that it could be. So I'm going to give you a quick one slide about Paratus, because no one's ever heard of us, and then I'm going to talk about CPS designs, alternative CPS designs, and other ways of doing things. So first of all, Paratus. We are a subsea engineering and design consultancy. We've got about 100 guys, 4 offices worldwide. And we've done quite a lot. We've worked for quite a lot of people in the room, actually. Worked for Sumitomo, ENBW, done some work for the Catapult. So, if you haven't worked for us, why not? You're missing out. And we've done a lot of work in various offshore wind projects, as well as quite a significant amount in oil and gas as well, involving pipelines, umbilicals. Effectively, all we do is subsea engineering. Now, CPS failures, they are well known. They are spread throughout the industry, and they are expensive. And Henrik's pointed some of these out. There has been abrasion of CPS against the scour protection, which has caused failures. There has been abrasion of cables within the CPS system that has caused failures. So it is a well-known issue, and I bet you there are probably more people in this room working on CPS failures and CPS systems than we might initially think. So there is an issue, and there is an issue that needs to be solved. And And this is what we don't want. Well, this is what we're trying to stop, like the cable movement. And that movement is caused either by direct wave action or from vortex-induced vibrations. There's a first and second mode vibration there. I probably should talk a little bit about analysis after Henrik's presentation. Yes, there is flow acceleration around monopiles or jacket legs, and that can be accurately modeled. And yeah, the cable protection system and the rock dump and the rock berm, the rock installation, can also be effectively and accurately modeled. And actually, we should probably I'm just going to take a couple of minutes out. I wasn't planning to say this, but cables on rock move differently to cables on sand. So there's a new British standard that came out last week, I think it was maybe the week before, BS 10009, cable stability on rocky seabeds. And basically that looks at the effect of cables on rock, and although it's not specifically relevant to scour protection because it is really looking for cables on seabeds where the rocks are roughly twice the size of the cable, actually the underlying physics is correct and can be applied to cables on scour protection. And that is, and especially the bigger the rock, and as Henrik said, there are point loads. So the cable does not sit on a flat, smooth seabed like it's sand. It is supported at a number of discrete points. And what that means is you don't just get flow going along and going over the cable, you get flow that comes to the cable and then ducts underneath it and on top of it. So wherever there's a gap under the cable and you can get flow under the cable, that cancels out any lift force above the cable. Now this isn't new. I mean, there was some brilliant research done on that standard by the University of Western Australia, but this idea of the flow going above and below cancelling out the lift force, that is in DNV 81. There's a curve that shows how you can reduce the lift coefficient. So cables on rock are actually significantly more stable than they are on a sandy seabed. And that can be taken into account, even if it's scour protection, you've got a rock roughly the same size as the cable, that reduced lift coefficient, and there is a reduced horizontal coefficient as well, but that can be taken into account in terms of your analysis too. So worth bearing that in mind, because the cables may not be moving as much as you might expect. So this is a picture of a cable within a cable protection system, and you can see that actually based on the analysis and all the foundation stuff has been taken out of this, there is quite a significant amount of movement that we need to restrain or at least engineer and manage that movement. And this is what's usually done at the moment, and we've all seen these, and this is similar. There's quite a similar diagram in the Carbon Trust guideline as well. And what we have is a very complex system made up of a lot of different parts, and all these bits have to be installed offshore onto the cable before it's pulled in. All of them have potential for failure in their own ways, both in the installation and actually during the operational time. And there are a lot of issues with those. The bend restrictors can fail. And as I've shown on that little animation earlier, the whole thing can still move. You know, they are susceptible to, especially to direct wave action, but also potentially to VIV. So there will be fatigue issues with your cable protection system. Anything that moves will suffer from fatigue. There will be abrasion as this thing moves around across the seabed, or if the sedimentation gets into the CPS, there will be abrasion between the cable and the CPS. They are potentially vulnerable, and as Henrik said as well, you know, Ørsted and their cable rock dumping campaign, if they are not adequately restrained and you cannot accept that movement, then you will need to use some secondary stabilization, use some rock bags or some rock installation to ensure that they don't move. There's also a minor thermal issue, but effectively they are not potentially the ideal solution, and there's lots of issues that can go wrong and obviously have gone wrong with them. So we had a look at a number of different ways that you could stabilize some cables. So basically, we were asked by one of our clients, they kind of said, we don't like CPS systems. We're going to build quite a big wind farm, and we're not sure they are the right thing. They're the right solution. And at the same time, actually, we're also asked by an oil and gas client who had a CPS for an umbilical effectively fail. And they kind of said, well, what can we do as well to, we don't want to put another one of these in. So we started looking. So I'm just going to run through, like, you don't have to have a CPS. You could have a pile of grout bags and put your cable on those grout bags. That would give you stability. That would be no moving parts, very easy, very simple. Or you could do the same thing, but make it out of fiberglass. You have a solid support that you could install and you could use instead of your CPS. So again, physical restraint, lump of plastic, dead easy, no moving parts. This was specifically for that application, but you could just put a steel frame around it, like a cage. That will hold the cable, stop it from moving, stop all that nasty kind of like wanging around, because the cable doesn't just move sideways either. What we've seen in the analysis is it can come, I'm at the risk of looking like a breakdancer here, but it doesn't just move sideways, it can do a kind of whipping movement as well. So it's important to get that analysis right, and this would stop that as well. Shrouds, again, very often used, good long track record, reduces any hydrodynamic loading, removes it from that suspended section of the cable. Very well understood, very well known. Or just even a simple hold-back clamp. So the Protonus one was a clamp onto the seabed, but you could have just a simple hold-back clamp going back to your monopile or back to your jacket, just holding the cable and reducing the amount of movement that you allow the cable to have. Obviously, again, long track record, very simple solution. Needs some design work to make sure you don't get fatigue points, because you've got a much more rigid point here in the cable. And needs some work to ensure that you're not breaking it up into a number of sections that will then give you multi-mode kind of VIV response through the different sections of cables. But again, a simple and relatively effective solution. Weights. You can make the cable heavier, you can attach weights to it. Now these are the kind of things that are quite often used with dynamic cables, where you change the shape of the cable and you change the catenary. You may have a lazy wave or whatever else, but you add weights and you add buoyancy to get that shape that you want. And you could massively increase the mass of the cable to ensure that the movement that it has is much smaller. So another solution. Strakes and fairings, I mean, again, you see these on chimneys all the time to stop VIV. They'll break up the flow around the cable. They won't stop your direct wear. We wrote this guideline about how you actually go about designing a cable protection system. And actually, what you need is something that will restrain that movement. And it's really only restraining that movement where you're going to get fatigue damage. So it's those an argument that actually, if you know you're going to go and rock dump your rocks, install your cable, then actually, or put some anchors on it, or whatever you're going to do, you need much less. You need much less cable protection. And there are a whole load of things that you should consider when you're doing this and when you're designing it. It's not just about the movement of the cable. There is also impact. There's also actually, can you go and fix it if it breaks? Can you pull it out again? Can you put it back in? Are there any thermal issues? So there are some design activities that are needed. Okay, so lots of potential issues with cable protection systems, lots of potential problems, and lots of interesting solutions. And this is another solution that I'm going to show you now, which I think gets rid of most of the problems. Here's our J-tube. Here's a little ROV. Comes along, finds a torque bucket, telescopes a J-tube down to the seabed. Now, all of a sudden, you no longer have a free spanning section. So you no longer have a length of the cable, I don't know, 10, 15 meters from 3 or 4 meters above the seabed down to the seabed. That has gone. So you do not have then any VIV issues because your cable will be on the seabed. The other thing is, your cable is laying on the seabed in the J-tube now. All you need to do is drop a couple of rock bags on it or a couple of mattresses, and that cable is stable. That's not going anywhere. That is not going to move. So you have a very, very simple system. There's no bend restrictors needed because there's no movement. There's so the whole thing becomes much, much simpler. And it's effectively a telescoping J-tube. If the cable is no longer moving because it's laying on the seabed and it's got a mattress on top of it, then you do not have any abrasion issues. You do not have any fatigue issues. You do not have any overbending issues. So yes, you have a rack and pinion which needs to be built and needs to be installed. So there's a slight more amount of complexity there. But in terms of operational life and potential for failure, there is a massive win because you are eliminating almost all of those things that are causing those issues. Oh, and there it goes down to the seabed again. Just a little couple more details there. We stuck a mud mat on the bottom to ensure you don't get sediment poured in. And you could pull this in with it being half a meter above the seabed, above the scour protection, and then lower it. It's not an issue. We started doing some modelling on this. We did modelling using typical pull-ins from 3 meters above the seabed down to half meter above the seabed, and then actually on the seabed as well, looking at the different loads that the cable would see, and as you pulled it in, this is like an animation of a sausage going into a drain pipe, and there it goes. I'm really hoping to get a better one soon. But basically, those what those showed, slightly more. This was it again, going up into the thing. So it's very possible to pull your cable in along the seabed, and actually the maximum tension it goes up a bit, as you might expect, because you have more cable on the seabed. So you've got more cable on the seabed, you've got more friction. Pulling loads are going to go up, but they haven't gone up massively. They certainly haven't gone up, and this is completely non-optimized design. We haven't really configured the bell mouth on this. We haven't really configured the J-tube bend there. So I think you could probably play with that and get it down a bit. But there is a slight increase, as you might expect, because there is more friction on the seabed. But it's not massive. Span length. So this is the length of cable between the bell mouth and the seabed. And what's interesting, so 2.5 meters, it's kind of 10, 12 meters. But actually, even when the cable's on the seabed, it's showing a span. But I would say that's an analysis artifact. The span shown is 13 millimeters high. So although we do have that span length, in reality, you would not have that span length. And that is the span that is showing immediately as you have pulled the cable in. So actually, if you relaxed that cable by, let's say, 13 millimeters, for instance, that would then drop down and you wouldn't have that span at all. So there is absolutely kind of like the modeling we have done so far has shown that it really is quite plausible that you could pull in a cable without too much additional load and it would sit on the seabed without any kind of significant or meaningful span. So, just to sum up, we know that CPS systems are an issue. There are a whole load of systems. It could just be grout bags or something else that could be put down and used instead. They don't have to potentially be so super complicated. And in terms of JLO, our little lowering J-tube, we're working on that as a little internal research project at the moment. I think there's potential in it to go further, obviously, but we are only doing it when I don't have actual real paying work for the engineers to do. So if anyone would like to invest in us and give us some cash to develop it further, we'd be very happy to take that on board. Thank you. That's it from me.
Anybody else then, René? Can we have a microphone here first?
Sorry.
Anyone other than René? Yeah. You know I'm going to ask you a question after your presentation now.
Yeah. Hi, my name is Yvonne from ENBW, and my question is, because you show now also in the picture there are monopiles, but the JLO would only work for jacket type of foundation.
Yeah, I think it has much more applications for jackets. Yeah, absolutely. And it's actually, we are looking at it with one of your substations in mind, actually, as well for jackets. Yeah.
Are you considering adaptations for monopiles? Because I think at a previous conference you considered a slit in the side and then.
Yeah, at the moment we're concentrating on the jackets for now, because I think that's where the biggest opportunity is. And then, as I say, it's quite difficult because we are a relatively small company. So trying to do this as an internal project, when actually, we sell engineering hours is what we do as a business. So it's not as if we will ever, make any money from making these things or anything else. So it's quite difficult to kind of widen it. We're trying, I think once we get some proof of concept and keep going and keep the modeling going forwards, and then I think we can spend a bit more time looking at other applications for it as well.
Perfect. Good. Go ahead, Srini.
Am I allowed? Now, first of all, a question regarding your presentation, which was quite nice, and in the end was becoming even more interesting because that was my initial question. However, it's did you take into account scour and scour protection? Because even if you're looking at a monopole or a jacket, at a certain moment when they are installed, you will have definitely scour. And either you do scour protection up front and then you're putting everything on top, you lower your J-tube on top of the scour protection, or you lower it on the seabed and then you have to do something afterwards because of the scour.
Yeah, so absolutely you could lower it on top of the scour protection and then just stick a mattress on top of your cable on top of the scour protection. That would not be a problem at all.
The other thing I would like to mention is that this solution with monopoles has been initially used already in 2007 and in 2009 on two of the projects I was involved in which there was a telescopic J-tube lowered into, there was no scour protection, no pre-installed scour protection, just put in the foundation, let the scour hole develop, lower your J-tube with a cable inside, lower to down into the scour pit, then fill up the scour pit. You don't have any issues anymore.
No, I mean, I can see a few issues with that solution straight off the bat as well, just in terms of tension and protection of the cable and bits and pieces. I think I would prefer to put it in after the scour protection.
I can understand, but it's still working after 18 years.
Brilliant. That's great.
Good. Then one last question.
Just a very quick question, Michael Brooks from TGS. Your system goes in. What you haven't said, which I presume you will do automatically, is that you will monitor it post-installation inspection over a period of time, or continue throughout the life of the product.
Yeah, absolutely can be monitored, and we've done a few pull-out cases as well. If the cable breaks, you can still pull it out. The J-tube is strong enough to take that and that kind of thing. But yeah, I mean, it's not a... I'm not saying you should put that in and then not do any monitoring of your cables, no. And in fact, in terms of wind farms and subsea cables in general, I would advocate always for more monitoring than is currently being done in the industry.
Perfect. But then can we move on and then take those discussions in the break? Thank you very much.
Thank you.
Okay. Now for the most challenging part of my task here. So our next presenter is Angeliki Georgiopoulou, Geoscience Manager at Turn-On Energy. Did I do okay with the name?
Very good, actually. Thank you. So I'll use this one as well because I'm too short for the lectern, so you won't see me. So yeah, I'm the Geoscience Manager for Turn-On. Turn-On Energy is a marine geoscience and engineering consultancy. So I will give a brief introduction into what we do. Is it the central button to move forward? Yeah, okay. So it's going to be slightly different, probably resembling a little bit what Daniela was saying earlier or John this morning. I want to highlight how important the shallow ground model is in everything we do cable related. And I understand, I mean, this is a power cables forum and interconnectors. These are not really activities that are employed with telecommunication cables, which I'm a bit surprised, to be honest, with. So I'm just going to, I think I'm speaking to a room that is aware of all of these things as well. So I will talk briefly about the hazards to cables, route engineering, cable burial risk assessment, the burial assessment study. And I've put at the end the shallow ground model because I believe it underpins all of the other things. So we need to understand how the other things work before we decide what we want, what we need from our ground model. So Turn-On Energy, we're about 9 and a bit years old. It was founded in 2016, started as a one-man band by Mark Finch. He's our CEO and founder. And now we're about 20 people in total across 4 offices in the UK. Headquarters in Aberdeen, another office in Edinburgh, one just outside of Oxford, and one in Brighton, which is where I'm based. These are the services we provide. So like I said, we are a geoscience and engineering consultant. So lots of geotechnical support or geophysical support. And this is how we've divided the services that we do. I can speak about this individually to anyone interested. These are the clients that we tend to work with. All of them repeat customers, actually, as I'm looking at everything we've put there, so multiple projects with all of these people. So let's dive in. Hazards to cables, generally divided into natural and human anthropogenic. So from natural hazards, there's not a lot, really, that cables can cope with. So as a geologist myself, I see this as a very kind of temperamental thing. So there's a lot of things we need to negotiate with. We need to negotiate with the steep gradients, lithological variability, which may be caused by buried channels, sediment mobility, so generally high speeds. We don't like very low strength materials, but we also don't like very high strength materials. We don't like rock, we don't like gravel, we don't like boulders. There's a lot of things, really, that when we're trying to design a cable route, we don't like. And then there's all the anthropogenic things. You know, there were questions earlier about what happens with cables that are left on the seabed. You know, and you have to cut them, or active cables that you have to negotiate how you cross them. There's pipelines, there's other users like the fishing industry. So all of these things need to be taken into consideration when we're doing anything cable related. So ideally, what you want to do is you want to avoid them. The first approach when you're dealing with all of these hazards is that you're going to try to avoid them as much as possible. So you need really good data. Daniele pointed out that earlier about Italy, especially where you have complex seafloors. Can't stress enough how important the good data set is. So you're going to identify your morphology. This is from south of Ireland, actually, so there's a lot of exposed bedrock along the coastline. So you'll identify all of these. But again, in trying to avoid them, you always have to bear in mind that you don't want a very long cable. And there's a lot of things that you can't do really to thread the cable through the hazards either. So the length, the economics are going to be really crucial in what we do. So let's say, we've defined our ideal route, at least at a very early stage, and then we move on to doing the cable burial risk assessment. For anyone in the room that doesn't know cable burial risk assessments, it's a probabilistic analysis, basically, where you take into consideration vessel traffic, the fishing risk, so basically the contact of any fishing gear with the seabed and how deep it can affect into the seabed, and the local conditions. Combining all of these, you come up with a risk profile in different segments of the cable. So this is an example of the different segments of a cable where you're going to zone it according to the local conditions and add to that any other features like mobile sediments or high density traffic. Maybe it's a specific traffic channel, for vessels. So can I go back with this? Is it this one? Yeah, okay. So once you have defined all of these, then you create profiles like these for the different zones. And what these profiles are showing you is we express the risk as a return period for that risk to occur. So in the top one, you can see that if you have a depth of lowering that is 1 meter, you have a 10,000 year return period. If you increase that to 1.7 meters, then you're increasing your protection, essentially reducing the risk significantly. But in the lower diagram, you can see that you can do any depth of lowering there, and the risk profile doesn't really change. So really fundamental piece of work. And once you've done that, so you've defined the depth of lowering, you feed that to the contractors, and then you go into doing the burial assessment study. And as many of the people in the room know, there's different ways of doing the installation, either simultaneously or post-lay burial. All of these, they tend to, it's not a linear process per se. So when we work with clients, especially in the bigger projects, we tend to go back and forth. So we'll do a CBRA, we'll realize that there's high risk in specific segments, we'll go back to the route engineering and refine the route. Or we'll get to the BAS stage of doing the burial assessment study and realize that because essentially it's a feasibility assessment, the burial assessment study, we might find out that it's too expensive, again, very challenging, and again, go back to the route engineering and refine the route again, redo the cable burial risk assessment, and on it goes. I mean, not endlessly. There will be a point where you have to stop, but it tends to be a feedback loop. One feeds into the other and then back again until you have the best outcome. So key in understanding that when we go into the installation stage, what we tend to look at is what the trenching capabilities are of the equipment that we're going to use. What slopes can they manage? Can they manage variability in the subsurface lithology. What depth of trenching can they achieve? How much can we push it really in these particular locations? I'm going to put in the center of all of this the ground model. So this is what I was trying to get at. All of these practices, all of these processes need to be underpinned by the ground model for many reasons. To do this correctly, to reduce your risk, to reduce uncertainty, but also to not over-engineer. The more you know about the geology, the more you know about the geology and the conditions of the site, the better decisions you're going to make, the most appropriate decisions for the specific site. So what is a ground model? It's a 3D surface. I would argue that it's a 4D understanding because you need to understand the evolution as well. So let's put the time parameter dimension in it as well. So usually what it will contain is the seabed morphological features and their descriptions, their distribution, the subseabed lithological variability, really, really crucial in understanding, and this is actually the most challenging part, understanding how that changes laterally, the risks and the hazards. So there usually is going to be a risk register that comes together with the ground model. But what I want to highlight is that it needs to be fit for purpose. We tend to use ground model singular and say we need a ground model. I would argue that we need multiple ground models for specific things that we do, because it needs to be addressing the questions that we need answered for that particular process. Is it cable laying? Then my ground model needs to have enough detail in the top 5 meters. I don't need anything more than that, but I need enough detail in the top 5 meters. The ground model that we produce for foundations goes down to 60, 80, 100 meters. It tends to ignore that top 5, 10 meters. Even the data collected tends to ignore that top few meters. So, like I said, I mean, different developers are going to define a different depth of what they want for the ground model, 5 meters, 10 meters, but usually not deeper than that. Something that I've often seen in ground models given to me that is missing is the base of the mobile sediments. So a lot of interpreters are going to go and interpret the base of the Holocene, the most recent sediment post-Quaternary, but they're not going to define the mobile sediments that form part of this. And the reason we need that is that when we're doing cable burial risk assessments or burial assessment studies, we hang everything from that depth. That's our reference level, because there's no point defining a depth of burial or depth of lowering within mobile sediments, because in due time they're going to be exposed or overburied, etc. So we needed to identify the hazards locally. We needed to have the risk register. We need all of these. But mostly I want to highlight that we need the data that can actually feed into these top 5, 10 meters. So sometimes this is what we get. And the reason I've highlighted in the yellow box that one, if you can take a minute to read it, or I can read it as well with you. Interbedded, loose to medium dense, fine to medium sand, and low to very high strength clay. Low to intermediate plasticity clay, high strength, 3 meters, with occasional gravel in top 3 meters. Basically everything. So how do I design for that, right? So that has a significant flow. What kind of unit is this? You know, even if you map that unit, it doesn't really give me any understanding of how the conditions change, because you've bundled everything in it. Here's another one. In this case, we know that the top 2.5 meters are sand. We have another profile where the top 2.5 meters are high to very high strength clay, and I have data for that strength. Or I have a third profile where I've got this high strength clay overlain by that sand. Clear, I know how to design. So we want to avoid the top, we want to aim for the bottom. It may look simplistic, but this is what we need for engineering design. And overall, let's not forget, because it has come up, like with the Posidonia. I'm originally from Greece. This is also an issue in Greece as well. Highly regulated seagrass, really indicative of the environmental health of the seas in the Mediterranean. So everything that we do, we want to minimize our impact on the seabed. And the way to do that is to really know what we're going to encounter there so we don't end up over-engineering, like I said earlier. So just to summarize with 5 minutes left, so the shallow ground model feeds into everything really that we do up until installation, and I would argue even afterwards for all the operational and maintenance activities. So it has a very paramount importance, and in fact, it's not very expensive. It can save a lot of money from faults and failures that you might encounter down the line. So it's not a very expensive thing to produce. And the pitfalls, because I promised I would highlight some of those, is that very commonly we don't see the base of mobile segments defined, so that's not useful. Sometimes we get a ground model that has too many zones, so it's too detailed, and again, it doesn't help with planning. Or it doesn't have enough information. The amount of times I've received a ground model that has only geophysical units and no geotechnical data, I can't, I mean, this is more common than the other way around. So, and that's me.
Thank you. Do we have some questions? Oh, everybody is saving up for René. Then I have a question. So you just mentioned that often the quality of the models is not great, or not the models, the data, the input data. Both, well, as a result. But do you see ever massive discrepancies between what the data would have suggested and what is then encountered in the field?
Very interesting. We don't really get that information afterwards, which is actually, sometimes I've been able to contact, when they've gone out to say, can you confirm, that you've encountered what we thought you would encounter? But this is like, I don't know, 2% of the times I get that feedback, that information afterwards. I hope that the fact that they are not chasing us afterwards is because they were happy that we had predicted correctly what was going to be there. Yeah.
Okay. And maybe another question is, it's one thing to design or engineer a very good solution. It's another to then be able to execute it. How do you take into account what tools are available and which to use? Because the perfect solution is expensive, and what's good enough?
Yeah, specifically like for installation, for example, when you're looking at trenching equipment, it's almost impossible that you're going to have a site that doesn't have variable conditions. It's almost impossible that one solution will be fit for the entire site. So in that case, budget really matters, but in that case, either you're going to go with a combined solution, or you're going to end up implementing some kind of cable protection system for the parts, so whichever trenching equipment applies for the majority of the site, and then for the rest of it, you're going to accept that you're going to have to protect in another way. One of the things that we do at Ternan is, so in order to avoid that kind of problem, is we can assist during the trenching operations with doing a live CBRA, so we can give advice on whether you need multiple passes, whether you can reduce the risk profile in different zones. So, and again, this helps with doing a more targeted approach than with the protection afterwards.
Perfect. Okay. Any final questions? Last chance. No? Okay. But then, thank you very much. Now, our next speaker will be René van Kessel, consultant submarine cables at Cable Ability.
Thank you, Jacob. This is not going to hold, so I'll put it there. Good afternoon, ladies and gentlemen. I'm in between myself and lunch, so I don't rush it a little bit. And don't be afraid, I'm not going to talk about rock dumping, neither rock placement, neither rock installation. I'm going to talk about cable installation and the status. And in short, it is what's been, what's now, what's come. So let's start. Just a little bit introduction of myself. As I said, I worked 30 years for Van Oort. 5.5 years ago, I started as a business development consultant. There are two companies I'm mainly working for, one is Wind Subsea Cable Services, a logistical company doing transport, storage, intermediate as well as long-term storage of power cables and also all the cable handling. Most of you are pretty well familiar with that company. And another company, which is a daughter company, it's Drafttech, which is designing and engineering, building, commissioning and maintaining high-end oil and gas equipment and also cable handling equipment. And the third one I'm doing is I offer assistance to this event, the Lead Vent organization, mainly in Amsterdam, organizing site visits next to the conference. Let's go into what I'm doing. I go quickly through it. You have the cable manufacturers, it's very simple. You have the inter-array cables, export cables, and the interconnectors. And what you see, the various factories, the first time I went into a cable factory was in 2004, was the Karlskrona factory of ABB. That one was empty. And at that time, they were really telling me, we don't know what we do in power cables anymore. We want to close our factory. Nothing is going to happen for the next years. Now the third factory in Karlskrona has been opened, and so on all over the world. Factories have been opened all the time. You have in the States, you have the Charleston one from Nexans, and LS Cable is building a factory. Prysmian stopped building a factory, and Hellenic told there was going to come a factory, but it's been quiet since Trump came into service over there. Looking into Europe, I'm not going into too much details. There's a lot of factories coming up. Some of the factories have disappeared. There have a lot of plans being made. Sumitomo is building one in the UK now. LS Cable has plans. XLCC has plans also to build a cable factory. I've got my doubts about that one, but that's something, my personal view. And Piccola, there are many cable factories, and also in the Far East, with the main ones in Japan, Korea, China, of course, and there's one coming in Taiwan. Let's go into the various manufacturers. For inter-array cables, there's quite a range of manufacturers who were doing inter-array cables. However, at a certain moment, 3 disappeared because they were taken over by Prysmian, 2 of them, and 1 disappeared completely. Nexans and NKT decided not to go into inter-array cables anymore, so they disappeared from the market, leaving those companies. And I must say that I have question marks on a number of them, and that's not because they don't do it locally, they do it internationally. I've seen Orient is going to produce inter-array cables in Poland. I'm not going to see at this moment other Far Eastern companies coming into the market in Europe with inter-array cables. For a number of reasons. Export cables, more or less the same. You can say TKF it does not do it. I have my questions on JDR. They are going to do it, but I've not seen it yet. And it should be approved when they really produce it. Going into the DC cables, it's a little bit similar. Those are all the companies still being left. You see some of them will not go into DC. And I have some question marks. Again, a little bit about the companies. Do they have DC? Yes. Are they going to provide DC in Europe, for instance, or in the States? Not in the States with the Chinese, it's a little bit difficult, I think. But in Europe, they will come. but not at this moment. When? I can't say. But anyhow, I was talking about cable installation. When I started in the industry for cable installation, power cable installation, around about 20 years ago, we started with cable lay barges. I would never ever use them again. And after that, we evolved into modified sidestone dumping vessels. And those were definitely dumping vessels. But we put some reels on top and we tried to install with them. Marine warranty surveyors were not very happy with it, I can tell you that. And neither were we. And for the larger systems, we used some chartered vessels from the Skagerrak, the Endurance, from Nexans and Boskalis at that time. And this is a slide which I showed 10 years ago. And it gives some, it created some havoc in the industry, to be quite honest. I'm pretty outspoken. And this slide was said, okay, these are the cable installation companies after the last 15 years. These have disappeared the last 10 years, or the last months even, some. And those were the ones still being there. I put a question mark at that time at Shim offshore because there was certain uncertainties. But later on, I was proven right, and they went from Shim to CV7. So they disappeared as well. But I'll come back on that one later, maybe. If you look at the market, if you look at 2010, there was only 4 vessels doing power cable installation. Now, if you take into account all the new built plants, etc., in 2028, there will be around about 52 vessels. The capacity of those vessels have increased from 28,000 tons to over 450,000 tons. So there's been a tremendous growth of the industry. And manufacturing has kept pace with that as well. Just to give an overview of all the vessels we've been here. This is one of the, I think it's the oldest vessel still into service, which is 79. It's the Nexans Skagerrak. What has Nexans done in 2021? A new one, Aurora. At the moment, they have one cable lay barge in the US this time. They charter in the Calypso from Van Noord to assist them, awaiting the new vessel, the Electra, which is coming into service next year and made a splash, I think, yesterday. The latest I heard. NKT. Now, Jacob's getting nervous, what I'm going to say about NKT. It's very simple. It's the Victoria, of course, which was 2017, was one of the first more modern vessels, I think. And secondly, of course, they have announced the Eleonora, which will come in service in 27. A couple of weeks ago, I think a week ago or so, 2 weeks ago, they bought from the ex-Boca Constructor, and renamed it to NKT Isabella. So that's something. And yes, I did not include the Ocean Installer, but that's a vessel of opportunity. It's not a cable installation vessel. That's what you were afraid of. No, Prysmian is the largest cable installation company. And what I'm saying is that what you see now is a little bit, that's the sequence as well. It's the cable manufacturers having their own installation vessels. Julia Verne, old one, 1983, still in service. 10 years ago, they had the cable Enterprise and the Ulysses. 2 years ago, the La Vinci. I was happy to be able to visit the christening of the Mona Lisa this year. The Barbarossa came into service, and they have announced 2 vessels, one for next year, the Marco Polo, and another one coming up in 27, the Alessandra Volta, which is a pretty large vessel. And you see a movement in the whole industry that manufacturers want to have their own cable installation tools, vessels. LS Cable, together with LS Marine, or mainly LS Marine together with LS Cable, had a barge for a couple of years now for local activities. And they have announced a new build, which will be built in Turkey and will come into service in 28. And at the moment, they're using the Endurance of Boskalis for some of the projects in the Far East. Then you have Taihan, the new manufacturer in Korea. They have the Palos, which is a pretty old vessel coming from Boskalis, the ex-Temod Spirit. I'll go a little bit faster through these. ZTT have announced to make a new vessel as well, coming into service in 26. Orient has a barge in China. They have 2 transport vessels. I didn't include them in this presentation because they don't do the installation. And there are rumors that Sumitomo, together with Furukawa, is going to build something as well. But to be quite honest, I put a question mark on those because after the first and initial announcements, I never heard anything about it anymore. You got the marine contractors who have been taking over quite a lot of the cable installation. Boskalis, the Endurance, the Boca Constructor and the Giant 7, 2 more or less barges. Of course, they sold Boca Ocean. The Boca Ocean is their vessel which they are using mainly now for inter-array cables. Of course, they sold the Boca Constructor to NKT just 2 weeks ago. I was still preparing this presentation when this happened. And I got confirmation yesterday, there is a new vessel coming from Boskalis. When exactly, what will be the dimensions, what type of vessel it will be, I don't know. But it will be announced. They may, similar, Livingstone in 2017, Viking Neptune, a modified vessel for operations, and they have announced just a couple of weeks ago as well a new build which will be ready in 2028. Jan de Nul, Willem de Vlaming, an old vessel, an old modified rock installation vessel by the way. Isaac Newton, already a couple of years in service. They bought the connector from EMAS a couple of years ago, and they have announced the biggest cable-lay vessels in the world, 29,000, and that's typically Jan de Nul. Always want to have the biggest one, and if they buy one, they always buy 2. Maybe they get it cheaper when they buy 2, but okay, that's not my not my thing. Seaway is mainly for inter-array cables, I think. They have the Amory, they have the Seaway Phoenix under contract, and they've chartered the Scandi connector, which was the old ex-Maersk connector. Van Oort, my old company, being at the end of the marine contractors because the V is behind everything else, but also I think that they are behind everybody else. But that's personal view. Don't kill me. The next is in 2050. Calypso 2 years ago, and they have Vetach 8, which is a barge which they modified for the shallow water activities. Also Subsea, a new one, a small company, not aligned for anything else, just cable installation. The Atalanti in 2014. The Ariadne coming up. They have announced the Althea, the Avra, although it's a trenching vessel, but it has also 4,000 tons capacity carousel on board. And yesterday they told me that a new one is coming as well. And correct me if I'm wrong, but when I said, no, I have your two new vessels, they told me, oh, you mean 3. So I don't know anything about the last one, so this I put in this morning. NCT offshore, a new one in Denmark, 1 vessel at the moment operating in the Far East. Simos, which is a joint venture onshore, Herbers Kieren, with a very old vessel as well, one of the oldest vessels, the Simos installer, which is the ex-Sea Spider, which at the moment they're doing the installation of the export cables for the Inchcape. NC, with the Kuro, a repair vessel, and the Altera, who is a mix between installation and repair vessel, I think. Correct me if I'm wrong, Jack, but that's more or less the intention. Deep Ocean is coming into the market with the Edda Freya. Olympic Aris is being used sometimes, but I'm not quite sure if that's a real installation vessel. And they have chartered in the Orient Adventurer from DFO from Taiwan. DOF has the Maersk connector at the moment, Scandi connector, which they charter out to Seaway. Dongfang is chartering out next year the Orient Adventurer to Deep Ocean. Some other announcements have been Toyo Construction is building a vessel for whom I don't know. Penta Ocean, exactly the same. I'm not quite sure that it's announced. It seems to be being built, but I can't find anything about it at the moment for whom. It might be that it's for the Japanese Sumitomo or Furukawa for the local market. I wouldn't be surprised. Calypso was very loudly announced 1.5 or 2 years ago. I can assure you that that's not going to be built. And as far as I understand, the company is not longer existing. And of course, we have heard rumors about Telefonica and XLCC going to build vessels as well. But I got my doubts about it. And you have some local areas. I mentioned, I put them in, but that's really for the local market as well in China as in Taiwan. And the Oceanus is also something which I picked up only a week ago. This is just a slide which you can see later on. Not everyone. Prysmian is not going to do inter-array cables. They will do the export cables and the interconnectors, but not inter-array. And so Seaway is doing inter-array cables, but not export and not anything else. Coming back to my previous slide, which I stopped on 2015, there have been some changes and consolidations. It's still the same companies. ABB became NKT, VBMS became Boskalis, CM Offshore became CW7, Prysmian got a new logo, Tideway became Deme, Nexans and Van Noord stayed the same. And just to this is the same slide, a little bit differently ordered. And just come back to all the cable installation companies. Those are the cable manufacturers related installation vessels. Those are cable manufacturers who have or will have their own installation vessels. And there are quite a number of other companies also coming into the market. But I wouldn't be myself if I wouldn't have some remarks on that one, because this is what is and what will come in the next 2-3 years. I have a future outlook. And I'm talking about, it's a very personal view. It's not representing any other view, it's only my own. So if you want to kill someone, kill me. It's all characters are, as you see it in the books, it's not real, it's fictional, whatever you may. I'm just a messenger for myself. Don't shoot me. I'm calling in the First Amendment, freedom of speech. So I'm free to say whatever I like without being sued. I've been sued by CM because of the question mark. I can tell you that. That was 10 years ago. So I'm pretty careful at the moment. Okay, this is the slide I stopped with just before. I don't think that those companies which are being crossed now, Calypso, Fulan, XLCC, Telefonica, a completely unknown Chinese company, and Coasia, they will not come into the market. So they will not. You will not see them in Europe. You will not see them. Maybe very local in Asia or in China or in Taiwan, but not in the rest of coming to Europe or whatever. It's a little bit similar with two companies before. That's Travauchamp and ECE Offshore. They both doing something in cable installation, but I don't see them as real cable installation companies. NC, sorry, that's, I'm going too fast, or this one is going too fast, sorry. Yep, I go, otherwise I'm losing my, yeah, that was ECE and Travauchamp. I don't think they will be real installation companies. They will do some shore end landings, they will opportunity basis do some cable installation, but that's about it. The next one, what I see is that DOF and NC, I think they are mainly in it for the repair market. And Jack, I know you are going to do the installation of the Inchcape inter-array cables. It might be a one-off, maybe it will be your future, I can't predict it, but I more see you as a repair contractor, and DOF is similar. The Far Eastern companies, Alice Marine, but also Orient, Sumitomo, Taihan, ZTT. What ZTT is telling me and what Alice Marine is telling me, yes, we are building brand new, beautiful vessels, but we only build them for the local market. Alice Cable, Alice Marine is building their new vessel mainly for the Western Link in Korea. But after that, they have to do something else. So at the moment, they are local vessels, but they might come in the international market or more regional in the future. And it's a little bit similar for the Japanese companies, I think. So it's getting better to look at this slide now. This is the other companies I did not discuss yet. And I put some question marks on NCT, CMOS, Deep Ocean, and Dongfang. The reason why I'm doing it is that we are in a risky business. It's a very difficult business. Cable installation is not the easiest thing to do. And the projects are large. And if there are huge amounts of money involved with high risk for small companies, if they take on too much, it's one of the reasons is that if the things go wrong, they may go bankrupt. And all 4 companies I've mentioned here, as a colleague of mine said, and a former colleague of mine said, to build a cable-lay vessel is easy. To operate a cable-lay vessel is something different. And to operate the vessel, it's not that difficult, but to lay the cables and have the whole process in hand, you need experienced people. And there is a lack of experienced people. And if I hear, and quite honest, I know something about NCT, what happened there. I'm not saying anything. Deep Ocean still has to prove themselves on the real installation projects, which will start next year. CMOS is now doing the Inchcape. Yes, I see CMOS doing more of that kind of projects, but it will be relatively small one-off projects. That's why I put a question mark. I hope I'm wrong. I hope I'm wrong about everything I let disappear here, because I'm very much involved in the cable industry, and it's never been to say people cannot do it. I hope everybody will survive, but sometimes I'm pretty much scared that things will not happen as I think our hope. As a subsea, I must say they have an internal growth, and I see them surviving as the only completely independent and small-sized cable installation company without having any other activities. And of course the manufacturers and the marine contractors, because they have a large portfolio of other projects as well. Right, conclusion. This is the typically risk matrix everybody knows. And I think I can safely say that cable installation is a high risk, high frequency operation. And I think that everybody knows that in the end, comes at the moment with all the wind farms going in, or all the costs rising and all the difficulties there are to get the wind farms in the water, it's been that prices are being more and more difficult to get good pricing. The risks are getting higher. And you know the color of, this is Holland, the flag of Holland, and you know the color of Holland. It's not this flag, it's the orange. It's the orange is the color of the royal house in Holland. And sometimes it still feels like we in the cable industry are the oranges being squeezed. So this ends my presentation. But almost, I've come 2 remarks to make. As you see, it's the end of the presentation, but something else. I always said the end is nigh. And there is a time when I've dismissed him as a crank. I've been dismissed as a crank when I showed the pictures or the slide in 2015. Unfortunately, I've been proven right at that time. But I'm pretty well known in the industry. But for me, at my age, to be quite honest, the end is near. And for me, this is the end, the very last presentation I will ever give. So I disappear. Maybe not on the panels, maybe not on the conferences, but as a presenter, absolutely. Thank you.
Okay, let's see if there's questions, please, before we split for lunch.
No more rock dumping.
No questions? Any observations, objections to what was said?
Kill me during lunch.
René, sorry, thank you. René Nyland from Prismian. The slide that you had with the cable suppliers and your questions about the cable suppliers from Asia on the DC cables and also inter-arrays, can you explain it a bit more, why you have your doubts there?
Inter-array cables, it's very simple. When I was still in Van Noord, we were buying cables. And we have been looking into the complete market, and due to my background in other areas as well, we approached at that time also the Far Eastern companies for inter-array cables, for instance, and export cables as well. And we found out very quickly is that the production cost of inter-array cables in the Far East versus the inter-array cables in Europe, the production costs were marginally different. But then you still have the transport and the import duties. And that made the inter-array cables just not economically to buy from the Far East. And it's the same that, although it's happening sometimes, I don't see inter-array cables going to the Far East. It happened in Taiwan, but that's a little bit of a different story. I'm not always known with the economics. I know that Orient is going to do one of the inter-array cables, of course, projects in the Baltic. They must have had a very low price, or everybody else had a very high price. One of the two. I'm not going to. For export cables, it's different. It's LS Cable was, and I was involved in that one. LS Cable was one of the first companies from that area producing AC, high voltage AC cable for Europe, for one of our wind farms. And you see more coming, and Sumitomo has always been more in the DC cables as well. It's not that I'm not saying that they will never come, because commercially Ningbo has installed in Holland, LS Cable has installed in Holland, ZTT has produced several small types of cables for Germany. Hangtong is meddling around with some projects as well. But up until now, I don't see them coming that often to Europe. And to be quite honest, I think that when they want to come, first of all, and don't get me wrong, I'm not in the geopolitical area, but you see it with the Mingyang turbines, which are now more or less abandoned in Germany, or not allowed in Germany. The Chinese cables can't go to the USA. They can't go into Taiwan either. So what you see at a certain moment, you have to be careful if those cables are allowed to come to Europe. And they are allowed geopolitically, but also by the established European players. Because you don't want them to come over. Not as Prismian, not as Nexans, not as NKT. You try to keep them out of the door. Well,
yeah, that is right, and I appreciate your opinion on it. But when we talk about transportation costs, for example, we see that if we take our cost price for production and we don't even count for the transportation cost, that still the Asian companies are cheaper than us. So we cannot compete with them even if they include their transportation costs. And whether that's government funded or whatever, I don't know. But for us, this is a really tough battle.
Yes, I hear what you say, But if I look at the moment, and I'm a little bit looking into the interconnectors, but even the export cables, so the high voltage AC and especially the DC cables, predominantly the market is still done by the European contractors and definitely not by the Far Eastern. They can pick up some of the contracts, but the main things, and you know it as well as I do, EGL1, EGL2, EGL4, for instance, have been picked up by you. And that Sumitomo is getting the Shetland 2 interconnector and the C-Link is because they are building a factory in the UK. It's not because it's coming from the Far East.
Sometimes.
I think you're still in the lead for that kind of things. At least the European contractors. But you'll get competition, which is good, which I like. I like competition. You don't, but I like.
We like it as long as it's fair. Then it's fine.
Yeah. No, as long as it's fair. But okay, no, I fully agree on that one. But that's another discussion, I think.
Yeah. Perfect. But then, thank you very much, René.
You're welcome.
Yeah. And again, as was foretold by René, he definitely got that part right. Next point on the agenda is lunch. So we'll meet again at 1:55. Okay. We are making our way to the seats. Welcome back to the World Championship in Endurance Conferencing. So on to the last. There's only a few that made it so far. It's the last leg. So, without further ado, let's move on to the next presenter, and that's going to be Frank de Wild, Business Director and Senior Principal Consultant for Power Cables at DNV Netherlands.
Yes, hello. Good afternoon, everyone. Thank you, Mr. Chairman, for the introduction. And, well, I hope you're still, let's say, awake and that I am not going to let you fall asleep with my presentation. The topic I wanted to address with you was already mentioned a few times, but I want to still address that with you because I believe it is really a problem in our industry, and that is failures in submarine power cables and interconnectors, and also how to prevent those failures from happening. First of all, my company is DNV. We are around already for quite some time. We are a worldwide company with about 15,000 people focusing on different, let's say, industries, among which the energy industry. And what we do is we try to manage risk and complexity with confidence by certifying, verifying and testing against standards, specifications and requirements. We qualify, for example, new technologies. We provide expert advice from our independent third-party viewpoint, and we co-create and share by providing, for example, recommended practices, standards, and new rules. Regarding failures in power cables, let's first have a look to the interconnectors and what's happening there. When we consider HVDC interconnectors, we can see that, well, voltage levels are now at 500 kV. They are qualified up to 640 kV, so we can go a little bit higher. Conductor sizes that are being, let's say, addressed and being designed for are already at 3,000 millimeters square or a little bit above, right? That allows for bipoles of 2 gigawatts or 2.2 gigawatt, or what we see, 2.5 gigawatt here and there. And those power cables, right, those interconnectors have increasingly long length, right? We have yesterday seen interconnectors, let's say, up to a few hundred kilometers, but there is a lot of plans, let's say, to extend that to a few thousand kilometers. Well, very interesting, but I wanted to address that the criticality of those, let's say, cable systems is also rising. If you look what would happen if such an interconnector fails, right, you have, of course, an expensive repair campaign to do. You will have a lot of energy not delivered by that interconnector, but you also may or are going to be close to, let's say, stability limits of networks. In Europe, we have a stability limit of about 3 gigawatts, which means that if an interconnector would carry 3 gigawatts and there would be a failure, that there would be instabilities created in the network, and the network, let's say, may experience a blackout that could cause a blackout of a country. Not everywhere in Europe we are reaching that 3 gigawatt stability limit. Let's say on the fringes of Europe, right, we are actually more close to 2.5 gigawatts, let's say, of a stability limit. And I note that DC systems are of such large size nowadays that we are really approaching that. Then, right, it's no longer just an outage that you would have if you have a failure, but you also threaten, let's say, the stability of the entire network. Of course, what that leads to a focus on reliability and availability of power cables already from the very start when you start developing and defining such an interconnector project. So it is interesting to then see how we are actually doing, right? Do we do this in the right way, and what is the experience that we have with those interconnectors? Well, as DNV, we perform a lot of root cause analysis for, let's say, failures in the power industry, amongst which failures in power cables. And I am sharing here a number of results that we have. First, before I'm sharing that, right, remember that DMV, right, we don't see every failure cause, right? You go to DMV to do a root cause analysis of a failure if it is unclear what is the failure cause. If the X is, let's say, sticking out of the power cable, you don't have to have DMV to figure out why the cable failed. So we do the bit more complex matters, and well, that includes cable systems for, let's say, about 900 root cause analysis and DC systems for about 80 root cause analysis. Those 80 failures in DC cable systems are, let's say, roughly equally split between lapped cables and extruded cables. The lapped cables, it is, let's say, there where the cables are mostly failing. For the extruded cables, we see mostly the joints failing. Compare that to what is reported in C-Gray, right? That is public information. It's typically used to make business cases for new interconnector projects. But in C-Gray, we only report 20 failures in DC land cables and 8 failures in DC submarine cables. So completely different types of numbers, right? We see already 10 times more of those failures. These are the root causes we have seen, right? We identify each of those, let's say, failures. We do a dissection of the cable system, figure out why that cable has been failing. And we see that, well, root causes are, let's say, installation, manufacturing, external damage, and design and engineering in that order of magnitude. This is for the lapped cable system failures. We understand also a bit why that is. The lapped cables are typically the longer interconnectors, right? There is a lot of installation going on in those, let's say, cable systems. Not always that easy because it's typically, let's say, spending a longer time in sea. So there is a lot of installation of power cables needed. Regarding the manufacturing, what we often see in lapped cable systems is problems with the smoothness of the outer layers of the cables, like the outer semiconducting layers and the lead sheets, etc. There is a lot of problems, let's say, attached to that. When we focus on extruded cable failures for HVDC interconnectors, we see also installation, manufacturing, design and engineering, and external damage, let's say, emerging as the main root causes of failures. Remember, these are more the joint failures, right? So if I'm talking about installation, it's installation of joints, which is a primarily problem, let's say, in these kind of cable systems. We also note that the failure modes are really different from AC cables. We see, for example, corrosion playing a much more important role in DC cable systems and leading to failure much more often than in AC cables. And what we also see is that the joints, well, there is also a lot of problems in the manufacturing of those joints. The manufacturing of joint bodies, let's say, which have imperfections or impurities on the surface, causing later problems, let's say, during the operational phase. And also the workability, which is more of a design aspect of joints, what is sometimes quite kind of hindered in these kind of joints. So all compared together, right, if I bring all those 80 failures, let's say, together, we have, let's say, this pie chart where we see installation, manufacturing, and design and engineering, let's say, being the key root causes. And just to observe with each other, 85%, right, if we add up the installation, the manufacturing, and the design and engineering, 85% of that is under our own control. It's not that something extraordinary is happening. It's not where I don't see, let's say, the anchor damage here so very significantly. I see a lot of things that we have under our own control and that we can also solve. Is it so very different from AC cables? And I'm looking now at the larger AC cable systems, not so much the array cables. Well, maybe not, right? Also for AC cables, we see the voltage levels rising, the conductor sizes rising, the amount of power transported rising for each cable system. We also see the lengths increasing, let's say, of those cable systems as we go further and further offshore. The criticality is, however, a bit lower, right? The network is not going to collapse if we disconnect 1 gigawatt because of a failure. It will hurt, right? Especially for the ones owning, let's say, the power cable or the ones having to, let's say, repair, right? The consequence is increasing, but it is not, let's say, critical for the network. Looking to the performance of AC cables, there is actually 2 different sources that I can provide you with. This is a joint industry project called cable lifetime monitoring. I reported on that last year and the year before. So you can see where we, let's say, focused on, let's say, power cable failures in and around Northern Europe. So Northern Sea, Irish Sea, etc. And we found 135 AC cable failures in that project. Focused, and the moment of failure initiation is mentioned here again: installation, manufacturing, and design and transport. If we look to our own databases as DMV, we have analyzed the root cause of 70 failures, and we find, again, manufacturing, installation, external damage. And again, I find, let's say, the same number: 85% of those failures are things that are happening under our control. We could do something about it. So how do we prevent failures from happening? And some failures, let's say, for a reminder, those kind of things all happen. Well, I think the answer to that is, let's say, improving quality management. And then understanding also that quality management is something not a single party does, but should be, let's say, applied over the entire project, from the very first start of a project to the very end of the project. So from design until, and maybe even including the operational phase. To suggest some improvements, let's say, and that those suggestions come from, let's say, the causes of the failures that we see, we can share the following. Regarding design, what we see that design aspects are sometimes forgotten or not, let's say, considered, let's say, in the development of a project. And to avoid that from happening, it is really good, let's say, to do design verification studies. Ask somebody else to check your design and to make sure that you do not overlook some design aspects, that you do not overlook some, let's say, design concept which is already addressing things, and that you make sure that the design is complete and accurate. Right? Too often we see that variation of the seafloor is not taken into account, or design aspects are not completely considered. Regarding specifications, and then especially about specifying who does what in a project, we can advise, let's say, to try to ensure that information is not lost over interfaces between different teams or different companies. That also happens regularly. And as I say, not only between companies, but also within companies having completely different teams, right? So like a company having both manufacturing capacity and installation capacity, there still is a significant interface in such a company where information can be lost. And what we see is that that information is being lost and is causing problems in the operational phase of the cables. Regarding quality assurance, and there was already some talk about, let's say, quality assurance, right? It is really important to make and have a quality assurance plan in a project. And quality assurance plan means that there is a plan, a written document that says how we are going to make sure that that cable has the right level of quality in the project. It has a lot to do with qualification and qualification tests, but it is not the only thing. For example, right, we have development tests in the industry, and manufacturers, let's say, do development tests to learn the vulnerabilities of their products. All the products of manufacturers are different from each other. The manufacturers have different techniques and the vulnerabilities are different. So because of that, they do different development tests and different amounts of development tests. So different manufacturers have different amounts of insight on what makes their, let's say, their product vulnerable or less vulnerable. We do qualification tests separately, like the pre-qualification test for power cables or the type test for power cables. But right, type tests and pre-qualification tests can be done in different ways. Right? There is a variation possible. Right? There is, let's say, test houses that use standardized procedures to perform tests and to interpret the result of tests. But nobody is, let's say, required to use those kind of, let's say, situations. You can also do a type test or a pre-qualification test in-house at a manufacturer, or in another test lab that follows different types of interpretation rules. So there is some variation in the way you test power cables. And the more important aspect even is that a type test or a pre-qualification test typically does not say everything about a project. Right? The IEC tests are very much focused on electrical performance, a little bit of mechanical performance, but not, for example, corrosion. right? If you want to add that to the design, you can do an additional design test focused on corrosion, but it is not standardly applied, let's say, as a qualification test of the product. So is your qualification actually complete is an important question. And if it is not complete, right, maybe you should, let's say, improve the completeness such that those kind of design aspects which are important for your project are also qualified for. And that brings me to the next point, right? Project requirements are different between projects, right? There is more simple projects and there is projects that are more challenging. And typically the thing that is more challenging or makes the project more challenging is different from project to project. Those things that are more challenging, what you can design for, and you can prove, let's say, that the design is able to withstand those more challenging things by including them in the qualification test. So it all requires kind of designing how you make sure that the quality of your product is at the right level. And that is a project on project, let's say, specific activity. When we go into the, the next point is also something that happens on, or that is important for the qualifications. And that has to do with long length cable systems, right? The longer the length of the cable system, the more important this issue is. It is a length effect. If you test a cable, right, a type test or something, you test typically 50 meters or maybe 100 meters of cable, but not so much more. So with that, do you actually qualify 1,000 kilometers of cable production? Or would you just qualify 100 or 1,000 meters, right? There is difference in that, right? Because, right, there is simply a difference in the statistics behind, right? What is the statistical likelihood that, let's say, all the defects that you could have are included in that, let's say, sample length that you are testing? And what does that say then if you have an extremely long or large production volume? But at some point, right, you will see that the production volume, let's say, is, let's say, below, let's say, design criteria. And that is something that should not happen. So our recommendation is that to aim for the creation of statistical evidence that the whole length that you are purchasing obeys the design criteria, not just pass the type test. Regarding the manufacturing phase, important to aim, let's say, to detect variation over long manufacturing durations, right? If we have an 800-kilometer interconnector, it will take one manufacturing line 2 years to produce that. 2 years, and 2 years, let's say, you should, let's say, have control over the wear and tear of the machinery in the facilities. You have to have control over the raw materials that are entering into your product. That is not nothing. Right? One bad Monday morning in 2 years, how do you prevent that? Regarding installation, we believe that it is useful, let's say, to develop the installation design and the installation design plan together and aligned with the cable design plan, such that they, let's say, can be optimized together and such that you ensure that your cable is installable in the way you foresee and that the installation allows the power cable, let's say, to be installed in the way that you foresee. So the design verification aspect here is an interesting thing. And the other thing is to consider making a feedback loop on the design, or sorry, on the installation process. Right? Could you directly, let's say, feedback the way you are, let's say, performing the installation to, let's say, the installation procedure itself? And you could do that with fiber optic sensing. I have some slides on that separately. And regarding the operational phase, right, you could continue the quality management during the operational phase, but especially when you have a failure, do a root cause analysis to figure out why it is failing and what that learns you. It's really important to capture that learning and to improve, let's say, the industry experience with those kind of things. I wanted to highlight two different things. That is the manufacturing variation I'm talking about and the installation feedback loop. Regarding manufacturing, right, to shorten, let's say, manufacturing lines, what is happening is that, let's say, we have and apply more manufacturing lines to produce products for a single project. Right? But if you have 2 lines or 3 lines or 4 lines working in parallel, either producing cable or producing joints, right? How do you make sure that the variation between those products is, let's say, under control and not, let's say, beyond any limitations? The other interesting thing is that manufacturers all, let's say, develop and expand their capabilities and capacities. Right? New factories are developed. New manufacturing lines are being, let's say, are emerging. And right, it is useful, let's say, to be able to utilize pre-qualified, let's say, existing lines and use the pre-qualification of those existing lines to also qualify the products of the new line. And you can do that if those lines are similar to each other. And that means that you have to prove similarity. So we have experience improving similarity and ensuring similarity between manufacturing lines by proving the similarity of process, right, the manufacturing process, the procedures, the work procedures that are utilized in a factory, the people, the experience and the quality of those people, the knowledge of those people, and the actual products, right? They should all be similar. And if they are all similar, right, we end with a similarity verification statement or a manufacturing line qualification statement, and that provides you the evidence that the variation is within limits and therefore kind of under control. The other thing I wanted to highlight was the fiber as a feedback to the installation process. Right, there has been a joint industry project, cable lifetime monitoring. You find a link, let's say, if you follow that hyperlink. And as part of that, right, a sensor was developed that identifies and distinguishes and measures the bending, the twisting, and the forces in a power cable in real time over its entire length. It's really interesting. You can put that sensor in the power cable directly after, let's say, during the layup. You can cover, let's say, and measure during the last stages of the manufacturing, the loadout, the transport, the transpooling, the installation, and the operation. Right? If it is already there, right, you can use it in the operational phase itself. Right, we made a proof of principle in that joint industry project, and I wanted to share a few pictures to end. Otherwise, I am just, let's say, providing you a lot of text. Here you see the sensor, 3 fiber optic in a triangle, let's say, to figure out, to be able, let's say, to measure orientational, let's say, defects. And if we bend that, you see that you can directly measure that, let's say, on a screen with a DAS system or Brilliant OTDR system. So it works brilliantly. We integrated those kind of sensors in power cables, right here in the middle, right, with triangular, let's say, sensor construction, or there, let's say, in the interstitials between, let's say, different cores, let's say, and figure out if we can measure that. And, well, we have done tests, let's say, with bending tests, tension tests, torsion tests, crush tests, impact tests, etc. And we can measure each of those individually and can integrate, let's say, the variables such that they survive the installation process. So as a practical application of that, let's say, we see the following, right? You have an installation vessel with a Brilliant OTDR or DAS system inside of the vessel, continuously monitoring these kind of, let's say, forces and changes in the power cable. And that monitoring will, let's say, provide you, let's say, how strong you are squeezing the power cable, what is the tension on your catenary, what is the bending radius that you have on the touchdown point, what is the bottom tension, etc. And maybe actually that is not so much of interest of, let's say, everything that goes already in a proper way, right? So if we do this in the North Sea, maybe that is not the most interesting thing. But suppose you are also, let's say, floating this in and putting this into an HDD, you want to be sure, let's say, that you are not, let's say, pulling too hard, that the cable is not twisting or changing its direction, etc. And you could do all of that, let's say, with this sensor. So consider, let's say, integrating those kind of sensors as a direct feedback loop, let's say, to your installation process and have better control over what's actually happening to my power cable. With those words, I thank you for your attention.
Thank you. So, do we have some questions for Frank? There is one in the front.
Thank you. Thank you. Very interesting. Those sensors, can they stay afterwards, while after the cable is buried?
Yes, they can stay, and they can
They will
actually have...
still give you data, right?
Yeah, they are integrated in the power cable. They can stay in the power cable, and they have a purpose also during the operational life. Suppose the power cable becomes unburied, right? The power cable may move around a little bit, and you can detect the movement. You could also detect the movement in a J-tube or whatever, let's say, to ensure that it is not, let's say, behaving in a way that was not designed for.
So you could add a pressure sensor as well, and you know at all times how deep it's buried.
Yeah, kind
and
of,
if
right?
it's
There is
about
already...
to become unburied.
You are measuring already the crush forces, so that is very close to, let's say, measuring
Yeah.
pressure.
Okay, thank
Yeah.
you.
Do we have any more questions? No? Okay, but then, Frank, thank you very much.
Thank you.
So, our next presenter will be Charles Dudley, project engineer at Arup.
Thank you. So more on fiber optic cables now. So hi, I'm Charles Dudley. I'm a project engineer, mechanical engineer at Arup, and I'm going to be presenting on some research we've been doing on subsea cable risk management, and specifically using DTS systems in array cables. And this is some work I've been doing with Professor Justin Dix at University of Southampton and my colleagues George Walker and Chris at Arup. So just about Arup, a bit about Arup. So we're a global engineering firm. We provide consultancy services in lots of different industries, specifically to offshore wind. We provide design from kind of pre-feed and concept stage through to kind of detailed. And we provide asset management services as well. So on asset management, we consult on kind of all aspects of offshore wind farms. So that's kind of from foundations and wind turbine generators through to cables and offshore substations. And we also look at performance monitoring, consenting and decommissioning. So cable exposure, I don't need to tell any of you how important it is. But yeah, it's a real challenge for the industry. So yeah, each array cable failure can cost up to £10 million and cause well, I've got 40 days there. I think someone earlier said a month to 2 months of downtime, and obviously this has an effect on the levelized cost of energy. And I've got there almost 80% of offshore wind insurance claims are directly related to cable failures. So from kind of speaking to one of our clients in the kind of asset management aspect, we've found that that cable spans exceeding design assumptions have caused multiple cable failures in one of their early round wind farms. So yeah, there's a step change in the integrity risk if the array cable becomes exposed. So how can we prevent that? So what do we do at the moment? So the kind of industry standard approach uses bathymetry surveys. So you know these are kind of vessels scanning the seabed, and you get a nice image like that on the left. But yeah, these are pretty costly. We found, or kind of clients have told us they're pretty costly, and they give you a very discrete understanding of kind of what's going on with the cable. So you only kind of get it at kind of 6 to 12 month intervals, and sometimes this is even longer. And then yeah, there's some existing solutions for continuous monitoring, but generally these haven't been tested on array cables very much. So we're really interested in kind of reliably detecting array cable exposure using DTS data. So as I mentioned, DTS systems are often installed on export cables and interconnectors, but it's quite rare to have. Well, it's a lot rarer to have them on array cables. And so we're quite lucky in one of our clients we're advising on at the moment has a large array, well, a kind of large database of kind of over 10 years of data of DTS from an array cable from a highly mobile wind farm. So we thought, how can we use this to predict deburial, as they've kind of identified it as an issue in the past. So just for things affecting cable temperature, we've got thermal resistivity for cable. Obviously, that's pretty well understood. Electrical load, so that's quite well documented. So you get that from a wind turbine generator SCADA system. Temperature surrounding medium, that obviously affects the cable temperature, but then obviously the temperature of a medium depends on the medium it's in. So is that in soil or in water or in air, and if so, what type of soil is it in? So there's a lot of things affecting the kind of cable temperature and the DTS temperature that we measure. But from all of this, we should be able to infer something about the cable's burial status from the DTS temperature. So what I've got plotted there is a DTS trace in time. So that's that heat map on the left there. So there's a few things we can see here. So we've got kind of the warmer summer months or late summer months, and the cooler winter months. And we see that in the kind of light to dark transition. But then there's a few other things going on. So we can see those kind of bed forms at the top of the figure, and you can see some of them are pretty static. So they're kind of stationary in time, and then you've got one of them there towards the bottom where it's kind of actually migrating along the length of the cable. And when we compare this to BAFI data, for this section of cable, we've got that in the bottom left. You can see it's kind of, there's quite a lot of a bed form movement going on there, a lot of different kind of features, and we're quite nicely picking that up on the DTS trace we're looking at there. So with this in mind, we've tried to kind of come up with our own method of using DTS data to predict exposure, and we've tried to kind of validate it using a few different things, which I'll get onto later. So I've kind of picked a single point on that. Well, this is a separate cable, but this is what the DTS trace looks like for an array cable. So there's quite a few things going on here. So yeah, this is about 10 kilometers long, and there's about 15-degree range in temperature. So we've got the offshore substation at one end, and we've got the end of the string, or the kind of turbine at the end of the string at the other. So as we'd kind of expect, we see a kind of step change in the temperature in the buried periods as we kind of go from the end of the string to the substation. And this completely makes sense, right? We're adding load, we're adding temperature. Well, load. Yeah, I don't need to go into that, but that makes sense. But then there's a bit more to it, right? So in the middle there, we've got a bit of a step up and then a step back down. So that's really, really interesting because we think that's directly caused by a deeper burial within that period, within that section of cable. There's a few other things going on. So each of those spikes, they're foundations, and we've kind of verified this from installation data provided by the operator. And you can, just visually there, you can see how clear it is where the cable kind of it becomes exposed to water, and then it kind of goes back and it's in the buried section. So if we look at these traces in time now, so this is I plotted here the kind of in purple there. I've got a time history over a year for the exposed section, and then in red for the buried section, and then in blue I've plotted sea surface water temperature. And what do we see? So obviously the exposed cable follows the surface water temperature very nicely, tracks pretty perfectly actually, really high correlation from when we've carried out this analysis on kind of multiple points. And the buried cable, obviously kind of a lot less variation in temperature, and And there's also a bit of a lag. So you can see the kind of where the peak in the surface water temperature is in the kind of middle of the plot. The peak in the buried cable temperature is actually kind of later on in the year. And we think this is due to a kind of number of factors, but one of them being that the peak period of generation is not necessarily when the seas are hottest in the middle of the year. So some really easy kind of features we can pick out from this, and you can see we can use this to kind of build a model to detect cable deburial or cable exposure. So we zoom into one of those foundations now. On the left, I'm just showing one half of a foundation, but I can promise it's pretty symmetrical. We can see there's as we expect, the kind of buried section there with kind of little temperature variation, and the in water or kind of exposed section on the right. A few things to note in this plot. We can see so each of these lines is kind of is a single month of the year, so it's kind of single data point. It's not average. It's kind of single point in time. But we can see in the summer months, the exposed section is hotter. We'd expect to see that. And winter months it's warmer. But then we get this kind of transition period in the kind of late spring and late autumn, where actually the kind of exposed section's pretty similar to the buried section in temperature, and it's actually quite hard to, just from looking at this, to predict the kind of exposure point. So this presents us with quite a nice challenge, kind of getting around this, and it's quite hard to do that when you just consider it as kind of single point in time. So with that in mind, you've all probably seen DTS systems before. What's so special about this, right? So one of the nice things about it being an array cable is we've got foundations, and with that we've got foundation design drawings and construction drawings, and we've got bathymetric surveys from the last 10 or so years. And because of that, what we can do is we can kind of cross-correlate the DTS trace to the construction drawings, to the bathymetric survey, to kind of come up with, to kind of infer exactly, very specific points around a foundation. So these are monopile foundations, and we've kind of confirmed that we've got the hang-off point there in the middle, where we've got that kind of constant signature, but we've also kind of been able to pick out and verify specific points, kind of specific kind of key interfaces. So water to air and kind of J-tube to water. We see on this DTS trace. So and then we kind of through this, right, we can get to the end of the J-tube, and then we can use the bathymetric survey to add on a distance to this to kind of pick up the burial point. And that's what I've got plotted there in the kind of last two kind of large dashed lines. And what's nice about this is it means we have a kind of really rigorously kind of validated kind of exposure length, and that's kind of what we're going to kind of use going on to kind of predict the kind of cable exposure and the change in the cable exposure. So with all this in mind, we've come up with our own kind of method to predict kind of cable deburial or cable exposure. So our approach uses DTS data. It uses load data. It uses, which is kind of readily available from the wind farm operator, and it uses publicly available data. So it's just kind of sea surface and air temperature, and using this, we've been able to kind of classify the cable around the foundation into kind of these characteristic regions. So you can see there in the top right, we're kind of automatically identifying regions as kind of buried or in water or in air, and we're doing this using kind of spatial and temporal consideration of the DTS trace kind of simultaneously, and these two plots I've kind of copied the plot from the last slide, set them to the same length scale, and you can see there's a kind of really nice or generally really nice agreement with kind of what we'd expect to see the interfaces at. between the different regions. So we've kind of carried this out, this kind of detailed, systematic kind of understanding of the bathymetry, the construction drawings, and the DTS data. We've kind of done this cross correlation for a small number of foundations at the moment. So here's one. From kind of multiple surveys, we'd expect the kind of cable exposure length to be pretty consistent, and that's what we're seeing. So these red dots are the predicted values, and the black line is is the average of a large number of bathymetric surveys. So a few things here. There's obviously a bit of a DC offset, but it's pretty consistent. So this is 3 years of data, and we're predicting cable exposure each month, and so we're getting a much higher kind of higher frequency kind of prediction than you would from a traditional bathymetric survey. Reasons for this offset, we're kind of still kind of finalizing our prediction method, but we also think it's partially due to kind of error in kind of the BAFI survey and the kind of construction drawings, or kind of what we've measured off construction drawings, and then partially because we think there's a kind of temperature gradient along the cable as it enters the buried section. I think this next foundation, which we've kind of also looked at in detail, is a bit more interesting, because so again, red dots are prediction, black dots are the bathymetric surveys carried out during this time period, and from the kind of BAFI images we've seen, we'd expect there to have been kind of there's a kind of quite high mobility, well, kind of quite high movement around this foundation, and we'd expect there to be a kind of scour pit developing, but we can't really see what's kind of going on when we just look at the images, like from a kind of day-to-day perspective. But you can see there what we think we're seeing is the kind of gradual growth and then kind of rapid decay of kind of a scour pit around a monopile, and that's really interesting because yeah, as I say, this is something you just wouldn't pick up with a kind of conventional bathymetric analysis or bathymetric survey. We still see the DC offsets, and it's kind of, for us, it's good that it's consistent because it means there's something systematic we need to change, and we think, yeah, as I say, we think we know reasons for this, but yeah, kind of method development is ongoing. A few more foundations here. You can see we get kind of errors in our kind of predicted exposure lengths between kind of 5 and 12%, 5 and 13%. But these have been carried out over kind of a large number of kind of different foundation depths and kind of seabed level mobilities. So where do we see this going? So currently we have our LEAP solution, which is a kind of takes real-time foundation monitoring data and provides clients with a kind of an interactive dashboard for kind of seeing the remaining useful life. So we kind of we provide structural health monitoring services for foundations, and we see this kind of cable monitoring being integrated into this with further validation in the future. So a few takeaways from what I've shown today. So I think kind of I don't need to explain to you how important or how high risk cable deburial is, but especially for array, well, definitely for array cables as well as interconnectors. Often array cables are not installed with DTS data, with DTS systems, but it's, compared to the cost of replacing a cable, it's relatively cheap. So it's an easy win to for a kind of potential mitigation of failure in the future. We've developed a promising approach for detecting array cable exposure, and this uses kind of readily available data, and further validation is coming. So we're over the next few months going to carry out a farm-wide validation, and we've got 3 more farms, DTS worth of data to process as well. And we have looked at, I kind of foresee some questions. We have looked at mid-array cable and kind of interconnectors, and we do get promising results, but from kind of comparing bathymetric analyses to kind of bathymetric surveys to what the predictions are telling us, but we don't kind of quite have the kind of rigorous validation that we do for kind of around foundations yet. So we've kind of not shown that here. So thank you, and any questions?
Perfect. Indeed, do we have questions? Can we have a microphone?
Hello there, Dan from Alcatel. Is there a reason for using DTS data as opposed to DAS data for this?
Well, primarily, you know, we were approached with DTS data from the client, or yeah, the client. So that's what we were kind of using.
Super.
But yeah, acoustic data.
If you want to try DAS data, then have a try. It probably tell you this in about 6 hours.
Okay.
The same data.
Yeah. I mean, you know, the actually showing kind of where, you know, it's very easy to look at a signal and say, well, obviously there's a variable point, but kind of validating it and kind of rigorously kind of showing it along the length of the cable for kind of multiple, you know, that's kind of where a lot of the work has gone and is still going. Yeah, but no, I take your point.
Any other questions? Nope. I have one then of my own. So you're now strictly looking at buried versus exposed cable, right?
Yes. So I mean, our kind of, yeah, we're classifying it into buried in water and in air.
Yeah. And so you use the temperature response to make that assessment.
Yeah.
Have you looked at doing more thorough thermal modeling of the cable?
We haven't at the moment, but again, it's kind of definitely something which could kind of support validation kind of before we kind of fully integrate it into kind of one of our services.
Okay. One last chance. There is a question.
Out of curiosity, why are you using sea surface temperature data and not sea bottom temperature data?
Well, it's publicly available. The kind of validation exercise we're doing, kind of sea surface temperature from kind of buoys, is we can just get it for the farm we were looking at. So it's primarily kind of a ease of access, but I mean you could see, right, that it's still tracked pretty well, and you know, if we had
CTDs.
Yeah. Data, then it kind of, you know, it'd be better, but we're kind of using what we have access to at the moment.
Thank you.
Perfect. But then, thank you very much.
Thank you.
Perfect. Then let's move to our next speaker, and that's going to be Jack Wattel, Director Subsea Cables at NC.
Good afternoon. It's on. Good to see you all. Let's talk a little bit about cables and cable repairs this afternoon. Just to start with the first question, how many people in this room have actually ever seen a cable fault or a cable repair or been on board of a cable vessel? Not too bad, about 5%. Right. Since I've been here, I've been paid to come here, and I had to pay to come here, I might as well talk a little bit about NC. NC is a subsea cable, NC is a subsea services provider. And we're busy in the field of survey, UXO, IRM, light construction, and for the last 5 years also in cables. The last 5 years have been a pretty rocky ride. And why is that? Because the amount of cable failures is quite unbelievable. And I won't go into detail today of why there's cable failures, maybe a few examples, but at least let's look at what happens outside. What happens when a cable fails or when there's a fault in a cable, and how do we get it back energized to status that the owner can use it. NC does that with a number of vessels, just a short overview of those. And together with all those capabilities we have in-house, we deliver integrated solution for CAPEX projects. We're not talking too much about this. We're talking about cable repairs this afternoon. But as already was mentioned by René this morning, we are building a new generation cable repair and installation vessel. And again, let's talk a little bit about the difference between a cable installation and a cable repair vessel. So talking about OPEX, subsea cable repairs. Basically, there is only very few parties in the market that deliver this service. Two of the main ones I think are here today. One is NC and the other one is NKT. And I'm sure NKT will give you a full story of all the capabilities after me. We offer this insurance policy to the market. You never know when a cable fails, but you do know when it fails, it needs to be repaired, and the time to repair it and the certainty of the quality to repair it is quite key. So we offer that insurance policy. We can do it ad hoc, or we can do it in the form of a framework. And if there is no vessel available because they're already busy, and that happens more and more, then we have this beautiful mobile spread built, which is standing on the quay wall of our logistics center in the Netherlands and can be mobilized of a vessel of the market in any time available. Typically 10 days, according to NKT. In our case, normally 2 weeks. Then cable repairs. And as you said, there's not that many people that have actually seen a cable repair or have been on board of a cable vessel. So I thought I'd take you through some of the pictures that were taken last year outside on real projects with real vessels and, as you can see, real people. And there's a lot of difference between our engineering services, between our thoughts, between our brainstorming and the actual reality outside. And this man on this picture, he's retiring this year, has seen this for the last 40 years, and you can see by the color of his hair, it's a hard job. So sometimes you have a very nice sunny day and everything goes according to plan. You have a cable lay vessel, all the equipment is working, sun is shining, the sea is calm, and it goes well. You even have a CPS that is in one piece. But the work continues during the night, the work continues during rough weather, and then it becomes all of a sudden a lot more difficult. Things you can very hard simulate and analyze before you actually start the work. And we go through a lot of analysis, we go through a lot of engineering. At the end of the day, it's very difficult to understand the impact on the crew on board of a vessel that's actually working in seas of 1.5, 2 meters. And then we have a lot of different cable repairs. Sometimes it starts with dredging a trench to lay a cable in, because that's also part of it. Sometimes it starts with diving. Over the last 25 years, since we started installing cables in my current life and my previous lives, we have been trying to reduce diving. Everything, or a lot of things were done by ROVs, and that works very well. And then you start doing cable repairs, and all of a sudden you see that we have had more divers in the water over the last 5 years than we had in the 20 years before that when we were installing new cables. And why is that? Because we installed a lot of cables over the years and we never thought they might fail. We might have to repair them. The first generation CPS systems, the ones that typically fail, were never designed to be removed. So in some cases, the only way to remove them is just to either cut them or remove the bolts by divers. And this picture on the right-hand side for you is just a little tiny element that you need to take out to remove the CPS. If the weather is not that great, if you can't dive, it might take up to 14 days just to remove the CPS. And that's on a single inter-array cable repair. So you can imagine the costs of that are enormous. Going back 15 years when we installed the wind farms, we could have thought about that, but we didn't. And now we have to live with the consequences. It just shows you that the CDM regulations, where you have to design something actually you can also safely remove it, are very much applicable for these type of jobs. And at the end of the day, if there's no better solution, we do it with divers, but it's certainly not preferred. Most cable repairs actually start, just apart from all the engineering and analysis, start with loading the cable. We either use a bow cable engine, or we take the cable directly from the keywell. I think Osbert is here. There's your picture again, so just to be proud of. And then we go offshore. You start lifting out the cable from the seabed after you have deburied it. The picture on the left is a cable actually that has been in the seabed for close to 15 years. It looks brand new. It has been covered by 1.5 meters of sand and silt for the last 15 years. You take the cable out, it's just like you take a new cable out of the factory. Sometimes you have to clean it a little bit. CPS looks slightly different, as you can see. It is a lot of marine growth on there, and it absolutely stinks. It stinks that much that if you don't clean it or get rid of it, it makes people sick on water. But it's a sign that at least there is some marine life there in a wind farm. Then we go to some other options of a cable repair. You won't see them all. This is actually the float out of the cable from the vessel near shore to the shore. One of the pictures is in the North Wales coast, and the other picture is actually in the Mediterranean. A project we did for Prismium earlier this year. You see that they look a bit different. The sea conditions are also a little bit different. But a cable float out is in these kind of repairs of an export cable an integral part of a repair, including the pull-in of the cable through the horizontal direction of drilling into the joint bay. It's not easy. And you can see on the left picture, in all fairness, we had a very proficient supply chain in the US, in the UK with assistance vessels, and in the Mediterranean we had to find local fishermen in the port to assist us with this cable float out. Again, these things you cannot take into account when you do the preparation of a repair. You have to find those out at the time. Some cables are jointed. Again, I think we will hear a little bit in the next presentation. It's a very complex process. And in this case, it took about 3 days to do actually the joint between two lengths of cables. Sometimes it takes 5 days, sometimes it takes 7 days. And all that time, there is a vessel laying offshore, subject to wind, waves, storms, current. It needs to be in one place, because the play actually that you can move the vessel in this kind of circumstances is very, very limited. And again, you can understand it takes a lot of engineering, takes a lot of analysis to make sure that this joint or the cable that goes into the joint doesn't move in that period of time. At least we have improved a little bit, because the jointing habitat that you see in the top right corner is a conditioned area with heating, with lights, with proper lifting equipment, and the people in there can work quite comfortable, which again improves the quality of their work. You can do the same work under a bit of a tarpaulin on the deck. The quality won't be the same. And then you have this massive offshore joint, which is 12 meters long, 1 meter in diameter, which needs to be then lifted back into the sea. Sometimes we do it with a quadrant in case of inter-array cables. In case of export cables or interconnectors, it's normally with a lifting beam. And you can see this is a very complicated, very precise operation. And again, weather conditions are very critical. At the end of the day, you finished, the cable needs to be buried. If you can do it with the controlled flow excavation, it's a very cheap solution. If you have to do it with one of the big cutting trenches or jetting trenches, you're talking about a day rate of 150,000 euro a day. So quite expensive. Those were just a few pictures of the last 12 months, in this case in ANSI. Now it doesn't stop there. We have done a lot of cable repairs, and there has been done a lot of cable repairs over the years. And there's a lot of clients that have lost a lot of money, or insurance companies that have lost a lot of money. And then why is that? And I think in previous presentations I've given similar stories. You know, clients, cable owners are not prepared. There's a lot of parties in the market that the spares are not organized, the joints are not there, the cable has never been inspected over the last 5 years. And there is virtually no engineering, no data available. There's quite often a survey of 2-3 years ago. There's quite often a list with spare parts of the building of the wind farm, which could be 15 years. So gathering all that data takes time. So what we recommend is that if you are the owner of a cable and you don't have a framework with one of the parties that is prepared to do so, sit together with one of those contractors and do a bit of brainstorming and find out what is all needed, what are all the parameters, what are all the variables, and try to come to a conclusion. We've done this a few times now. We've done it together with people like Prismium, we've done it with Standard, we've done it with Ørsted, and we're doing it with a lot of other cable owners at the time. It's very valuable. After you've done that, you can start to develop a cable repair philosophy. Because it's not only the vessel, it's not only the deck equipment, it's also the spares, and more important, it's the personnel. To give you a little bit of an idea, if you have a cable repair in the UK, there is no cable repair vessel in the UK today. You can mobilize them, but they are not there as we speak. To get visa for personnel to work in the UK takes 6 to 8 weeks at the moment. And that is after you know who's your crew. So if you have a dedicated vessel, fairly easy. You just know that 6 or 8 weeks later, you have actually a crew that can work in the UK. If you don't even know which people you're going to take there, because they're busy on another project or you have to find them in the market, it will take a lot longer. So the first 8 weeks, you basically lose. So yes, we can mobilize a vessel in 10 days, but if it's close to 12 nautical miles from the coast, which a lot of the old wind farms are, you lose the time in getting visa. And I mean, we are in the UK today, there is not sufficient labor in this country to actually do cable repairs, whether it's jointers or whether it's people on board. Anyway, develop the cable repair philosophy and develop a toolbox. What we typically do is we start looking at scenarios. If you have an export cable, is there a horizontal directional drilling? Is there a beach landing? Is there a shallow water section? Is it deep water? Is it hard soil? Is it soft soil? Is there an offshore transformer platform? All those scenarios you can prepare. You don't have to go to the greatest detail, but 70% of the engineering, 70% of the analysis can be done up front. You don't have to wait till the cable fails. And then at least find a contractor. I mean, ANSI is available, but find a contractor. It doesn't matter who it is, as long as you have somebody you can trust that when you pick up the phone, by the time your cable fails or the light goes out, somebody will pick up the phone, you have a contract with them, you have some repair preparedness engineering done, and then you can start. Now, it's all about the program, it's all about the schedule, so as long as you have that in place, then at least you can make some agreement with those repair contractors that they will be there, that they will pick up the phone and that they will start in 10 days, 14 days, and finish maybe the project in a month or in 2 months, depending on the scenario, depending on the complexity of the project. I think I skip a few of those. Basis of design, quite keen. It's not just you start somewhere, you need to know what the parameters are, you have to design something around. And every cable repair, similar to every cable installation project, needs a basis of design. You need to start somewhere, you need to know what the parameters are and what you have to deliver at the end of the day. It's not just fixing the cable and walking away. No, the cable needs to be energized, the cable needs to be approved, and it needs to be safe. So, a few more pictures. This was actually also the Quintimore project, where instead of a vessel, we came to the conclusion it was better to use a jackup. And this is part of this process of optimizing, engineering, optioneering, to find out what is the best solution for a repair. In this case, it was so shallow that we couldn't get there with the vessel, so we did it with a jackup. And it worked very well. But it took probably a few weeks to come to that conclusion. So, last slide before we go to the end. Like I said before, this is a cable repair vessel. And if you wonder what's the difference between a cable repair vessel and a cable installation vessel, the real answer is nothing. They both do the same thing. They can install a cable. In case of a repair vessel, it needs to be more volatile. You want to be able to change the deck layout a little bit easier to reduce the time, to reduce the cost. But at the end of the day, they both lace cables. You can optimize it, you can make it more versatile, but at the end of the day, it's still a vessel. It still needs to comply with marine warranty surveyors criteria. And the difference is very little. However, how many dedicated vessels are laying along the quaywall at the moment that can sail tomorrow to repair a cable? The answer is very few. Probably one, maybe two. And if you're lucky, the CAPEX projects, particularly in this time of the year, are not ongoing. So there might be some vessels along a quaywall that are readily available on a very opportunistic basis. But you don't know that. You don't know when your cable is going to fail and when you need a vessel. So it must be kind of reassuring that there's a number of vessels in the market that are actually dedicated to these kind of tasks and are available if everything fails. So that was ENSI, that was cable repairs.
Thank you, Jack. I thought I already heard police coming for you because you spoke badly about customs and immigration. Yeah. Yeah, exactly. Okay, do we have questions for Jack? Oh, then I'll ask my own again. There is one back there. Yeah.
Hello. Hi, Jack. Thanks for the presentation. Davide Nobile from Prismian. Just a quick one. You mentioned the importance of an early engagement also with the owner of the cable, of the supplier. Can you please elaborate a bit more on the importance already in the pre-engineering phase, in the pre-engineering scenario, of having an alignment on all the requirements between the equipment and the mobilization of the vessel and the jointing team? Because in our experience, also working with you, this is a crucial element which reduce dramatically also then the operations. And so in your experience, according to the repairs you have performance, your track record, which is the big difference when this solution is not in place?
Yeah, just trying to understand your question properly, Davide, but yeah, in your case, you're talking mainly about export cables and interconnectors, which 9 out of 10 times require a offshore joint or a subsea joint. And of course, for these joints, you need about between 11 and 14 jointers on board of the vessel during the repair period. They don't have to be there on board all the time. If we're not too far from the shore, we can bring them on board. Typically, most vessels, and you can have a vessel of 60 people on board or 100 people on board, but most vessels don't have sufficient accommodation to keep such large groups of jointers on board on top of the on top of the repair crew. So we quite often have to exchange a few people like ROV operators or equipment operators to make sure that the jointing. I think, but you probably can confirm that, or NKT can confirm that. I think jointers are even more scarce than cable repair vessels. So when you have an offshore joint or a subsea joint, the most critical element is quite often not the cable or the joint or the vessel, but is actually the availability of high voltage jointers, particularly if you get into the more complicated cable systems like MI cable. It's quite a rarity. I don't know if that answers your questions, but
Yeah, no, it replied. It was just to point out and to understand if also your opinion is that, I mean, when you have already an early engagement and a pre-engineered scenario where you put together the two pieces, so the vessels, so the assets, and the people, in our experience, this was the game changer. I mean, it reduced dramatically the timing then to go in operation compared to a situation where you need from scratch to engineering the scenario with a partner, let's say. So.
That's very true. I mean, I think why our collaboration is quite a good one. And I think if you can deliver the client a turnkey solution of joints and jointers, I think that's a winning element, as NKT can confirm.
We can confirm that. The problems of getting jointers, I don't know what you're talking about. Do we have any sorry? Do we have any further questions? Yep.
Yeah, good afternoon, Jack. Steve Ascroft, Manx Cable Company, Isle of Man. It was just really to talk about emergency desktop exercises and the value we get out of them. Is it something you undertake yourselves with the customer or the cable owner?
Yeah, we do that with the main framework operators, where we have a framework with. We sit together once a year, sometimes twice a year, go through a number of scenarios, and basically treat it like there is a cable fault or a cable failure, and then follow all the steps, bring the team together, and then do of course, lessons learned evaluation. Depending on the size of the framework and the money involved, we can make that very big in the 2-day sessions. We can do it in a morning or an afternoon session. But yeah, we do that a number of times a year with our clients. Yeah. And it's very valuable because there's always things that come out of these sessions. Either there are changes on the client side, there's new data available that somebody forgot to tell us, or we have changed our internal procedures and we didn't update them towards our clients. It just happens.
Just another thing as well, the re-energization of the cable circuit, that can prove quite challenging, especially on long interconnectors, the test sets, or potentially it comes down to the final thing, the big test, it's throw the switch.
Yes, so we repair cables. So after a while we give the cable back to the client. If it's an inter-array cable, we do the high voltage management. It's not so easy or not so challenging to switch on the cable. Of course, if it's an interconnector or an export cable, there's a lot more to be said. And that's we leave that to the client, to be quite honest.
Perfect. Okay, we have a couple. Let's do one more in the back and then we move on. Yeah.
Thank you. I'm Peter from National Grid. Jack, can you explain the difference between your product, the service level agreement, and the warranty provisions that are provided under the main contract agreements? Is your service supplementary to a warranty, or is it part of a warranty?
Yes, it depends on the client, but let's say that typically a cable system gets a 5 years warranty from the OEM, from the manufacturer. If the cable fails in that period of time, the OEM has the responsibility to repair the cable. Very simply put. And after that period, of course, the cable owner will look for somebody to do the same job if the cable fails, but then at their cost or at their insurance cost. What you see is that because of the long-term agreements that some of, for instance, the interconnectors have now, including a warranty or a maintenance obligation towards the OEM, that some of the OEMs are saying, we won't do that. Find somebody else to do it. And then these people reach out to NC and say, or others, can you take over like a lifetime warranty arrangement for the cable? And we are negotiating a few of those at the moment. It's a relatively new scenario. It hasn't happened that often, but we see it more and more that also the warranty period is covered then by an independent contractor like ourselves.
Okay, thanks.
And it makes sense to a certain extent. I mean, warranty is something, of course, if the cable fails or if there's a defect, but if you have a specialized party in repairing cables, you might as well involve them from day one after the cable has been energized, in part, instead of splitting it in between two. But contractually, it's a bit of a nightmare.
Perfect. Thank you very much, Jack. Yep. So our next presenter will be Andreas Hallengren, Principal Business Development Manager offshore at NKT.
Thank you very much for that introduction, Jakob, and thanks for a very good presentation, Jack. So, for those of you now who paid attention to the agenda, you can see that I have actually changed the title of the presentation, so apologize for that. But listening to this first 1.5 day of presentation in this conference, I think we can see and hear all the discussions about risks, how we're managing risk, the need for collaboration, the need for maybe cross-OEM initiatives. So bear with me, I've changed it slightly, and of course not only the title but also the content, and I hope we'll be able to release some really fresh and relevant client case study here in this presentation. My name is Andreas Hallengren. I can come even closer. Oh my God, yeah. So my name is Andreas Hallengren. I work as a Principal Business Development Manager for NKT, our service and installation business line, where we then works towards the aftermarket, offering service agreements and executing repairs to the market. But let me start by introducing NKT then. Obviously been around for quite some time, founded back in 1891 and delivering innovation since. Today supporting a wide range of cables from building wires up to 640 kV and also the installation of those systems. We're delivering a robust results to our shareholders, actually releasing our Q3 report today for those who are interested to review that one. And I mean, we are growing with sustainability in focus, a proud enabler of a green transition, connecting a greener world with our cables, and maybe should I say also reconnecting a greener world by repairing also cables. We are today a truly global company with operations in more than 16 countries, having over 6,000 employees globally. And myself being based in Karlskrona, of course, I'm very proud of all the investments that is put in, now especially in Karlskrona here, to meet the market demands. We are investing 1.3 billion euros in the small city of Karlskrona to meet those demands. So I'm very glad, René, to see that I was not cursed with a cross in your presentation. Seems like we will be around for a couple of more years. And of course, looking at the proof point of those investments is now the third extrusion tower, 200 meters high, a fantastic landmark in the small city of Karlskrona. But of course, it's not only the cable manufacturing capacity that we're increasing. We want to continue, as René also said, to be a relevant turnkey installation provider. So that means we also need, of course, to increase our installation capacity. So we have our NKT Victoria, as most of you hopefully know. As you can see here in the lower left side of the picture here. But in 2027, we will also introduce NKT Eleonora, an amazing vessel, which will more than double the capacity compared to Victoria. be able to, with 3 turntables, be able to load 23,000 tons of cable. Having said that, and then maybe moving to the content of this presentation. And I guess this question, what risks are exposed to, I think all of us, you, should be able to respond after listening to all those sessions during this first 1.5 day. And I should not dwell too much on it, but maybe share a little bit different perspectives as well. Now we start by referring to and using an external study for one of the interconnectors that we actually have heard mentioned here earlier. It's a risk assessment study for the IFA2 cable, connecting an interconnector 240 kilometers long, connecting UK with France. And there's, of course, a lot of details in this slide, but if you focus on a little bit on the availability to start with, you can see that in this case study, they estimated that the availability of the cable system will be 96.5%. It is, of course, really good, but it also means that you will have 3.5% downtime of this cable system. And over the lifetime of a cable system, of course, that is a massive impact. If you break down and look at what is causing or expected to cause those outage, you can see that the offshore cables constitute 2 out of those 3.5%, or put it in other words, the stochastic impact of the offshore cable is 60%. So even if the outages of the cable is not expected to happen that often, 0.1 failures every year, which means a 10-year mean time between failure, the impact when it happens is massive. In this case, they estimate 76 days to repair. So of course, if we can increase the mean time between failure and address the mean time to repair, that will be very effective for the business case. Another perspective is, of course, to look at reality. I mean, as has already been stated, we will continue to see those spontaneous errors, faults, which is caused in manufacturing during installation. But with processes and procedures, methods in place, we will mitigate those issues. We will continue to have accidental failures, like in the photo you see an anchor, or it can be a fishing gear pulled into the cable, damaging the cable. And unfortunately, I think in the geopolitical unstable world that we all live in today, we will continue to see more of these malicious activities. I think all of us woke up in 2022 with explosions over Nord Stream. And I mean, it's taken us to where we are today, with the shadow fleet operating in the Baltic Sea, Russian, Chinese vessels dragging anchors and threatening critical infrastructure. So the question is then, how can we address those? To NKT, it comes down to 3 principles. It's about prevention, it's about preparation, and it's about mitigation actions when something happens. And prevention is a lot about monitoring, starting with internal monitoring. And people have already talked a lot about that, and there will other presentations coming, so I will not dwell too much on that. But utilizing the fibers today integrated into or bundled with the power cables is, of course, a great source to utilize acoustic sensing, temperature sensing, in proactive way, monitor the condition of the cables and hopefully prevent faults to happen. Can even be used then to optimize the utilization of the cable over time. Second would be the external monitoring, looking at referring to vessel monitoring, utilizing AIS technology to monitor vessel traffic over in vicinity of your cable systems, set up geogrids in a graphical user interface, and if you identify any kind of suspicious activity in vicinity of the cable systems, trigger an alarm and reach out in a proactive way and hopefully be able to reduce the risk for a cable impact. Last but not least, cable surveys. Really essential, and of course, to monitor the conditions of the seabed and the conditions in general around the cable systems. How the cable is protected, do we have any freeze spans, how deep is the cable buried, and very importantly, which has also been stressed several times here during this conference, to do this recurringly, to have to understand how this changes over time. essential for preparedness. Preparedness being essential for cable to address a cable fault and, of course, execute the repair. Normally, when I do this presentation now, moving from preventions into preparations, I will talk about the structural way to structure your documentation and repair preparedness plan. But I skip that part now to spare some time for the client case study instead. But I still want to stress maybe one of the most important things here as part of preparedness plans: be on top of your spare parts. And being on top of your spare parts, of course, NKT can support with everything from simple inventories to make sure that all the status of all spare parts, that they are not expired or up to date, do risk assessments, give recommendations of how many, depending on the risk assessments, spare parts, joints terminations, spare cable length, etc., you should have. But we can also support to optimize the spare part strategies. And yeah, I talked to Alex here after this presentation yesterday, just informing that, that there are actually alternatives to the power CCL joints. NKT a couple of years ago introduced an adaptive rigid C joints, which you can see here on the photo, and I can also share more details with you later if you're interested. Which then means that we, with a single set of base joints, can then adapt this joint to multiple cable systems with flexible adapters from in the electrical joint, in the inner watertight casing, and in the outer mechanical casing, meaning you can reduce the number of assets that you need to have in storage and also keep over time. And importantly then, it is OEM independent. So it doesn't only support NKT and ABB cables. And of course, we sell this to the market, allowing asset owners to have those in-house to enhance their spare part strategies, but we're also keeping 3 of those in our stock to be able to help in case an asset owner, in case of an outage, do not have spares or for any reason cannot use the existing spares. Moving from preparation into mitigation. Again, I would normally talk about service agreements and getting commitments in general and how we can structure that. I skip that part now and again jump into maybe what also has been focused on quite a lot here and one of the main challenges with the vessel availability. How can we give commitments on this? To NKT, of course, we would like to utilize our in-house assets. You have seen the NKT Victoria. You have seen that we're investing in new vessel assets. NKT Eleonora will be available in 27, but we are also doing other investments. René mentioned the nearshore barge that we recently acquired. Will also be a good asset to support more shallow water in the future. We have frame agreements with third-party suppliers. We have support vessel supplies. We are investing in our also trenching equipment to be able to do, of course, end-to-end turnkey installations, but also use this for remedial actions as well as potential burial in the end of the cable installations of our repairs. But that is not enough to give the commitments. We cannot only rely on our internal resources. Second part would be to have a good network of third-party suppliers, pre-mobilized vessels like cable lay or cable repair vessels that Jack alluded to. But again, those are also scarce today, as Jack also is repeating what he's saying. So in order to be able to utilize the bigger pool of offshore construction vessels that are out there, normally more available, NKT has also invested in a set of cable handling systems, having all the parts that is required to handle the cable handling with the cable integrity in focus and a modularized approach so we can mobilize this in a quick way. And that includes all the parts from turntables, cable guidance, tensioners, winches, chutes, quadrants to overboard the system, overboard the cable in a safe way. And with this, I would like then to move over to and showcase how we can actually, this can come together and talk a little bit, talk you through this case study. And now we are moving to the very relevant case than being here in London, but moving a bit north, in the northeastern coast to UK, to Scotland, sorry. And it's the Beatrice wind farm. So Beatrice wind farm, just to introduce that shortly, for those of you who don't know it, I mean, with 84 turbines, 588 megawatts of total power, ranging over 75 square kilometers. It's one of the biggest wind farms in Scotland, not only to size, but also to the investment that were put in initially. It's operated, the wind farm is operated by a consortium with SSE Renewables as the majority owner. And the offer for this export cable is Transmission Capital Partner, TCP. When this cable went down, which it did unfortunately in end of April this year, leading to two cables connecting the wind farm to shore, leading to a 50% decrease in power transmission capacity. Of course, this is a huge impact given the fact that it's powering 450,000 households in Scotland. The scope were quite early identified to be a total complete turnkey solution, and NKT could respond with having the repair units, utilizing and also executing our strategies, having the cable handling system to mobilize repair or offshore construction vessel, turn that into a repair vessel. We actually mobilized 2 vessel spreads. We also had a support vessel here. There were partly rock installation along the repair route and also some need in the early engineering, without going into details, for CMOPs. So that's why. And it was a standard repair from that perspective, 2 joints, in and out survey, delivering all the engineering and documentation related to this, protecting the cable afterwards. And this, of course, required a very quick response. And the 2 partners, in this case, TCP and SSE Renewables, they initiated a very well-coordinated response. They, in the end, contracted NKT to execute this turnkey repair. And we could, in this case, really show our strategic planning and also execution capabilities. And with experience that we have from similar projects, we managed to deliver this project from contract signing to power to the cable, repowering cable within 38 days. Given what have been discussed here earlier during this conference, I think this is a very good reference. And what was the key to success here to be able to deliver this? First of all, having the cable handling system, it's we keep this in a strategically well-positioned location in Emshaven, being well prepared on standby to be able to utilize again the big fleet of offshore construction vessels. And in this case, we could actually, I need to correct you, Jack, we actually didn't do it in 10 days. We did it in 6 days. So it is actually enabling us to do a very quick mobilization of such vessels. Secondly, to have the adaptive reed units. Not only that we have this and we can sell it to asset owners to optimize their or your spare parts strategies, but also in this case that we keep 3 of those in stock. And in this case, the asset owner had risk assessed the existing spare joints that they could not be used. So that's why it was, instead for being depending on supplying new joints from the market, we could provide those and mobilize those to the site within a couple of days. Thirdly, of course, this is based on having a wide network and trusted partners. The vessels, as I said, we used a 2-vessel approach here, and of course the vessel is the obvious one, the big things that are delivering this is such a complex repair, expect for all the resources and equipment, of course. In this case, we had the North Sea Giant from Motion Installer as the cable repair vessel, which was turned into the cable repair vessel, and we had the Northern Victoria from OEG Subsea. And of course, that it comes, there's a lot of other interfaces and sub-suppliers that are delivering this. I mean, having the partners in Emshaven with Wagenburg, etc., doing everything from welders to having support resources as part of the crewing to the vessels, etc., etc. So no one mentioned, but a lot of people goes into generating this. So just to finish up this case study with a couple of customer testimonies as well. No one of them could be here, unfortunately, but starting here with a comment and a quote from Bruce Turner, who is the asset manager at TCP. And to summarize what he's saying here, you can see that the key enabler for the quick response, also compared to other solutions that were available in the market, was the fact that we had this adaptive redesigned and could deploy it to the market very quickly and leverage on the NKT's end-to-end capabilities. Second quote, it's a bit long, but if we focus on the essentials here, it's from Elena Banayans, who is the general manager at SSE Renewables, responsible for the wind farm. So you can see she's more stressing the complexity of such products and the need for collaboration and having a team who are coming together, working motivated towards the same goals. You can see that her stressing that we can, with the solution that we put forward, could reduce the downtime substantially and significantly reduce both the power outage as well as the revenue losses, which I think is very good and positive feedback from an asset owner like this. Having said that, coming to last slide of my presentation, and I hope from different perspectives I've managed to show that yes, even if the cable outages doesn't happen so frequently, when it happens, I mean the impacts are massive. Prevention and monitoring is essential. We differentiate between internal, external, and maybe the importance of doing recurring surveys to be on top of any control of the conditions of the cable. Preparations are essential. Repair preparedness, as several of us has alluded to, is essential. One part of that to be on top of your spare parts strategies, and NKT can support to optimize that with the adaptive redesign, which I've shown, and I can share more details about it if you're interested. Last but not least, repair projects are complex operations. It takes a good partnership, both for you as an asset owner, to us, the one executing this, but also for us having a good network to rely on. I think that's it. If you're interested to discuss and understand how we, NKT, can help you to enhance your preparedness, and I'm glad to discuss that further. And also, I have a couple of folders here for the adaptive redesign and the case study, if you're interested to get one of those copies. Thank you.
Thank you, Andreas. I have to disclose conflict of interest. Andreas reports to me, so I will not be asking questions. Thank you, René. Please go ahead.
Thanks, Andreas. It was a very nice presentation, and I think you have done a very good job. But one thing, can you elaborate on the time between the outage and when you signed the contract? Because I think that initially you could, when you have known already 2 months in advance for signing the contract, so your preparation time could be much longer. But what happened between April and June?
Yeah, that's a good and interesting question, of course. I wouldn't expect anything else from you, René. And now trying to be politically correct here, but I think taking two steps back here and seeing the bigger picture. I mean, the off-gam and the off-those and all these, maybe people have touched upon the conflicts of interest that we have here. I think the issue with the OFTO being responsible for the export cable and not necessarily having the means to move forward quickly, rather have under initiatives or incentives looking at maybe finding the absolutely cheapest solution here and now, rather than going forward quickly. I think that is where we ended up in this discussion. And then, yeah, I mean, then we saw the other interest, and of course, from the one suffering in this case is the wind farm owners, right? And in the end, they stepped in, and then it was a very quick process. Let's put it that way. I can elaborate more about this, but also trying to be politically correct there.
Okay, thanks. I have a second question.
Yes.
If I remember correctly, those export cables were produced initially by NKT. Did that help?
In this case?
Yes.
No, it was not. It was another OEM producing this cable.
Okay, sorry.
Thanks, Andreas. Just a quick question from me. I wanted to know if, here. Just wanted to know if, given the use of trusted partners in that Beatrice repair and the use of your C-joints, would anything in that process have changed if that was a response under a warranty?
If it would have been, to also tie it to the second question of René, if it would have been within the warranty, NKT would not have been involved in this case, since it's another OEM's cable system.
Yeah, but if it was one of your cables, would any of that process been any different, or would you respond in exactly the same way?
I mean, if it would have been an NKT cable system, I mean, our business line, we are responsible for the warranty during typically the 5 years that's been referred to here. And then we are doing a preparedness, we are doing a handover from the installation, turnkey installation product. We are taking over the responsibility and all the documentation, we're doing preparedness, and we have the means of executing the repair during the warranty. So you would not see the period that referring to René's first question between April and June in this case. That would be much shorter. And in general, that is also the difference, of course, not only from warranty, but if you compare to having a service agreement or not having a service agreement.
Thank you.
Perfect. Let's take one final question.
It's a very similar question. The service that you're providing or that you've shown on the screen just there in your presentation, is that included within your warranty when you buy an NKT product, or is that a separate service level agreement that would need to be purchased?
The boring question is that it depends on the contract. But I mean, in general, yes, it is. I mean, we need to, normal cases, in most cases, we have commitments in terms of response times when the cable need to be repaired.
And would that be the same for third-party damage as it would be for a failure of the cable?
Well, that is, of course, a very good question, an important differentiation, because I mean, if it's a third party in external impact generating the fault, then it's not under warranty, right? So that then still you, as an asset owner, would be required to have let's say, a service agreement if you would expect to have a commitment in terms of response times.
Okay, understood. Thanks.
Perfect. But then, Andreas, thank you very much. And we will move on to our next presenter, and that's going to be Etienne Rochat, CTO at EOS.
Good morning, ladies and gentlemen. Over the last 2 days, we've been hearing a lot about the importance of monitoring and fiber sensing in particular. And this is just a source of joy for me, if I may say it this way, because fiber sensing is not only what I do for a living, but it's also my passion. So glad to hear that. Today, I'm going to broaden a little bit the scope, and you will understand very quickly why. Just introduce EOS as a company, then speak about electrical measurement, then about optical measurement, and eventually move into sensing solution in the field and conclude. Why in that order? Because you see that there is my company name hidden in the background. Good. So EOS, Electrical and Optical Sensing Solution. What is this about? EOS is the merge of first Prysmian Electronic, a startup from the University of Palermo in Sicily, founded in 2008 and integrated into Prysmian in 2012, together with Omniscience, a startup from the Swiss Federal Institute of Technology in Lausanne, in Switzerland, founded very early in 2000 and also integrated into Prysmian Group in 2021. And together, that became EOS, the E for the electrical part, the O for the optical part, sensing solution. And in the background, the owner is Prysmian, happened to be a very, very big power cable company. I think you probably know most of what they are doing there. And Prysmian is promoting strongly innovation in the background with 4 pillars, one pillar being EOS as the optical and electrical sensing company. That's for us in the background. So what we provide basically is a portfolio of distributed measurement based on fiber sensing, meaning temperature, strain, and acoustic, DTS, DSS, and DAS to use our jargon, proprietary solution for all these interrogator. We have also proprietary solution for electrical measurement, mostly featuring partial discharge and also shift current monitoring. We have some pictures of this system in the background. And then all this is talking to a asset monitoring solution, mostly a software platform that is collecting the information from the different interrogator, get the data together, process them, bring alarms or meaningful information and send it to the end user, usually through a geographical information system, a GIS. And then on top of that, we have service level agreement, technical support with all the guarantees and the people available to help and support the customers. And also in the background, we have the ISO certification that we need in this kind of world we are operating in. Let's go into the electrical measurement and in the partial discharge in particular. Partial discharge, you have to think at small sparks, electrical arcs in the system that are there, low energy, but they kind of grind little by little the power cable, the insulator, and at some point you get a shortcut, and that's the end of the story. So we can measure that using this. Is that pointer doing something? No. Well, never mind. That pinkish kind of rectangular shape is a sensor that is deployed on the termination, on the power cable, grabbing the electrical field, and from this we accumulate those perturbation of the electrical field with reference for the phase, AC cases in there, and we see in this diagram with the sinusoidal shape the accumulation of those small patterns. And from this, the specialist can work out what type of partial discharge is in the background and the dangerosity that is there, and if there is any mitigation method to do that. These are examples of what we can see in the field. I'm trying again this. No. So the top one is an internal partial discharge, something related to the insulator, so the polymer material which is there. It has a very typical signature, kind of a symmetric one. You may have surface PD, which is yet a different pattern, and the corona. The corona is the one you hear if you are close to a power cable or these kind of things, the zzz sound, which has yet another very typical pattern. And when you do this acquisition with the wing sensor that I was showing before, and you have the reference with the phase, you can accumulate the energy, look at the pattern, and work out what is happening in the background. You can do more with the electrical field and those measurements. You can do also a bit of monitoring. One of them is the combination of electricity and optics, electrons and temperature measured by the fiber, known as real-time temperature rating. That's something which has been around for a long time. But you can do also electric field rating and look at the way it behaves across the power cable. And you see funny things like you think everything should go in one direction, but suddenly you have an inversion in the field. And that is important to know when you want to do polarity reversal, when you want to change, have rapid energization and things like this. So all that is driven by the understanding of the electrical measurement in the background. Let's move to the optical measurement. That's the one slide, does it all for fiber sensing. So basically, most of the systems send the pulse of light down the fiber, and then the fiber, although extremely pure, will send back a little bit of light to the emitter. And this is being measured according to the different physical properties. It's measured over time. And because we know the speed of light down the fiber and we measure the time, then we know the position of the event. That's the localization, which is key to any fiber sensing. And then we have basically 3 backscatterings to choose from. And Rayleigh, Brillouin, and Raman, that's the name of the scientists that discovered that 100 years ago or plus. And so if we look at Brillouin or Raman, we can work out the absolute temperature. So it's a process that can be calibrated, and along the fiber, meter per meter, more or less, we can say the temperature is 20, 25, 30, or whatever. With Brillouin, it's also possible to measure the elongation of the fiber, deformation, the things that we've been hearing in some previous talk. And with DAS, mostly, we are looking at the variation of the signal over time. So the DAS is a kind of a differentiator, looking at the Rayleigh backscattering. And by analyzing those variations, by analyzing the pattern of those variations, we can work out what is happening on this. We'll probably hear more in the next talk on that topic. What is important is that the Raman and the Brillouin process can be calibrated in the sense that you can go back to a measurement, you can go away with your system, come back in a year, and you can continue the measurement, which is not the case mostly with the DAS system. Now, we are at the level of the interrogator, referring to the optics, but also true to the electrical measurement. This is where we measure. So we have a fiber, we have a sensor, we extract something out of this, but we don't have yet any useful thing. So we need to change from a measurement to a monitoring solution. We need to combine those data or to process those data in such a way that we can get alarms, that we can get an information that is useful for the end user. So it's transforming the sensor into data, transforming the measurement into a monitoring. And then, depending on what the application is, we are going to push an information to the customer, like you have a hotspot on your power cable, or you have a leak on your pipeline, or you have an anchor that just hit the power cable, or is about to hit the power cable. And that's where basically the data is transformed into information. And then whoever is the asset owner will have to manage from this monitoring and take a decision, like curtail the wind farm, repair the cable, stop the pipeline, or whatever the topic is. And so it's very interesting because the fiber, that piece of glass can be deployed in multiple different assets, and it's kind of asset agnostic. But depending on what you are looking, temperature, acoustic, strain, and depending on the application you are looking at, that you get different information from your sensor. So let's go into the field and see some example of how we deployed those technology. A few examples from partial discharge. In there, the interest is to show the evolution of partial discharge over time. And you see that the scale is getting bigger and bigger and bigger, and then over a few months, well, end of the story. And then you have to go back and repair the joint or do whatever is required. So usually those tiny things end up in a massive disaster on the power cable. That's another example, and I'm always amazed there. So you do see pattern, and if you are a specialist of those things, you would say, this is where the problem is, and this is what the problem is as well. And if you look, well, that was not absolutely perfectly cut during the installation. But I mean, for me, it's like perfect, but for the electrical guys, it's not. And for the electrical field, this is just a nightmare. And so in this case, mitigation had to be done to replace the things, and then it was okay. And then basically you can deploy this, you can scale it up on every joint that you have, for instance, on a LUNT cable. Example there with about 150 joints and different terminals. And you just get these partial discharge, for instance, when you get the first current down the cable and you look at the data. And in this case, one of them was not suitable and corresponded to an issue on the system. another example of what partial discharge can do for you when it enters the game. Fascinating story. Now moving to the optical side of the sensing solution and to one of these big wind farms which are around the UK, the Hornsea one in this case. I think it's still the biggest one in operation, but there are larger that are coming shortly. In this case, there are 3 export cable routes, around 500 kilometers of cable, every single meter being measured by a distributed temperature system. And I think it's the longest and most complex AC system that is fully measured with DTS. What is interesting there is the combination of different interrogator installed onshore in the reacting power section at the middle point along the cable and installed in one of the 3 offshore platforms. And then you have different routes with fiber loop. That's the solution that is in the background for the long distance measurement of temperature. And all that allows to cover all the cables. And then those data, like the measurement on circuit 2 from the second DTS in the direction whatever, goes on a 0 to 160 kilometer map, and so you have the full temperature trace. And these are just a few examples for the sake of the discussion. Usually the fiber loss that we measure in the field, which is our key criteria for fiber sensing, usually is much better than one is designed to begin with. And it helps us either to go to further distance or to have better performances than what was expected. And the measurement there shows dotted blue line, what should have been the performances with the nominal loss, and the straight line is what we measured, and we work out that the loss was much better than expected. But also, what is interesting is to look at time variation and ultimately load variation of the signal. Because you could look at this and say, well, that's a bit messy, there are peaks and valleys and looks a bit strange. But actually, every single thing there has an explanation somewhere. And we did once trace all these kind of things, and some of them are related to changes in the seabed material. And all there is kind of hidden in those data. And if you zoom in, and we've seen this already before, that's the J-tube, and we see the seabed and the cable in the water, then the cable in the air. And it's absolutely fascinating because the hottest position is not necessarily where you expect it to be. Another example from a wind farm in the Baltic Sea, the cluster Vikinga-Arkona. Also very interesting, in there is a real-time thermal rating system, and I jumped on the calibration and concentrate on what is there, because there was a question before. This is the DTS trait is the kind of blue things, and it goes up and down because there is production, so the cable is warmer and the fiber is warmer when all the turbines are on, and obviously if the production drops, then temperature goes down. And we see that the other curves are basically the measured ocean bottom temperature, or the model, that one, is actually the surface water temperature. And in this case, we are in a non-well mixed water scenario, so there is a difference between the surface temperature and the ocean bottom temperature. And we see that the DTS traces in a position where the cable is exposed to the seawater, like the exit of the J-tube, is very much following the temperature of the water, which shows, by the way, that the system was properly calibrated. And what puzzles me more, what I find even more interesting, is that when you compute the conductor temperature, which is the orange traces using finite element modeling and the load and DTS measurement, you do see a sinusoidal pattern on the cable. And that is given by the change over a year of the water temperature. And usually, when the cable is designed, the assumption is flat temperature year round. Well, okay. Now, think at the bottom, there is margin to push more current in the cable because the cable is cold. Now think the other way around. With global warming, we may be in a situation where the water temperature eventually is more than what was the design temperature, and we don't have room anymore to push the current. And then all that is again embedded into this temperature measurement. Last application is DAS for fault finding. So we know the cable never fails, but we've heard that they do eventually. And if you have a DAS in a system, then you can grab the position. And in this case, there was a fault that was featured by a hotspot. It was a repair campaign, and in the repair campaign, the vessel was driven by the DAS, comparing the DAS position and the DTS position. So it's like my colleague looking at the screen, calling the captain and saying, move a bit, stop, and this is it. And I mean, you can smile, but that happened a number of times, even recently, and I find this absolutely fascinating. That's another example of a DAS fault, a short circuit, and in this case, the location of the fault as seen by the fiber within 10 meters of the post-mortem analysis. So it really does work. Now, joining a little bit the previous speaker, if we combine the monitoring solution and we look at the full lifetime of the cable, we get something interesting. Partial discharge, the electrical measurement at the beginning, first current tells you about the quality of the joint, the cable, helpful and useful. If you combine DTS and real-time thermal rating, then you have to some extent failure prediction. You can optimize the operation. If you add DAS on top of that, again, failure prediction, failure location, and eventually if you have the combination and all that, you have a nice system that protects your asset. And so obviously, my mother company, Prysmian, is also looking at the full set, trying to promote this aspect of prepare everything and organize everything so that it works well. So in this case, 3 pillars: the monitoring, the preventive maintenance, and the ready to repair, us being into the asset monitoring. Having said that, we not only measure and monitor Prysmian cable, we measure whichever cable or asset has a fiber on it. So it's about time for me to conclude. I think electrical and optical sensing are now mature technologies. They don't have impact on the power cable manufacturing. They do long distance coverage. They are field proven. What is very important is to match the electrical or optical system to the application. If you need a thermometer, a DTS, don't use a microphone, a DAS, or the other way around. So just use the right tool for what you are trying to measure. PD on its own is something a bit different. And combine when suitable. And in fact, I would say it is always suitable. Good data is fundamental for the application software. If you want to do any electrical field prediction, any real-time thermal rating, any depth of burial prediction, you need to have good data to begin with and make sure that your measurement is matching your asset. And always think life cycle, so electrical and optical sensing, maintenance, repair. And then, well, I will be happy. Hopefully, you will be happy too. Thank you very much for your attention.
Thank you, René. Do we have questions in the audience? We have a few. Perfect.
Thank you. Hauke Meron from NBW again. I was wondering, with the background of Prysmian, is your system you just presented compatible with any cable supplier or cable design, or is it?
So basically, we are measuring a fiber. And the fiber doesn't care who is the producer and who is the cable around. So the short answer is yes. Now, obviously, if you buy a Prysmian cable with monitoring, or if you buy another cable with our monitoring, it's not exactly the same route, but you will have the same measurement at the end of the day. Yes.
May I give a follow-up question? Okay, great. Maybe you can elaborate a little bit on the requirements or constraints, not going into too much detail, but as a developer, we seek the best solution between worlds and suppliers. So we would be interested to get a better picture on the technical requirements on the cable design or fiber optic cable design.
So I would say, as long as you are only looking at temperature or vibration, DTS or DAS, just go with the classical loose tube telecommunication cable, 46 fibers, 96 fibers, and whatever. It's already there in the power cable, usually. If not, make sure you get one. And then we, as a fiber sensing community, can do something. Now, if you want to enter the game of shape sensing, of movement, of tension, which was shared in a previous measurement, then we need to change slightly the cross-section of the power cable. And then you have to specify this first. So you have to say to whoever your cable supplier is, I want this. And then we can get basically a tight buffer fiber, so a fiber that is locked somehow into the cable design to transfer the movement to the fiber and then measure that. But unless this is your interest, if you are in the classical approach of DTS, DAS, real-time thermal rating, single mode fiber, the lowest loss as possible because we can go further, and just make sure that you have the fiber in the cable or bundled with the two ports if you have a DC pair, or integrated into the sheath or whatever the design is proposed by the cable manufacturer.
Perfect. Thank you. Do we have another question? Yes, there is one here.
Tarek Dowd from Sompo International. Can you give a view on what the future is for DTS and DAS systems for monitoring in the future? Where is the technology heading, considering the evolution of fiber optics and digital signal processing?
I think we are all trying to go further. And we've been hearing about these massive power cables that are coming. So obviously that's a challenge to us. So that's one way. On the DAS, I think the challenge and where we are moving is the processing of the data. Today, a DAS system is giving you something like a terabyte of data per day per 50 kilometers of cable. So it's like, hop, that's your terabyte. What can you do with that? Completely useless. And a lot of effort is on the processing of those data to extract what is meaningful, to bin what is not, and to keep going. So a lot of the things, and if you look around, if you look in the literature and in the conference, a lot is around the processing of the massive amount of data which is there. It's not quite solved. I mean, we all have to learn to live in that digital world with the pile of data that DTS and DAS are giving us.
Just a follow-up question. Do you see any new doping chemistries or anything to make single-mode fiber more lossless?
That's an interesting question. The hollow core fiber are becoming very fashionable. And hollow core is basically the light is conducted in air. So it's absolutely great for the loss, but air has far less backscattering than the normal fiber. So if we have too many hollow cores, I suppose we'll have a bit of a challenge with the fiber sensing. But this we will work out. Otherwise, I'm not a fiber specialist on the chemistry, and the only thing I've heard about to massively reduce the loss is really by removing the glass. Apart from that, you can find fibers on the market with loss probably in the 0.14 dB per kilometer or things like this, which are very good. Make sure they are cabled correctly. And don't use that if you have a 10-kilometer cable, is useless. You see the difference between a standard fiber and an ultra-low loss fiber only when you are talking about 60, 70, 80 kilometer plus. Before that, that's fine.
Okay. Thank you.
Perfect. Any final question for René? Sorry, for Etienne. Sorry, it's also late for me. No? Then I'll have one final one, because you showed something interesting, and that's some cases around partial discharge.
Yep.
Now, so far, conventional wisdom has been that if you see partial discharge on a high voltage cable, it's already too late, it's going to blow up. And I think you showed us some measurements, but you also showed us terminations that failed. So clearly the measurements were not convincing enough yet.
Well, according to my specialist in PD, because as you know, I'm more a fiber guy than an electron guys, if you start seeing partial discharge, you don't have a lot of time, like weeks-ish, something like this. So, well, you better react quickly. But I think if you do have them, you know there will be a failure. And especially if it's at the installation time, so before you start producing and all that, you can say, okay, you can pinpoint that there is an issue in the termination or an issue in the joint, and then work out or change this and repair before you go into production. So it's a kind of, I would say, a quality assessment before you go into production. Online PD monitoring, then it gives you an early warning, but yeah, that's going to fail. Yeah.
Okay, perfect. But then, thank you very much, Etienne.
Pleasure. Thank you.
And let's take our final break. So we will meet again at 4:30. Good. Okay, let's take our seats and we will continue. We have 3 more presentations ahead of us and a panel discussion. So let's save the discussing for then. Gentlemen? Yep. Good. But then we're moving on to our next presenter, and that is Dan Keller, Head of Monitoring Solutions at High Volt Prüftechnik Dresden.
Yeah, thank you very much. I would like to give you a presentation about the digital twin of submarine power cables from concept to reality. And yeah, High Volt is a company that is mainly focused on high voltage test equipment manufacturing. So that means we are based, or our main focus is the electrical engineering, and therefore I would also like to show you some concepts of electrical measurements on the cable lines. We have seen very interesting presentations about fiber optic monitoring and measuring solutions, but what I would like to show you is like a complementary solution that could altogether bring us to this concept of digital twin. But let us have a look what is the idea behind. I think as a summary of all the topics we already had is what are the key challenges for operators of HVDC cable systems. And when you have a look here, you see, of course, HVDC subsea cables also consists not only on the subsea cable sections, but also normally on underground cable sections and overhead line sections. And if you see, and if you have a look, what are the main challenges? On the one hand, especially for the DC cables, we have the converter pulses, we have cable joint assembly faults, we have corrosion, we have seen in the last presentations. We have the sabotage, what becomes unfortunately more and more important, also anchors. And in addition, like an overview about, we have of course in total an increased amount of cables, more also a lack of qualified personnel at the operators. We have also multi-terminal. Yeah, we have seen some interesting presentations about the multi-terminal projects that are realized or should be realized. We have also the polarity changes, what is especially for the older cable sections a problem. And yeah, I've seen also in the last topics the long repair time, what leads to very high costs, cyber attacks, and nowadays also like disturbed GPS signals. Therefore, what is an objective? If you have a general approach of monitoring, we would like to have a fast localization of faults where it occurred, but also an assessment of the condition of the cable lines, the evaluation of aging trends, and the detection of sabotage as a general objective. So when we have a further look in such HVDC cable lines, you see as mentioned before, we have the underground cable, the subsea cable section, and both, of course, we have the pole cables. And nowadays, for the future projects, in addition, metallic return or electrode cable lines, what leads to additional challenges, what I will explain a little bit later. So, what you see here is an approach based on electrical measurements. And this is what I would like to explain a little bit more in detail as a complementary, it's a very important topic, to the fiber optic systems. So what is the basis for coupling? Of course, from the component point of view, on the one hand, we would need some sensors for coupling and decoupling of signals. So we have HFCT sensors. You see in here 2 different kind of them that are mounted around the complete cable, and this allows a very sensitive measurement of very high frequency signals. A second topic what we need are the HIRES, that means it's are transient recorders or injection units. First of all, you see either passive systems like here the HIRES locator, that means the system, it's a transient recorder that allows measurement of high frequency signals. A second point on the right, injection units that allows the injection of frequencies and signals into the cable, and special also into the live cables under operation. And the third topic is something like the HIRES analyzer, a system that allows both measurement and injection in one device. More important than the second important topic is the algorithms and of course the evaluation units and systems behind. And there we have three different kinds. One is, we have also heard during the TENET presentation already, the online cable fault location or transient fault recording. This is a passive approach to localize a fault. And what is the idea? We have cable lengths normally, especially for the future projects, of several hundred up to 1,000, and longest this projects now 4,500 kilometers. And the question was, how is it possible to localize a fault very precisely? And I'll come back how this could be done with an electrical measurement. A second approach is a frequency response analysis on a live cable system. That means like an online TDR in order to localize defects and also changes in the electrical structure of the cable during the operation. And the third system we have seen in the last presentation already, partial discharge measurement. But what I would like to show you here is also an alternative, non-conventional method that allows to reduce the amount of measuring points. And all in all, and then we come already into the topic of digital twin, it's not about just a single measuring systems. It's normally a big benefit, or the highest benefit for the operator occurs out of an expert system. And expert system means you can get an you could implement access for different experts for different evaluations and cable types in order to assess a cable and in order to determine also the condition of such cable lines. Therefore, of course, also with the experts as persons, but of course also to implement step by step additional advanced algorithms, what we also hear very often as a buzzword, AI. Let's have a maybe deep dive a little bit technical aspects. How are the methods implemented? How do they work? And the first method is a transient fault recording. And what you see here is such a cable line. Yeah? This is a cable with this is a cable with a cable length of several hundred kilometers or 1,000 kilometers. And on the left side, you see an HFCT sensor, the transient recorder, and of course the connection to the expert systems. And if a fault occurs, and what means fault? A breakdown within a cable, some very high power pulses occur, traveling waves will occur, and of course they are traveling into the cable end where they can be measured, and of course they are reflected again there, and again they are reflected at the location of the cable fault. What we are doing is, very precisely, we are measuring the distance or the time difference between two reflections, and out of this we can localize the fault because in a first stage the propagation speed of within the cable was determined. How can such approaches be even improved? One possibility is to make like a digital or like to make like a cable model. That means injecting signals and analyzing propagation speeds not only as an average of the complete cable, but also evaluating different cable types and different propagation speeds within the cable in order to localize it more precisely. What is the possibility or the main accuracy of such an approach? It depends, of course, on the localization of such, or on the location of the fault. If it is in the middle of such a cable, we can reach with such an approach accuracy of something like 0.1% of such a cable line. What is quite better, because like 5 or 6 years ago, the limit was something like 1% of such a cable line. A second approach to further improve it is a two-side measurement. That means in this case we have measuring equipment on both sides or both ends of the cable line. Yeah, what you see here is the installation of HFCT sensors at the beginning and the end, and high-res locator as a transient recorders. And what we are doing afterwards is analyzing the results of both measuring units alternatively also implement timestamps within GPS signal, so in order to analyze the first arrival of the traveling wave. Let's have a look on the second method, the frequency response analysis. And what you see here again, a cable line with a few hundred kilometers. Here we are a little bit limited to something at the moment to 400 kilometers, what is realistically possible to monitor with such a concept. And it's a one-side analysis. So you see on the one side of the cable line, 2 HFCTs are installed, one for injection and one for measurement. And in addition to the transient recorder, high-res locator, an injection unit will be implemented. And this injection unit injects signals with a frequency range between 5 kilohertz and 150 kilohertz as discrete signals into the cable and analyzes the reflecting signal. What can we localize out of this, or what is the output? If there's a structural change, that means impedance change, for example, a water intrusion into the cable, we can localize those impedance changes, and afterwards we can also determine what is the location and what is the amplitude of this impedance change. The second topic, or the third method, is partial discharge monitoring. And as we have heard already, partial discharges are very low energy sparks. And of course, out of that, there come some physical limits, what refers to the maximum length. In this solution, what I would like to propose to you here today is a limit of the cable line what was reached until now of around 15 kilometers between two measuring points, what is quite long already in comparison to everything what is available on the market. And how is it done, and how can we reach 15 kilometers? It depends on two main developments. The first development is a very sensitive coupling and decoupling of signals with an HFCT that is not installed around the bounding cable. It is installed around the cable, including shield, and the bounding cable is put through the HFCT again. So we are coupling directly to the conductor of the cable. And secondly, the second main development is how to handle disturbances from outside. And for that, algorithms were developed for the last 8 years now, together with university that was focusing not on the electrical engineering, it was focusing on the speech technology. Yeah, what we all know from our microphones, it's the same. There are methods available, mathematical methods to filter disturbances and to find small signals even in a disturbed surrounding. But maybe it's enough for the detail for now. But just to understand why this is possible. And now PD means what we are doing is we are injecting signals into the cable line and making a cable characterization, and this every hour. Why every hour? Because cable characteristics like the damping behavior and also the propagation speed of signals change, for example, with the temperature of a cable. Therefore, we have to do it continuously in order to always have a mathematical model of such a 15-kilometer long cable. And not as an average, it's an adaptive model that calculates the different characteristic for each part within the cable. That means each cable joint, each cable section, and so we can, out of that, understand this mathematical behavior. And the second step is, when we have this characterization, we are measuring partial discharges. And the partial discharges are measured on the left and the right side of the cable line. And with this mathematical model that we made before, we can now calculate where is the location of a fault and what is the amplitude. Yeah, we can create each partial discharge at the place of the origin of this partial discharge. This needs a lot of compute power, and this was therefore also like a project was not done like 30 years ago, but it's the next level of partial discharge measurement, analyzing each single partial discharge, and afterwards, of course, clustering them and filtering and bringing together, of course, showing also only the important methods. How does it look? Maybe to get an impression. Because it makes things a little bit easier, even for operators who are not an expert for partial discharge measurement. What you see here, like a 15-kilometer long cable with 2 defects, one within the cable and one in one of the cable joints, between joint 7 and 8 and directly in joint 9. And what we can see afterwards is on the left side a diagram with the cable distance and the amplitude of the partial discharges, and we can just show where is a problem within the cable, and afterwards, of course, it's even possible to have a look into the into each of the signals, make analysis of the sources. And a second point is, you see on the green line, we can of course also see the trends over a certain time with the partial discharges to see how a failure developed over time. User interface, of course, everything has to be shown into a certain software solution, but it's very similar. You see a partial discharge within the cable line. Yeah, you see the complete cable and the zoom in area, and afterwards you see how the failure developed and where was a fault localization. Such a user interface and also expert system also allows the implementation of further measuring methods. Yeah? It's not limited only for partial discharge. What you see here, for example, is already the implementation of fault localization, and further methods can be implemented as well. Yeah, very quickly, to show what over the lifetime, the different stages of a lifetime of such a cable, where should such methods or could such electrical methods be implemented? It's not only about the operation, it already starts, what you see here, during the quality control in the production. That means during factory process, first measurements of partial discharges, but also of the cable characteristics can be done as a fingerprint. Afterwards, the same methods can be used during project realization, for example, for detecting faults during the after installation test, but even during the installation, before applying a high voltage, it can be used. Then the event-based maintenance in the operation phase, of course, for fault localization. The condition assessment, of course, to understand predictive maintenance during the operation phase, but not only as a continuous real-time measurement, it also allows an interval measurement, that means spot measurements, what could reduce the investment costs dramatically and brings the same output. Yeah, and now we come a little bit in the direction of digital twin. The risk-based maintenance, if we implement certain measuring systems, of course, it is the idea and also the goal of, I would say, of our industry to bring together a risk-based idea of the condition of a cable. I'll show you on my last slide some aspects about it. How is a typical project integration, or how is the integration into such a subsea cable system? What you see here, the fault localization or transient fault recording is just installed into the cable stations. That means we can have cover distances of several hundred up to thousands of kilometers. The frequency analysis is also just installed into the cable stations together with the HFCT sensor, and PD measurements has to be installed every 15 kilometers, normally in earthing boxes, where you have access to that. Or when we think about inter-array cable, it is installed at the offshore substation and the last wind turbine if it is covered with 15 kilometers. I would like to show you 2 example installations so that you get an idea how such an installation could look. Yeah, the first is a 24/7 operation system for a 130 kilometer long offshore converter interconnection export cable to an wind farm, 320 kV DC, and it looks like this. On the offshore station, it's a 2-side measurement of the fault localization system. Of the offshore station, we have the cable and the installation of the HFCT sensor. And here you see how the HFCT sensor is installed around the whole cable to make a very sensitive measurement. And at the onshore station, we have an additional HFCT, and of course we need some switch cubicle for the electronics. In this case, it was decided to have an additional cubicle outdoor. A second measurement for an AC system, yeah, what you see here the three phases together with an with the Heimon Blue for measurement of the partial discharges. And with the benefit is for the complete cable with a cable length of 10.7 kilometers, it is sufficient to have just 2 measuring points. That means at the beginning substation and at the ending of this cable substation. And this allows the partial discharge measurement. And for demonstration purposes, we also installed one fault location system at one phase. To finalize my discussion, and it's also maybe something to generate some discussion on this, is how to make a risk-based maintenance. And this, from my perspective, can only be a joint path. It's not something what only one company can do, and we are starting a lot of cooperation on this topic. What does it mean? Yeah, when we talk about digital twin, it's also such a buzzword. But what do we understand on this? Digital twin means, from our perspective, to integrate the measuring data from different measuring systems. Yeah, that means the 3 electrical measurements that are introduced, but also integrate measuring results from additional systems like DAS, DTS, what we have heard today, maybe additional PD monitoring of cable terminations, but also current voltage data from the operator, cable data from the manufacturer, and also converter data is also an influence. Bringing it together using statistics, algorithms, and the experts with the idea to bring an result, such a risk analysis for such a complete cable line. And from my perspective, this is my conclusion for today, and maybe also the outlook where we would like to, or where we should go from our perspective, and what is the future of our cable systems to increase the availability of cable systems. Thank you very much for your attention.
Thank you. So, do we have questions? No? We must have a, there we go.
Dan, you mentioned the accuracy for the single-ended TDR type measurement. Is the accuracy different for the double-ended?
Yeah, absolutely. We can improve the double-ended accuracy something like it depends, of course, on the cable design, but we can be a little bit better with a double-ended measurement. So that means, I cannot give you a complete number, yeah, but something like 0.1% would be like the end result if you have the best conditions, yeah, so to say.
Okay, if we have one more question, yeah, then let's have one more.
Hi, thank you. I would like to know if you would be able to comment on the potential to integrate such cable monitoring systems also during cable commissioning, meaning site acceptance tests, for example.
It is. Maybe I have to add. Highvolt is a manufacturer of high voltage test equipment. That means equipment for example, testing of inter-array cables with a resonant test after installation, or testing of land cables with a test truck. And of course, for those measurements, we also implemented, for example, partial discharge measurement to reduce the effort for installation of different measuring points. So we just have it. Yeah, every 10 kilometers, 15 kilometers, depending on the cable structure, one sensor. So that means PD, coming to your question, partial discharge is definitely one part of commissioning tests normally, or very often requested, so to say. And what we also implemented was a fault localization. Yeah? If PD was not required, we already had several tests where we just implemented a system for localization of the fault if a breakdown occurred. Nowadays, together with some of our partners of the cable supplier, cable manufacturers, we come to even more requirements. For example, sabotage detection of a cable line before it is energized. So to say, okay, let's have, for example, this resonant FAA, frequent resonance analyzers, to implement it at the cable before it is energized, so they can see if somebody is doing at the cable some sabotage that is not required in this. Does it answer your question? Okay.
Perfect. But then, thank you very much.
Welcome.
Yep. And we will move on to our next presenter, and that is Dan Dansken, Commercial Manager at Alcatel Submarine Networks.
Hello, and thank you for staying. Even one of my own colleagues has disappeared, so if you're watching this back, don't feel too guilty. I shall try and keep things brief. I've got mostly pictures because I know most people are falling asleep by now, so we'll go with pictures only and try and keep things to as few words as possible. So apologies if I'm going to trigger anyone. I've put the intro to the intro to ASN near the end. There's a reason for that. So I'm not going to start as we normally do with company and everything else. I'm going to tell you a bit about DAS and how we use it, a little bit about us because it's pertinent to the next few slides, which is, I want to tell you a little bit about a case study using what we call an eye loop, and I'll come to that in a bit. So DAS, Etienne did a great introduction on DAS. It's basically measuring changes within the fiber optic. That fiber optic would be embedded in a power cable, and we're looking for microscopic stretches in the cable. We're looking at effectively picostrains. So anything moves in or around the cable, it will affect the cable, and then it will affect the fiber, and we actually pick that up. And we can then resolve various frequencies within that. So depending on how far we're measuring, gives us the ability to measure from near DC frequencies all the way up to, well, kilohertz, but in power cables, traditionally, we're about 500, 600 hertz. Effectively turning the fiber that is within the power cable into a microphone every meter. And then we just listen for whatever it is we want to actually hear. ASN does this in a very different way to everyone else. As far as I'm aware, we're the only people doing this thing called frequency-swept DAS, which is where, rather than just putting little pulses of light into the fiber, we actually put big sweeps of light into the fiber, thousands of times more light into the fiber, and then we can obviously measure longer and longer distances. So we have a system that straight out of the box will do 150-kilometer measurement. Again, it's still able to give you a measurement every few meters, so every 2 meters, maybe even every 1 meter. In fact, some people are using it to look at about 1.2 meter intervals. We're also able to resolve different wavelengths of sound and different speeds of the energy that's actually impacting the cable, and I'll come on to why that's important later. So there it is. I'm not going to dwell on that. So as I said, standard DAS is, for us, does around about 150 kilometers, but that's not far enough. We want to go further. So we add on what we call a pump box, basically just using a science called Raman amplification. All that does is inject a high-power laser into the same fiber. This is all in the transformer station, so it's all dry plant, and it then boosts the range that we get of that system up to, well, we're now over 200 kilometers of usable range without doing anything to the fiber. So this could be retrofit to any system. But very importantly, we've put an interlock on that because you really don't want to be having any damage to that fiber. It is quite a high power laser, so you need protection. So ASN's been working very hard on the same protection that we use for our telecoms networks. We use it for our DAS network as well now. But we're not finished. What if we add and take standard telecoms remote optically pumped amplifiers, and we add that onto the cable? So this is a small box. Now we're getting wet and we're going to the cable, but it's a small joint box, can be integrated into a cable joint. No electronics still, and that further boosts the signal. What it does is actually take some of the leftover energy of the of the pump, and then uses that to boost the DAS signal. So now we're up to 254 kilometers of usable range for our signal. Still not enough. 320 is where we're at the minute, and this is without adding any electronics subsea. And to do this, we add enhanced backscatter fiber. So this is different fiber subsea. So we need to modify the subsea fiber in some way, or on new projects, we just add this in. Somebody asked earlier about changing the fiber, doing low loss fiber. Well, actually, it works conversely. High loss fiber is actually better, you get more reflection. This enhanced backscatter fiber is actually a fiber that is inscribed with almost effectively mirrors every 10 meters. But these mirrors they don't add to the loss of the fiber, they just reflect a tiny little bit of light back. So this is high loss, but in a tiny little area of the fiber, and then 10 meters later, high loss and 10 meters of the fiber. It gives us that extended range to go up to around about 320 kilometers now. But we're not finished. Cables are getting longer. There's some people in the room that are working on cables that are thousands of kilometers long, and you still need to protect these cables. You still need to get accurate information on where there's a fault or an issue with the cable. So we have, again, taken Alcatel's repeater technology now, and we've put that into repeated DAS. So this is getting all the benefits of a DAS system, but extending it using standard telecoms repeaters and going out to, well, at the minute it's working at 2,227 kilometers, single-ended. So that's 4,500, should be enough, but we're actually working on a new test bed, which is 3,000 kilometers single-ended. So that'll get us across the Atlantic, and we'll keep going. The telecoms test bed that we have is 11,000 kilometers. So we're not going to finish until we get right the way around the world with DAS. And it works. We've got test data on it, and I don't know whether the audio works. If it doesn't, then... So that's the guys listening to Mario Kart playing on a speaker almost 2,500 miles away, kilometers away. That's like in Moscow, putting a little speaker and listening all optically to that just here in the UK. That's quite a distance. Yeah, they chose Mario Kart. Sorry for that. So there's a summary for those of you who like to take pictures of slides. All of those ranges that we do and the capabilities. The main reason for highlighting all of this is to show that you shouldn't really limit putting fiber monitoring or even fiber onto your cables just because technology hasn't got there yet. We know some cables only have fiber 60 kilometers offshore and then they leave the other 400 kilometers without any kind of monitoring. Why? It just doesn't make sense to me. Put the fiber the whole way and then technology will catch up and will enable the capability at a later date. But don't stop the fiber part way. That's just silly. So what do we do with that? Some applications. We've got quite a capable software suite. It's not perfect, but we also have partners that use our data. One particular thing is looking at cables that are not buried, so exposed cables and the tidal forces on those. These cables can bounce around on the seabed, so we have some cables that we monitor that actually skip along the seabed and then skip back depending on which way the tide's going. It's a tidal generator up in the north of Scotland. And interestingly, the cable wins, the seabed loses. So over 10 years, the seabed has become nicely polished, and the cable is still going backwards and forwards over these areas. And we're able to look at what kind of frequencies are in that to see, is it just the sheathing that's going over that rock, or have we got the steel that's now rubbing on the rock? Different sounds travel at different speeds, so we can see that it's only the sheathing. It's still not got through to the metal. But if it moves too much and it's bouncing around too much, they just put a bag of rocks on it and stop it moving. We're also looking at things like vortex-induced vibration on that cable and others. Again, if it's moving too much and it's going to fail at some point, you need to do something about it, but we'll tell you long before it actually happens. I'm not going to go over other uses. Locating breakdowns is one very important topic for DAS, and as Etienne said before, to within 10 meters. In fact, a long time ago, working for a different company, I managed to get to within 0.8 of a meter, locating a breakdown 43 kilometers offshore. So very, very capable technology to locate faults. And that was actually turning up after the fault and plugging in a DAS system and measuring. And that we have a partnership with a company called Marlinks that use our data into their software. And then we can look at predicting faults. There's a company called Indeximate who take long-term DAS data, and they will interpolate that and look at the vibrations on that cable and the structure of the cable to say, your cable's either healthy and it can withstand this for many, many years, or it's not, and give you a prediction of the life expectancy of that cable given the movement that's been made. And then the one that is close to ASN's heart, because we look after a lot of cables, telecom cables, is looking for seabed threats. That could be sabotage, although I'm still skeptical as to whether any of the cable incidents have been sabotage or just incompetence. But even then, incompetence, sabotage, doesn't matter, broken cable. What we're trying to do, and now have the software to automatically detect any seabed or anything being dragged along the seabed within 3 kilometers of the cable. So at about 8 knots, that's what, 15 minutes, 13 minutes of early warning that that vessel is going to impact that cable if it keeps going. If it's a fishing vessel, you're probably not going to do anything about it because, to be quite honest, they're not going to do anything about it even if you contact them. But if it is a very large vessel dragging an anchor, you're now able to contact that vessel. We marry this up with AIS data, and you can contact that vessel to say, look, do something about it. At least try and turn, cut your engines, whatever else. You're removing all the ambiguity. If they keep going at full steam, dragging that anchor for 15 more minutes, it's a deliberate act. So you've removed the gray zone now. There's no more gray area attacks on cables and infrastructure subsea, because you can tell these people long before they get to the cable. It may be that it's just a mistake. They can't bring the anchor up in time for that cable, but as we've seen, it's not just one cable that gets hit. It's 4 cables and a gas pipeline. Well, if you had DAS on those telecom cables, we'd protect all the other cables afterwards. That's only 1 break rather than 4 and a very expensive power cable as well. So just a note on what that is. It's about an hour's worth of data being played back quite quickly over and over. The red traces are things on the seabed. That's about 70 kilometers of cable we're monitoring there. And we're looking at detecting things around about in a 3-kilometer avenue corridor around the cable. It doesn't have left or right detection, so we have an ambiguity of whether the thing is approaching from the left or the right. We take that out usually with AIS, or we're now looking at taking it out with the bends that are in the cable. We can then detect the left or right.
Dan?
Yeah.
The microphone is not as good as your DAS system,
So it doesn't hear as well. So yes, you can see at the top there, the top left-hand corner, top left-hand corner, there's actually 2 vessels up there. If you look closely, there's one vessel starts dragging a net along the seabed, and then another vessel approaches soon after, and then right towards the end of the recording, they actually both turn the AIS system on, so the black dots appear, and then they disappear off together because they almost get tangled up. 2 vessels dark fishing at the same place at the same time. And then the guy down at the bottom of that cable going backwards and forwards, he's dragging nets across the cable several times over about 7 kilometers of cable, just fishing, I guess. But we're highlighting this. That cable was hit every 6 months or so until the company that run it and operate it started to liaise with the fishing fleet to say, look, we're watching. We know what you're doing. change the way you're doing this. So just lift before and after. You know, we're not going to enforce a 500-meter zone around the cable. We just can't do that. But just don't drag your nets right the way across the cable. We can see it. And now we actually see the cables, the nets lift even 20 meters before the cable and then down afterwards. They're not even bringing them up to the surface. They're just putting a bit of extra tension on the cable and then back down. And that cable, unfortunately, it's only just been hit, but that's the first one in 2.5 years. So they've taken a cable impact every 6 months to a cable impact every 2.5 years. Not just because of DAS. They put a lot of effort into that. So that's not just me. They've actually used this data to liaise with the fishing fleet to say, please don't do this anymore. So a bit about ASN, because it's pertinent to the next few slides. ASN's a telecom operator, cable installer. We install around 50,000 kilometers of cable every year, and we operate our own vessels, several of our own vessels. And what we've used is this knowledge of telecoms technology to develop an iLoop. An iLoop is a way of adding telecom repeaters and ropers or whatever you want to do onto an HVDC cable, but still maintain the features that you would like to maintain. You want monitoring all the way. You want to be able to repair these electronics that are on the seabed. Lots of different things you want to do. We can now do that with an iLoop. So what is it? The idea is that at certain locations along the power cable, we will add on this loop, which is a single tail that comes off the cable with 2 fibers in it, or 2 cables bundled together in it. And then we come along later, and ASN will put the repeaters on the cable, or the roper on the cable. That means that your power cable vessel is not dealing with repeaters, because they need to be handled in a different way, and you don't want to slow down to do repeater splicing and everything else. This is an expensive vessel, so let us do that bit, because that's what we're very good at. The power cable vessel does all the bundling and keeps everything together. So ASN will come along later, pick that up, and do the splicing. So I promised pictures, so we've got little pictures. Power cable vessel. There's the bundle, so that's 2 HVDC poles and fiber inside, and you can see it going through the bundling machine as it goes off the side. The idea is to show that we're actually doing this now. It's not a theory or whatever else. It's something we've been doing recently. When it comes to an iLoop, the vessel will then lay the iLoop down on the seabed next to the power cable. And that's as much as the power cable vessel, the cable lay vessel, actually does with the iLoop. It just lays it down there on the seabed. So you end up with one of these iLoops every 60 to 80 kilometers, depending on how far apart the specification is for what you need to do. And then we come along later with the ASN vessel, and we just pick that up. We take the ROV, pick up the cable, and splice on the repeater or the roper, whatever it is, and then very simply lay it back down and ROV jet it back in. This is all standard telecoms technology and standard telecoms capability to actually put this back in. The great thing is we can do that within the corridor of your survey, so we're not laying it 50 to 100 meters off to the side. We're laying it to within about 20 meters off to the side. So that means your surveys get quite small. You don't need to extend them wherever we have iLoops. And it's all finally buried. The other thing is we can delink these two things, so the power cable vessel doesn't have to be followed on by the telecoms vessel. We can do that as a vessel opportunity when we're moving backwards and forwards. Maybe we're going to do another repair on a telecoms cable, and then on the way back past, we'll do 2 or 3 more repeaters because the power cable vessels put the iLoops in. We'll do those. It saves mobilization and demob costs. So it enables a much more efficient way of getting the cable on the power cable, but also being able to do good monitoring all the way. So summary, perfect, 1 minute. We can actually protect cables. it's not just detecting problems. We're actually able to, and we've proven, and we have clients that are using the data from our systems to stop vessels hitting cables. And if you use this data proactively, it does work. And we can do this on any cable at all. So that's what I want to take away. Please, if you are planning a power cable, just plan to put the fiber on, at the very least. Thank you.
Thank you, Dan. So, do we have a question? Let's go there.
Thank you. Me again. So I would be interested in how the DIS is able to distinguish between the various modes you may see in not or potential defects, like you mentioned VIVs, sidewall pressure, tension, torsional forces, etc.
So some of them you can differentiate, some of them you can't. So motions like VIV would be at a specific frequency that's dependent on the flow rates and the size of the cable. So on a telecoms cable, that'll be around about 4 or 5 hertz. Slightly larger cable would be slightly higher frequencies, but not by much. Torsion and tension is a little bit more of a challenge. You actually see change with the DAS, as Etienne mentioned before, so DAS is a change engine. So you'd have to be measuring while you're busy laying the cable, and you wouldn't know whether that's torsion or tension, you just know it's strain. So something happened in that point. The nice thing about doing it with DAS is it does a measurement thousands of times a second. So it's fully live, as opposed to having a measurement every few minutes, which what happened, I'm not just going to move every few minutes with a cable lay vessel. I want it fully live and to see what's going on all the time. So use it for what it's good at. And that's things that are live and happening right now. That answer the question?
Okay. If I may pick up on that, because you said now that this is live, but I noticed you skimmed over it a little bit, but the frequency which you're measuring for the very long distance cables was only 500 hertz.
That's correct.
Right? Often in DAS we see 20 kilohertz quoted. So a question I have for those very long distances, which by the way is amazing, because you also glossed over that, but you said it's like listening to music from Moscow, but it's like listening to music from Moscow and every single point along the way, every 2 meters. It's 1 million microphones.
It is, yes.
So I'll complain about the quality of the sound. It's frequency truncated. Is there a way to get that up again? Is it?
The frequency is truncated, so even going 4,000 kilometers, we'd still be looking at around about 600 hertz frequencies that we can hear. Frequencies above that don't really travel very far underwater. So the frequencies that you do find much higher frequencies underwater, they travel short distances. They're used by cetacean mammals for hunting, but they're very short distances. So 600 hertz, most of the things we're looking for are at 600 hertz. The things we don't want to look for, sometimes a little bit higher. I'll leave that there.
You don't want to listen to the guy in the other substation complaining about your system. Or?
No, I think you don't want to listen to sonar pings and things like that.
Okay.
Active sonars at 9 kilohertz or something. We really don't want to be picking that up. So, yeah, we want to stick low frequencies.
Good. Do we have one more? Yes, please.
Hi, Annika Kleiner, Baltic Cable. So you say here that this can be used for any cable, but you also said consider this when you plan for new cables. Does that mean that it's only for new cables and that you cannot apply the system for already existing?
No, if your cable has fiber on it already, then it's relatively cheap and easy to install. If your cable doesn't, so those cables that didn't plan for it, it's much more expensive to retrofit. Because obviously we need to get out there and put the fiber cable in or near the power cable. Which we can do. We have the fleet of vessels to do it, but that's expensive. If you'd planned for it, it would be free. So that's why I say plan for it. It's not just a new thing, but the planning saves a ton of money.
Perfect. But then, thank you very much. And we are on to our next presenter, and that's Brendan Hyland, founder and CEO of Ocean Information Services. There is Brendan.
Right, good afternoon. I think I am the last slot. Volume okay? Yes. So I'm, I say, Brendan Hyland. I'm the CEO of a company called Ocean Information Services. I'm here really to present a JIP, a joint industry project that we've been running for a few years, jointly with a number of companies, some of whom are here and some of whom are not. We've been running a JIP to build experience of deploying underwater IoT devices, Internet of Things devices, to deliver autonomous operations. And the particular JIP I'd like to walk through is called ASEC, Autonomous Surveillance of Subsea Electrical Cables. And we're using just a different technique for monitoring cables. Neither better nor worse than other ones that have been discussed, just a different approach to picking up information. So over the next 20 odd minutes, I'd like to take you through really the background to the project that we're working on, progress to date on ASIC JIP. It's not completed yet. It's focused on monitoring cables on fixed bottom offshore wind farm. Like talk through where we're moving to the next stage to monitor cables on floating structures, looking at cables not just on floating offshore wind, but also on FPSOs in the oil industry. There's probably very little I can say about the problems with cables that haven't been said half a dozen times already over the last 2 days. We all know there are issues with cables. Where we come from in this perspective is we're not cable experts per se. What we're setting out to do is to use a technique to collect large amounts of data over very long periods of time to allow people with expertise in cables to try to understand what's going wrong and to derive better ways of improving the design, deployment, management, maintenance of cables. The program we're running is a multi-phase program. It's been going for about 3 years already. And we're in phase 3 of this program where we're deploying systems on a fixed bottom offshore wind farm. The particular wind farm we're deploying on is called Lynn and Innerdousing. It's a relatively old wind farm based just off Grimsby in the southern part of the UK, vintage 2009. And the particular wind farm suffers from scour. It's in very shallow water, around about 10 metres of water. And quite a number of the turbines have suffered from scour. And within the project, we're setting out to monitor cables which are subject to free span within that field. High-level view, autonomous operations. What we're setting out to do in the long run is to automate the collection of data in the underwater domain, basically replicating what's readily available above water today and has been available for a long time above water using Wi-Fi or Bluetooth or other wireless devices attached to sensors to collect large amount of data. Hitherto, that's really been very, very expensive, if not impractical in an underwater environment. But there have been a number of technology changes in parallel that have enabled the deployment of IoT systems in an underwater environment. One is advances in communication technology. We happen, for the most part, to use magnetic communication technology, which communicates through water and through the water-air boundary. So we can put gateways above water and communicate with sensors at the seabed. For very deep water applications, we also integrate with acoustic systems. But there have also been significant advances over the last 5 to 10 years on edge processing. So the tiny little processors in smartwatches, etc., are extraordinarily powerful. And we use these very powerful but very energy efficient processors to run significant amount of edge processing and machine learning right at the edge that then allows us to collapse the amount of data that's collected from sensors and wirelessly only transfer information, the answers. So instead of taking that data and post-processing on the desktop, we process it at the seabed and only wirelessly communicate the answers. And we communicate by exception. We only communicate when there's something worthwhile communicating, not needlessly transmitting data from point to point. There have also been significant advances in autonomous vehicles, ROVs, AUVs, USVs, UAVs, lots of Vs, but these vehicles have collapsed in price. I mean, I'll give you an example. About 15 years ago, we ran a proof of concept project at a NATO event in Kiel, where we got a UAV helicopter to command and control an AUV underwater using an early version of the magnetic technology. And in those days, the UAV helicopter cost about £300,000 and the AUV about £2 million. Today's equipment is 2 orders of magnitude cheaper. It's really collapsed in cost over the period. As an example of some of the equipment that we're deploying outside of the wind industry, is this a pointer? No. In the bottom right-hand corner slide, there's a white long device which we've designed and delivered into the oil industry for very long-term monitoring of the movement of pipes at the seabed. No different from monitoring electrical cables at the seabed, but this we've configured for monitoring pipes, a phenomenon that's called pipe walking. And that particular system was deployed earlier this year for Total Energies out in Angola. And it has a 15-year battery life. It will provide continuous monitoring of the pipe over a 15-year period, and its underlying purpose is to calibrate a predictive model around the fatigue of that pipeline. It's very much identical to the sort of applications that we need in this industry. And in fact, that particular unit we're upgrading, so the next version has a 30-year battery life. So it really operates for the operating life of the asset. So the project we're working on at the minute, linen inner dowsing, the diagram on the right is a J-tube with a bell mouth and a cable coming out of it. And when the project was originally deployed, the bell mouth was sitting on the seabed, but it's now about 1.5 meters off the seabed due to scar. And the cable, which is a Nexans cable, OD around about 110 millimeters, it has a free span of around about 3-4 meters through seawater before touchdown. And the water currents in this area are pretty active. And there's a concern on part of the operator. What's the level of, is there VIV in the area? If that VIV on the cable, if there is, will that VIV adversely impact the fatigue life of the cable? It's in very shallow water, around about 7-8 meters of water, so there's a potential for wave action as well on the device. And the honest answer is no one really knows what's happening to the device. There's been no monitoring on it. So we've set out in this JIP to answer a number of questions around monitoring. Could we find a way to use relatively modestly sized and low-cost ROVs with CTV to deploy retrofit sensors onto cables that are deemed at risk? And one of the interesting points that came up during the project pretty early on is it turns out, to the best of our understanding, and someone in the room may correct me on this, but to the best of our understanding, no one's deployed sensors onto live cables before. And that was quite a new area, because traditionally, attachment of sensors to cables or similar systems would be done with divers in the water rather than ROV. So we've had to do it with ROV in the first instance. The operators of this particular field are Siemens Gamgee and Ixico. They operate for the owner, which is Macquarie. The IoT platform we're using, its marketing name is Lattice. It uses a magnetic communication technology, and as indicated, it will communicate through the water-air boundary. So top right picture is a gateway device installed on a wind turbine at Lindner Dowsing. It's about 10 meters above water, and it communicates with, it's designed to communicate with the device on a J-tube, roughly 8-9 meters underwater. We have also got pictures of 2 other devices that we've built and deployed for trials purposes. One's a biodiversity monitoring system that measures the acoustic noise of cetaceans, so at the frequencies that our friends at Alcatel don't measure, that's configured to monitor around about 120 to 150 kilohertz. Long-term monitoring of cetaceans is an important issue in the wind industry. And the item on the right, Lattice EMS, is a device configured to monitor water quality, pH, conductivity, temperature. It can also be configured to monitor pressure as in water depth and temperature. On the top left, we have a UAV with one of our devices on board, and we've used that to harvest information from these BMS and EMS devices at the seabed, so just straight through the water-air boundary. So the fatigue monitoring system we've designed, built, and tested for this program in these photographs. So to the right, we have the fatigue monitoring system attached to a very small ROV. It's a small Oceanus ROV. The plastic curved element that you can see with a sort of yellow band across it has been designed and shaped to fit onto a J-tube, and it has a number of magnets, so it's magnetically attached. And then the yellow tube on the left it's actually a metal tube, but it's a simulation of an electrical cable. It's of the same dimension, about 110 millimeters, and we attach a spring-loaded connector onto the top of that. And top right-hand corner is all the various components that are deployed in this program. There are 2 accelerometers in the system. One of the accelerometer is on the device attached to the yellow tube, and the other accelerometer is integrated with the device that's attached to the bell mouth of the J-tube. And we compare the data from both. The particular units that have been designed with a 2-year battery life, that's all that was deemed required, but we can supply systems with a much longer battery life when it's deployed commercially in due course. Now, this is video footage of a test tank where you've got a picture from the ROV as it moves to the sample pipe, which is the equivalent to a cable, to deploy the clamp onto the pipe. And the clamping mechanism is designed to attach with a relatively small load. It's about 3-4 kilograms of load, and to pull off with a similar load. We've come up with some quite simple automation on this system. We actually use solenoid-enabled magnets to allow us to detach and attach our units. That allows us to use very, very modestly sized ROVs as opposed to work class. The photograph on the right is a brush, an ROV brush, simply for cleaning the cable in the J-tube when we go down, give you an idea of what we use. These are the same units, just in sort of diagrammatic form. The clamping unit is 3D printed with the spring. Very simple. We can make them pretty much of any size with relatively 3D printers are fabulous nowadays. And below is the unit with one of the bottles contains the various electronics and accelerometers, and the other bottle contains batteries. So one of the partners in the project, Total Energies, asked if at the same time as deploying, we could deploy an E-field monitoring skid to provide non-contact measurement of corrosion on the subsea structure. They free issued us a number of E-field sensors, you can see there on the right. We built these into a skid, you can see the top left. And we've run a whole bunch of trials on the system to verify the performance of the underlying device. Non-contact E-field measurement is a great way of going around a wind farm looking for gaps in the corrosion protection of a system. And when gaps or perturbations are identified in the corrosion system, it then allows you to go back later on to intervene and improve either the ICCP system or CP as appropriate. Third element of the project, building and deploying biodiversity monitoring and environmental monitoring systems. We'd originally intend deploying these at Lynn Inner Dowsing, but we couldn't secure the licensing for that, so we deployed these at a different location, a place called St Abbs in Scotland. And the photograph is a day when we deployed those and used the UAV to confirm the location and harvest information from them. And these are intended for very long-term deployments. So we've run a whole bunch of tests in test tanks and harbours and in seawater of the systems at various points over the last 12, 18 months. So the ROV, we rented from a company in Aberdeen, used their test tank to run a bunch of tests, one of which was the video we showed earlier. There's a research centre at St Abbs in Scotland, which has a great test tank, seawater test tank, and we deployed equipment in there for various trials. We ran a public demonstration day in Plymouth in May deploying various equipment off Harbour Wall, and then moved to Grimsby, which is the nearest port to Linen Introducing, and ran trials first in August, and then we attempted a deployment in October. So in August, when we went along to deploy, our modus operandi was to hand carry the ROV off the side of the vessel and lower it into the water. But as we were going through that process, we realized actually because of the angles and the size of the ROV, it really needed to be lowered by crane into the water rather than by hand. So we pulled back from those trials in August. We had to sort out David. We sorted out a cage for the ROV, craning mechanism, sorted out the certification of the system, and went back in October, which was the earliest date that we could get an operational slot to go and deploy. So these two photographs are the same thing, believe it or not. The one on the top is the cable that we plan to deploy our system on, and the photograph below is the same on the day that we tried to deploy. The day we tried to deploy was about a week after a large storm, and turbidity was really not very pleasant. That's the practicalities of doing deployments on the day. We had very unusual weather patterns on the day, and we had intended to deploy, or we designed a system to deploy at slack tide. We got about an hour's window. We put the ROV into the water to operate with low tides. But what we didn't recognize, despite the weather being reasonable, when we put our ROV in the water, we found out there was no slack tide in the day because of some curious weather patterns, and indeed, we were subject to a tide of somewhere between a continuous motion of about between half a metre and a metre per second. And we have a couple of little video clips of what went on. So this is an exercise on the day where they drop a little buoy into the water to measure the knots, so to speak. And it should have been dead still, but it wasn't. This was slack tide. And when we put our ROV in the water at full thrust, it basically didn't make any headway against the water. So we picked the wrong day for that.
About it.
And let's see if we show you this. Second one, this is the turbine that we're matching up against. As you can see, the weather on the day actually looked pretty reasonable. The wave heights were not in any way unacceptable. And there was no obvious reason to believe we wouldn't be able to deploy successfully. But what we learned was, although we picked up quite a lot of information from a Met-Ocean buoy run by Linen Introducing in the area, the particular turbines subject to scour have a significant amount of extra local current, and that's what is giving the scour. So the practical issues of deploying. So where have we got to date? What have we succeeded at? What have we haven't? Well, we've designed, built, and tested a number of devices that are suitable for attaching to subsea electrical cables and can be retrofitted onto live cables. And that's quite a significant step in its own right, being able to retrofit onto any cable operating in the field. The systems we've designed incorporate edge processing that allows us to run an analysis for VIV and wave action, so we can help to determine in due course whether those phenomena are present. We've developed and tested in a non-ocean environment a CP monitoring skid that we believe will be a CPE field monitoring skid that we will believe will be fit for purpose. But we've learned that the oceans aren't all what they seem, as many people in this room will probably know. Just because it looks okay above water doesn't necessarily mean it will be below water. And the key lesson for us is we need a more powerful ROV for the next time we deploy. So we plan to go back out in spring, next deployment. Hopefully, this time round, we will have a powerful enough ROV to deploy on the day. And then we move on. We've started to move on to the next project, which is the more challenging project of how do we deploy devices to monitor floating structures, whether it's floating oil and gas or floating wind structures, either. Because in the wind industry, the fatigue of dynamic cable is really quite a challenging area and adds material risk to project. So the follow-on JIP is called AMBES, A-M-B-E-S. And we plan to deploy monitoring devices on I'm about to run out of time, but we're about to deploy monitoring devices on dynamic cable, on mooring line, on fatigue on the structure, corrosion on the structure, and feed this information into digital twin. And our objective is to extend digital twin seamlessly through the water-air boundary to have live information calibrating and correcting. And whether you're in the wind industry or in the oil industry, that's super important to improve and optimize O&M activities, but more particularly in the oil industry, to identify rogue events, what I call the black swan events that could give rise to emission. We've reached agreement with Kincardine Offshore Wind Farm to use Kincardine as a pilot site, and we plan to deploy a pilot in first half of 27. We've run some sums to try and determine what size and shape of ROV we're going to need to deploy. These are our best guess. We basically need a lot more thrust, but roughly a similar size. And we're also planning to move away from an electrical umbilical to an optical umbilical, because the umbilical it has a significant impact on the usability of the ROV underwater. We plan to use a USV for deploying, managing and maintaining the ROV and Kincardine. What's the impact of this? Well, fundamentally what we're setting out to do is to make it easier for operators, both in the wind and the oil industry, to collect much larger quantities of data over very long periods of time to help them to optimize their O&M and to help them to design and build digital twins that absolutely reflect the operations they're working with. And we see the future of operations in the offshore industries using autonomous vehicles. For the most part, USV, uncrewed surface vehicle with ROV, to deploy, manage, maintain, carry out inspections. So in summary, the ASIC JIP has progressed. It's not completed. We'd hoped it would be completed, but it's not completed. We've got to go back next spring and finish it off. And we are starting to gear up to deploy, design, develop and deploy systems in a floating offshore wind farm. Thank you very much for your time. Appreciate that.
So, do we have a question? Yes.
What you are showing, presumably, is a tool for risk mitigation that will help plan a program if a problem is identified with the cable, with the structure, and with the scarring. Rather than sending out conventional systems the way we normally do it, what you're saying is you'll be able to predict the movement, which could lead to a situation where remedial action has to be put into place. Is that what you're actually suggesting with this?
Yes, although what we're using here is designed for retrofit. In practice, our real objective is to deploy these systems on new fields and attach to cables or CPS systems or bend stiffeners as appropriate to identify right from day one of the project what is the fatigue, what is the movement that these devices are exposed to. Yeah. Collect the data.
We have one last question there, and we'll move on.
Thanks. I think we're already stretching time, but maybe there's still some time left for some questions. I think the general project scope is a great way of showing what is needed as a industry-wide effort or joint effort to shift from a black box model, so to say, to at least a gray box model of the cables. Because personally, I try to avoid the digital twin or white box term, because we are far from that. But how do you, maybe you can elaborate on the scalability of such systems?
Our objective is to deploy sensors to monitor fatigue of structures, corrosion on structures, fatigue on cables, and met-ocean information across every device, not just 10% of offshore wind turbines. And in fact, we work with a number of tier one engineering firms and put forward proposals of that ilk into the industry. Our view is get the price down enough and monitor everything, and it will have a substantial impact on the profitability of offshore wind farms.
Good. Perfect. But then, thank you very much for your presentation. And we will be moving on to the final major point on the agenda, and that's going to be the final panel discussion. This time, the moderator will be René, so I'll take his spot in the back, you know, yelling out, screaming my opinion.
Call out the other ones.
Yeah, good.
Somebody knew beforehand how many shares were needed, because we were supposed to be with 9, and we are left with 6. I've got one slide, but I don't have the pointer anymore, so I can't change it. Sorry. It's just that those are the panelists. Unfortunately, Sally Lockwood told you already yesterday that she was ill and she was not able to make it. Richard Booth just mailed that he was gone. And Henrik just told me, do you really need me? And I said no, to be quite honest. So can I please ask the other ones to the stage, because that's a little bit easier. So Annika, can you come please up from the Baltic Cable? No, we need that chair. We need this chair. And the others as well. Richard. Yeah, always.
Maybe if you scoot over a little bit so nobody moves on the back.
Yeah, no, I can move more or less. It's no problem at all. Let's try to be a little bit lively at the end of the second day. Everybody is tired, and you see a lot of people have disappeared already. But it's very simple. It's about security of cables. It's a hot topic, of course, during the last couple of years. It's always been a topic, but due to the geopolitical things going on in the last year, it's even become more and more a topic within military governments and in our industry, I think, as well. And it's very simple. This is a map of the southern North Sea. And you can see it, there's a lot of submarine infrastructure. Partly it's pipelines, it's cables, telecom cables, it's power cables, interconnectors as well as export cables going into offshore wind farms. And it's pretty busy, pretty busy down there. And you see it on the right hand side, it's a similar map, but then it's all lighted. And one of the things we don't want is to go black. So the light should keep on, but this map was taken out of the Seafish Kingfisher one, which is available to everyone in the world, to be quite honest, and is being used for the fishermen as well. And I just would like to ask the panelists what for you is the most important thing on security for your cable systems, or in general. Annika, you as being a cable owner for the Baltic Cable?
Yeah, I mean, in general, what do we believe is important? That nobody comes and drag an anchor intentionally or unintentionally, of course, and that there is a system in place to prevent that, definitely. And maybe not that it's on the individual cable owner to make sure that this doesn't happen, but that there is actually a great awareness and a greater responsibility to make sure that this doesn't happen.
What do you see as the biggest threat to your cable?
I think that we have statistics that approximately every 50 years something happens, and it's normally anchors if it's external faults. So the whole concept of anchor dragging, and I guess that many of you here know, that is not a new topic. That is something that has happened all along, right? So, but yeah, that is the physical threat that is the greatest. I think that what we now also see, just the other week, the Swedish TSO had a cyber attack. That in itself is also, of course, a threat that we did not necessarily see a couple of years ago.
No, I fully agree on that one. Dan, what's for you the highest security risk to subsea structures?
Well, ruling out fishing vessels, because they are, and they damage more subsea cables than anything else. But that's status quo, and the UK government recently commissioned a study on this and suggested that status quo is fine if everything keeps going as it is. The telecoms industry in particular can keep going. You know, there's no real threat. If a cable breaks, we fix it in 10 days and we carry on, and a cable breaks, you know, a couple of hundred times a year, there's cable breaks. We just keep fixing them and that's fine. The study then said if there's an action that's deliberate, then we have problems. Because if you get 20 breaks all at once, you've got bigger problems. Unfortunately, that's an act of war, and when it comes to war, we're not going to deploy vessels to go and repair cables or anything else, so forget that one. For me, it's grey zone. It's removing the difference between just a plain old accident, which is up to cable operators to mitigate against, and foreign actors that do something that they shouldn't, but we can't prove anything. So if we can remove that grey zone, it pushes that boundary a little bit further away and stops people doing things deliberately, but then getting away with it because it's, well, you didn't know, or oops, sorry.
Jack, your view on it?
Don't really have one. I think on power cables, if you look at the external factors, it's typically anchors, sometimes fishermen, but then the cable isn't buried properly. And a lot of the more modern or recently installed cables have been properly buried, so they should be protected by using the CBRA. I think, like the Dan said on the other side, if you get external acts of war, then nothing is stopping people demolishing cables. And with the best will in the world, the governments can try to do what they want, but it's virtually impossible to avoid it, I think.
That's a challenging one to ask a Swiss person on cable protection in the offshore world. I'm not sure what is the biggest risk. I understand the anchor drop, the fishing activities and these kind of things. That's very physical, but Annika mentioned cybersecurity. And I have somehow the feeling that, okay, we can protect the assets with sensing, fiber sensing for me, because that's what I do. We can try to provide good data to the community, to the end user to use this, but we have also a responsibility not to ignore the massive impact, the things like cybersecurity, the things which are in the background that we think will never happen, but actually could be more damageable than a hit on the cable. I would take these kind of things very seriously.
Michael. It's a moving target. Prevention's better than cure. We've been hearing a lot about prevention. The only person who's actually come up with some solutions for the cure is Jack, with his concept. They're interesting enough, I just picked up, and Henrik can probably know more about this than I do, that, not Henrik, Jacob, that NKT have just repaired the Beatrice offshore wind farm cable. So combined with the other projects that NKT have done, obviously there's a learning curve there, and they know how to do it. Do they share that information? Can that be rolled into a overall scheme that everybody benefits. With, I'm just looking at all these cables that you got on the chart down there. Hell of a lot of cables there. And when they go wrong, whew, a lot of money gets lost. And I go back to what I said in my paper. The untalked about factor is the business interruption. As we rely more and more and more on power transfer, the problem is going to get greater.
Okay, thank you. It's for me, it's a little bit different. It's what we saw the last 2 years, especially after the Ukraine war started, is that a lot of the Russian vessels were sailing up and down the North Sea, trying to detect the cables, etc., etc. While, from my point of view, if you have a map like that, you know where they are. And if you want to repair one, you get your route position list from the owners. You know exactly where all the infrastructures are. If you do a new installation, you get the data. So it's not that difficult to get the data. So I don't see the need for those vessels, but it's the politics who are talking about it. And I think that even like what happened, of course, in the Baltic with the vessels dragging an anchor, yeah, in the end, it's not proven it was on purpose. You can doubt it. It's the Russian shadow fleet, but they couldn't pinpoint it. And I've been involved myself in various occasions that a cable was hit and damaged by fishing vessels or even dragging anchors. And with the IAS data, they could pinpoint it to the vessel and could collect the money. So that's nothing new. But we're all talking about lifetime of the cables, etc., etc., etc. And it's also very important, of course, to have it secured. But what are the real good measures? Because I've heard a lot yesterday and today. But still, it's measurements, it's repair, it's measurements. But you can't ignore that it will happen. And how's the view on that one? Because there are measures, of course, we can do. We can put a hell of a lot of money in it. But is it always cost benefit to do all those measures?
I think one of the factors that comes into this is exactly what you were saying. We've heard a lot about predicting and preventing risk mitigation. We've not heard much about what do we do with it. It's going to happen. How are we going to go forward? My view, when you take in the business interruption and you take in the national, and I'm not sure if this is political or if this is investor-driven, but we need a similar club to the North Atlantic Cable Agreement for telecoms, that somebody actually says, right, we'll pool a bit of money together, sort out the cable companies with all their joints, so we've got a common form of joint that can be used. Somebody pays to have a certain number made, and they can be strategically positioned where we know they can get access by a cable repair facility, and the sort of thing that Jack's trying to put together is paid for by some sort of insurance policy. Not necessarily NC, but there's an agreement to do it.
They would like it. But from a cable owner point of view, because that's what I found out during my lifetime in the cables. In telecoms, it's easy. All the developers, all the owners are working together. You have joint industry projects, you have the universal joints, you name it, it's all, it doesn't matter which cable you use, it's always fitting. If I'm looking in the power cable world, energy world, they hardly talk to each other. The cable owners hardly talk to each other.
Oh, now I'm not in the technical department, so, but
Even better.
yeah, no, but I mean there are cable forums where I do know that our technical colleagues meet colleagues from the other HVDC infrastructure owners and colleagues and peers. So I do think that there definitely is those kind of collaborations. I think they need to be better. I think that what we see in this action plan for cable security, that we need a spare fleet, so to say, so a spare part fleet, but also joint fleet. That's something else we can discuss how that would be possible. But to go together and pool that, I think that's something that would be interesting for the future. That not necessarily everybody sits on their own spare part warehouse, but actually that we could have a joint one. To some extent, then the technologies are different, so you need to pair up with your friends, right? And if you sit on old technology like we do, it's more difficult, but still, looking ahead, I think that's a good idea. But then also linking to what you said before with, well, you don't know if the vessels are there intentionally or unintentionally, but you will find them and you will collect the money. I think that we also heard earlier today that that's actually not so easy to track down the vessel. So we have some experience in this, being in operation for 30 years. So tracking down the vessels, we managed to do in all cases, I think. But then, what we also heard earlier today, there is a cap in maritime law on how much damage you actually get compensated, and that's very, very low, unless you can prove that this was willful misconduct. Yeah. So yeah, and that one is very tricky to prove. Even the most clear case is not evident that you will win. We have one of those. And also the fact that the ship owners can drag this out for forever. So the case I'm thinking about is a cable damage we had in 2012. We have gone through all the Swedish courts. We are now in the Netherlands trying to actually execute our claim, because we won in all the Swedish courts. So 2012 this happened, still fighting to get the money, and it's just a fraction of what it actually costed.
I agree on that one. It's very difficult to get the costs being paid. That's why we have insurances, but they don't like that anyhow. But for shipping, and when you hear all the stories and I'm quoting the news stories, is that there's a lot of things happening, and there's a lot of mayhem indeed about the one or two or the three which are coming up, while including the ICPC has said it was 150 to 200 cable faults per year. And most of them you never hear of it. Now you hear a little bit in here, okay, it's power cables, it's a pipeline, it's a little bit more strict. Pipelines being damaged on purpose or even not on purpose is not very nice for the environment. Power cable, it's a little bit less, but it's taking a long time to repair. But how is the view in general? Because ACMA, you mentioned it already. I would like that. I'm familiar with it. To have it in Europe, in the wind farms and even in the interconnectors. First of all the developers and owners have to get together to pay for the standby costs of those vessels. But there could be another way to do it as well, and is that if you're doing the installation of a wind farm and there's a cable break, you just stop working and do the cable repair and come back. It's only costing a very limited time. Some say 10 days, some say you have had a presentation last year of 24 days or something like that on the BritNet. It's a lot of preparation, but the actual repair with a vessel is only a very limited time. And if you can pull out an installation vessel to do the repair, it would be much more economic. But you need the willingness of the various developers. What's your view on that one?
I'm not a developer.
You've got to get them all to agree, first of all the developers. Who's going to do that? Who's got the power and the muscle to knock their heads together and say, listen, this is the only way we can all win on this. The only comment I would say about pulling off a vessel that's on an operation is the old factor of the weather, the timing, that you pull it off at a valuable time when it's getting on with its job, so to speak, and then it comes back, weather's changed, it gets behind program, who pays? Particularly if it's on a sort of fixed price contract. So there's a lot to be considered with that. But if the priority is to keep the infrastructures that are already in place working to keep the lights on, which is what it's all about, then someone has to really grip it, knock heads together and make it happen. And who that is, whether it's the government, whether it's a new body set up, and I certainly don't want to see yet another Quango set up, a European Quango, which they'll be moving from Brussels to Strasbourg before they even start making a decision. Somebody needs to grip it and lead it. Government organised. Oh, you're suggesting you will?
No, I'd like to comment to this because there's been a lot of discussion that I feel are discussions we have had. I actually, a couple of years ago, I tried to push for something like shared spare parts with my colleagues at Prysmian. Because we're competitors, we had to do everything above board. It took us about 6 months to send 3 emails because it had to be reviewed and censored and edited by 2 different legal teams. And the reason we had to try to do it together is because when you spoke to potential customers, they would all say, well, I'm fine, my cables are working, I have my spares, I'm not paying for type tests. And you're not coming near my asset with components that are not fully type tested. This holds true until one of them breaks and they don't have spares. Yeah. The next challenge is we suggested exactly the setup that we have in telecom with Acme to have a vessel on standby and share costs. And there was also objections from customers. Well, one vessel is not enough. What if somebody else needs it when I need it? It's like, yeah, you can have rules, then you have to wait. Yeah, but that's not good enough. It's like, yeah, but now you have nothing. How is that better? It did not resonate. So it really takes someone like Jack now to take the plunge, take the risk. And when you started, Jack, with the Curo, I actually gave the feedback and I asked, what makes you think you'll be successful? Because there have been companies that tried before and did not succeed. And they took some financial hits.
Global Marine had a barge available for 2 years being idle for repairs and was never ever used. Jack, go ahead.
There's a lot to say. We launched our Think Prepare to Repair campaign 10 years ago, and it was very well attended. There was lots of people there. Everybody's very positive, including insurance, and nothing happened. Last year we launched the Curo, which was a step in the dark, I have to admit, because we weren't sure. You can't really say what the market is. And it was up till now, she has been very, very busy, and one of the reasons why we're now launching the second vessel and a mobile spread. So I think things are happening in the market, but the thing we shouldn't forget is that the offshore wind or the offshore energy market is very much money driven, even more so than telecom. And you can't just have standard cables because the impact of a different cross-section on a whole wind farm or an export cable or an interconnector is enormous. You're talking not a few hundred euros or pounds, you're about millions. So as a result, we continue what we're doing as an industry, and we seem to accept that if there is a failure or a break, we pay the cost, or the insurance pays the cost and we pay the premium or the excess deductible. Now, as long as the insurance premium and the excess deductible is still acceptable to the developers, cable owners, and contractors, we will continue as we're doing. Nothing will change. Because there is obviously not sufficient monetary incentive to change the world. And that's as simple as it is, I think.
Yeah, I'm not an electrical engineer, absolutely not. And I've always asked myself when buying cables, when I was still in Van Oord, why is there no standardized cables? Why is a wind farm with a 33 kV or a 66 kV inter-array, but even the export cables, why should every cable be designed from scratch and completely new. And I have to ask a cable manufacturer for that one, because I still don't know the answer. I know Nexans has, Ørsted has tried with Nexans, but they stopped with doing it. And still now it's new and new and a new design. So you never get a standardization in place for that. So for standard joints or whatever, makes it very, very difficult to get similar things like the ACMA. Maybe you would like to come in.
Yes, I mean, we saw some of the presentations, right? And what we today call 132 kV array cable, that used to be a sizable export cable 10 years ago. Yeah, and besides that, in those array cables now we leave out the lead sheath, because who needs that, right? Now it needs to work with water alone, and ideally leave out the aluminum laminate as well. You know, have them pass all the tests, reduce the insulation thickness because that's too expensive, and give guarantees they will hold 50 years, right? That's, the technology is still progressing. We want to build bigger turbines, bigger wind farms, further away from the coast, reduce losses. The only way to do that is to increase the conductor cross-section or increase the voltage. Usually we'll do both. And that's where we are, right? We can try to form groups, like was said. You can fix a cable with a larger conductor cross-section, a higher voltage cable. That can be done. You need to be ready for that, but you still have a lot of differences, like mass-impregnated cables on some interconnectors, XLPE of different manufacturers, AC cables of different manufacturers, single-core designs, three-core designs. There is even, I think, a 2-core DC cable somewhere. There is still oil-filled cables, flat-type cables. There is so many different cables that it's incredible. And we see it also onshore. It also happened historically onshore. We also have those variances. It takes a long time and a lot of experience to find the solutions that work very often, that are very reliable. Yeah. Okay. We're starting to get there in offshore, I think.
We see a lot of measurements ongoing in the industry as well. I mean, measure and measure and measure, but are those the solutions? Yeah, if I ask it to Dan or you, Etienne, you will most likely say yes, you have to measure and measure, and we heard the last presentation as well. The more you measure, the more you know, but do you really improve things with that? If you can't avoid damage, you hope to avoid damage.
Okay, just one. At least if you monitor things, you can also, if you see a cable failing or deteriorating, you can start planning things. And a preemptive repair in the summer costs about 50% or maybe 60% of what it costs in winter. So I think it's definitely worth monitoring cables and making sure you know what's happening with the cable during its lifetime. So I think that's a relatively cheap way of at least reducing cost and being in control of your cable system without the light going out because it pops at an unexpected moment at the height of the rush. So I definitely think there's a good need for monitoring and measuring. But yeah, cables will still fail, not because they're not or they're monitored, but because they're either designed wrong, they are manufactured wrong, they're installed wrong, or they're damaged by somebody that doesn't know what they're doing, or maybe know what they're doing.
To be quiet, sorry, Dan.
So you say that we can't prevent it. Yes, we see the slides that say a lot of the damage at the minute is installation damage and whatever else. That's not the topic of this. Was really on security. Sure. We can stop that. You know, the two instances that we had in the Baltics, that could have been stopped. Those vessels dragged anchors for what, 200, 300 kilometers, and you're talking 70, 80 kilometers between the first impact and the one that really did cost a lot of money, the gas pipeline or the. What's to say we can't stop that? If we'd seen the first one, we'd stop it. Or you'd prove beyond a shadow of a doubt that it was absolutely deliberate. You'd be screaming at that tanker or the container ship for an hour and a bit while it's dragging its anchor. And what, ignoring you, not doing anything? Well, that's a vessel under distress because it's actually not responding to any thing. So you actually have other vessels that would have to come to its aid.
To be quite honest, if I was going to damage cables, I would not do it in the same way to drag my anchor for 200 kilometers. I know where the cables or the infrastructure is, and I drop my anchor just before I drag below it and retrieve it and go on.
And then
you're too late to notice.
Yeah, but you would see that as well.
Yeah, but your cable is still damaged or your structure is still damaged.
Yes.
And that's something, but
we would have still the damage that we've seen would have been stopped. So now you get on to the person that actually wants to specifically damage an individual cables. Well, if you're picking and choosing cables, that's an act of war on a completely different area. But the incompetence or grey zone, get rid of that. That's the start.
In the Baltic, initially it was called an act of war as well, huh?
It's incompetence.
I was just going to add on that. I mean, what you've just said is correct. When you see the way they keep crashing into each other in Straits of Dover with our modern technology, you think, what the heck's going on? What was the heck going on when this recent Baltic failure happened, when I think it was 30 kilometers that tanker was moving slowly, dragging its anchor? Why didn't somebody see it and stop it? But that's not the problem. The problem is you need an overall group that grips this. Now, I'm going to go on a parallel here. I studied life in commercial diving, and with the support of the oil companies, when everything was being done by divers, before the ROVs took over, we set up what was known as the AODC, Association of Offshore Diving Contractors. And that was driven by the commercial diving companies who were all in competition with each other, but it was also supported by the oil majors and the government, where if there was an incident, it was a problem, everything got dropped and we went and dealt with it. Because basically we were losing a lot of divers through accidents, through things going wrong. But the AODC answered the call. Something similar with infrastructure cables, where there's a body that runs it, controls it, grips it. We can then start maybe getting some solutions through. It would be all the cable manufacturers getting together, and they have to get together. There's no point in them saying, I'm keeping my secrets from you, I'm not going to tell you what's going on because I want to win the con. There's got to be somebody who grips it. And I think we're looking at the first chairman sitting over there with a beard.
And anyhow, we're almost running out of time, and I don't want to stop anyone from going home at the moment. It's one thing, because we're talking about physical damage to the structures, to the cable structures. I think, and it was mentioned already a little bit, that cybersecurity, with the hybrid war ongoing at the moment, a little bit already starting, is much more effective in the end than trying to on purpose damage an infrastructure. I heard it yesterday because I think everybody saw the news on Cloudflare that it was out of service for the whole day yesterday. One of the biggest servers seems to be in the world. I got a message last night from my wife, and she said, okay, I couldn't work today because I couldn't access my computer. And then you're getting, if that's for a very short period, it's very nice. But I can tell you, when we lose all the due to cybersecurity and everything goes black, then all your measuring systems are gone. Everything is gone. Nobody knows anymore what's going on. And that's much more a danger, I think, at the moment than any physical damage. And I think we should sorry, but it's just the truth. It's Are you make comment on it?
No, I'll leave it there.
Good. I think we concluded. I would like to thank the panelists. Sorry for the other three missing. I couldn't help it. But anyhow, thanks a lot for the end of the 2-day sessions, which was very much of interest, but also a little bit tiring.
And I'm just going to finish with one thing. I picked up that Rene said he's just given his last ever paper here. That's not going to happen.
It's absolutely going to happen. I'm not going to give any presentations anymore. Panels, okay, no problems with that, but I'm not going to do presentations. No way, Michael.
Michael, just keep saying rock dumping, and he'll come. because he has that one he has in his in his nightstand waiting. The what is it? Back to
Lights go out. Back to the Stone Age.
Back to the Stone Age and rock and roll. Yes.
I can come up with 30 different presentations which I gave throughout the year. So
Exactly.
don't get me running.
So we can get you back. We'll find a way. But then, thank you very much for the discussion. And congratulations to everybody that made it this far. Yes, I think this will not be the end of this discussion. We'll continue offline a little bit. But for now, of the official part of the conference, this was it. So thank you very much for joining. I hope you learned something and that you'll retain some of that information with you and take it to your colleagues, and also that we'll meet each other again in the future. Please remember to provide feedback if you can. It's highly appreciated. It helps the presenters, helps the organizers improve future conferences. And I hope to see you all, where is the next one? In April in Amsterdam. Yes? Perfect. Okay.
And just a few last words from me. I would like to thank all the speakers and of course Jakub for his amazing chairing of the conference. And as he said, hopefully see you all again in April in Amsterdam. You have my contact details, share the feedback, any ideas, whatever you like. Thank you and see you next year.